Okay, it's currently connected to this one right here when it's on. So
Okay.
we can put that in there whenever we want to.
Yeah.
I guess we and then it's streaming. We'll hit record at 9:50. We'll hit record.
Yes.
And then, yeah, your room looked great. Stop and start between presenters. Everything was good. Streaming.
Amazing.
Okay.
Cool.
So far.
So we go over for the meeting, right?
Yeah. It's gonna replace this SD card real fast. Then
Good morning. So this one is connected.
that one's connected, yeah.
Right.
Yeah, I tried to set up all the rooms with one connected
Uh-huh.
and tested, and the other one had to be reset, so.
Great. Okay, I'll head over to
Okay, yeah, I'll be right behind you.
Yeah. So, where is the? How should I join the? How should I join the session? Kind of there, choose a enable the speaker. Or can you help me with the laptop, please?
Well, with the laptop. And for the video.
Yeah, I just pressed the join the session, but maybe it's
This I don't know. Also none of my.
so. What? You don't know.
No, I'm sorry, I don't know. I'm only for the video. And there's
Okay.
supposed to be a sound guy, but usually how it happened yesterday.
Then maybe the sound is separate. So I'll be like this, and
So you have the notes here.
yeah, I mean the questions. Oh, I should take the presenter. Yeah, I think. And where is the? Someone should upload the talk.
Okay.
That was the concept. I mean the slides.
Yeah.
And apparently,
I don't know who will be here because yesterday there was always a guy here for.
yeah, I can try to find them.
Yeah. I need to set up the cameras, but
Okay,
I
okay.
can.
I'll try to deal with this and
Yes. Okay.
go ahead with your.
This command knows this mode. The frequency there is defined somewhere. Or it's really okay because I have 10 megahertz, but pretty much the field. There is no much deviation. I think it's really specified.
Display makes up with something faster. Displays makes up with something faster.
Yeah, but in my office, 10 megahertz. So that should be okay. Yeah, but yesterday it was I might think that I might not have access to it.
So does it work? Yeah, works. I mean, the slides are there, so slides work. So the video and the sound. This is not mine. Yeah, guys, I mean, this room is quite weird. So if anyone is not shy, I encourage to come closer. But if you are shy, stay away.
Just to be sure that the shy doesn't get any blood.
Gut, wie geht's?
Ja, alles bestens. Und bei dir?
Ja, auch alles gut. Ja. Gar nicht vorgestellt. Der meine. Die Runde, die zwei Räume, dann bin ich wieder weg.
Hey. to go. Oh, hey, I was waiting for you. No, I'm joking.
Maybe that you consider that's why I don't show my rubbish.
We still have 2 minutes.
French people are listening. French people.
Is the mic working? Yeah? Good. All right, let's start. So, welcome everybody. This is Device Both. I have few slides here. I have few topics which I would like to discuss, but I'll be happy if you also come with some topics, if you have. We have here also second device maintainer, Connor, and Rob is probably sleeping because it's middle of the night in his case. Yeah, come on in. So what I would like to talk, there's a topic of common board ID property. This came from Qualcomm. There's also configuration parameters. This came from NVIDIA. Maybe a few things about DT schema. And I want to also talk about the usage of DTS in other projects like U-Boot. And the remaining topics are just, in the case if you don't have questions, we can talk about them. But if you have questions, we will skip them. Up to you, kind of. So the common board ID property. So this came because the compatibles are not enough, and comparing strings is too difficult, and EEPROM is too small to store the strings. One of the solutions, I think Simon Horman mentioned it, that the fit image supports comparing strings, but it turns out that at least for the Qualcomm, they just have too many strings, too many compatibles, too many different boards or small variations, right? So they have a downstream property, actually not, it's even in upstream, which are just integers. Yeah, there's a question here. Can you pass the mic? Yeah. Go.
You can store, it's just a comment. You can store device tree overlays in fit image as well, so you can have like a base DT there, plus a bunch of overlays, and you can have the bootloader apply the right overlays on the base DT and boot Linux with that. This is actually what we do because we have a baseboard with like billion variations. It's logistically impossible to support or to actually have billion device trees in a fit image.
But how do you select the overlays? How do you apply them? How do you choose which overlay?
We actually have a U-Boot script which detects which board it is and then selects the combination of base DT plus the overlays which we need. the fit image can actually embed U-boot script and run that. So if you then have more variations, you can just replace the fit image, including the script, and cover all the billion+1 variations.
We did the same, nothing new.
Yeah, it's all figured out.
There's no register to read the chipset revision?
So maybe Bjorn, you knows exactly the hardware in case of Qualcomm.
So we can figure out the SoC, but then there is, PCB variations, and there will be peripheral variations with the customers. There might be second source components. So it becomes multiple layers of selection mechanisms. And the current scheme of having these 3 integers has scaled well for Qualcomm, but not for Qualcomm's customers. So there is, we are incentivized to come up with a more generic scheme there as well.
Yeah.
Someone asked for
Oh.
yeah, it must almost worked. So yeah, a few months or about a year ago, we dropped the really long compatible schema from the QCOM SoC. But I think that which encoded all different PMIC and all this stuff. But I think this can work as a schema for fit image compatibles, if extended. So it does not work for the kernel. It is not necessary for the kernel, but this can work for the fit image. So I support fit image. And earlier, I think we discussed if we can embed if we can get fit image wrapped into the PE, and then make not only U-boot people happy, but also the UEFI people happy.
Yeah, that sounds good. We just need an executable header or something. Some of you maybe have found the fit spec at Open Source Firmware Foundation or something. So a PR would be great. That spec includes things like SKU ID and something else. So it can certainly be extended to add more things. But what worries me about the combinatorial thing, I saw comments about there might be 1 billion different combinations. It's not so much the number of axes that you might imagine, it's how many actual things there are. Some of those things could be just, there might be 2 different PMICs, so that can have 2 different nodes or 2 different compatibles for the PMIC. You don't necessarily have to put that in the top level compatible. So I think, from my perspective, the fit compatible thing works super well. It would be a shame to throw it away.
The proposal here is quite flexible, so they want some sort of viable IDs for both of the SoC and the board or the components, and it's quite extensible up to different revisions, and the list can grow, and the selections allow quite a flexibility. However, still, of course, the question if everyone says, yeah, we use the fit image and compatible matching, then this might be the answer. If there are more users, it will be easier for the guys, because that's the answer from the teammate 10 years, please get 1 more user. There's that.
We have something similar on our board. We have this usual ID with product variant, hardware revision. What we see that I'm not sure if it would be covered here, that might be covered with a script, is that normally we have one DTB file that is compatible with multiple board ID or revision ID. That's because the differences are relevant for, let's say, the hardware, the actual PCB, but maybe not relevant, for the description that we have. Not sure if this would be covered with some sort of list, or we would have ended up having DTSI and 10 files just redefining this ID property.
Okay, so if there's any other user for this, please come up. If not, the answer will be fit image.
But with the fit image, then we store the selection criteria outside the DT,
Yeah.
right?
I think that was one of the issues that Elliot brought up, was that we don't want something external of the device tree to actually map a compatible string to one or more device tree blobs and overlays. Hard to maintain, and maybe not accepted in this kernel. It would be something like a YAML file or something under the device tree file.
Technically, the fit image. So technically, the fit image is a device tree itself. So the fit image is basically a device tree with long strings encoded in it, and the long strings are the blobs which you encode in the fit image. It just uses the inkbin directive of the DT compiler. So it's like a super device tree, effectively, which embeds device trees and overlays and the kernel image.
But the fit doesn't follow the bindings.
There would have to be a description for the fit image format, which has been long established anyway.
But the selection criteria you have into the boot script. So everybody's inventing their own
Boot script.
and its own selection criteria.
This is boot specific anyway.
Yeah, it's fine. Yeah.
I mean, the Borg selection criteria are hardware specific anyway.
Okay, folks, let's move on. One idea was from NVIDIA, I believe. So they want to have some sort of configuration parameters which are stored per, let's say, SoC, so in DTSI, but they are selected based on the board properties somehow. So they describe them as the timings, but they also mentioned that it could be more than only the timings. They look somehow like that. So this is the cover letter that this could be some functional speed of some bus, I/O controllers, or some signal timings, board characteristics, thermal characteristics. And they propose some sort of DTS looking like this. So this would be the configuration for the I2C, and depending on the speed of the I2C bus or some pin control settings, right, you choose this fast configuration or the standard configuration. Is this any of interest for other SoCs? Because here as well, we kind of look for second user, or this would be just come on, use standard properties or fit yourself.
Yeah, we used to have this, and then Rob said no, so it never went upstream.
Okay, then in that case, they should reach to you, and maybe you will be able to convince Rob together. But do you still use it downstream, or no?
I believe there is some cases where we need to tweak more than just the frequency of an I2C bus, for example.
Yeah. Behind there are some.
Does it make sense to change this on a board-by-board basis, or do you just have these two settings for the frequencies? Because like for PHYs, you have similar properties where you set the skews for the different lines, so you have the angle that you need between the signals, and there you change it on a board-by-board basis because it's layout dependent. I'm not sure about I2C if it's also something that's board dependent or just frequency dependent. So if it's frequency dependent, it should go into the driver, I think.
So I imagine that this is also board dependent.
Okay, thank you.
Whoa.
Yeah, so there are actually two different cases here. On the previous slide, you also mentioned fused values. If the values are fused, then I don't see a reason to put it in the DTS.
Yes.
And for the other parameters on the next slide, so you basically have two different configurations there, and then you need some way to select? Or
Yeah, I would need to show
board
entire source code. I mean, that's another point that I cannot here display, show everything, right? Because this is, I think, limited way. So I just abstracted some piece that the point of view that you just have multiple different configurations per different devices. So this I2C has some sort of fast mode and the standard mode. And this is defined per SoC, basically. So the different boards will choose different setup.
Okay, so this is different from calibration values. Because for this, you could just put some binary property in which is basically some list of bytes, which is similar to what you would put in a fuse.
Yes. I mean, it's getting similar to this point, but the binary values or the fuse values are quite not user readable, and I guess this is the point.
Yeah, that's more readable, but it takes much more space.
Yes. Yeah.
And fuse values, they're binary usually too.
True.
So this is basically, I work for NVIDIA, so we've been trying to, I was actually meaning to talk to you guys about this, because we really want to solve this problem. I hear this quite a lot, and we want to find a way how we can upstream it. And one of the things that we had considered was having a binary representation for this. But there's been proposals for this in the past as well, and they have never been accepted. And there were like, things like address and register address and value proposals and that kind of thing. So we're really just trying to find a way how we can make this work in some way. And if it's a binary representation, that would probably work fine too. We just have to agree on something.
Can you maybe explain why you need this?
Yeah, so the idea is that you have, like in I2C, you have these different bus speeds, and depending on the bus speed, you have to program different values into the register, and some of these are not directly related. Like, you cannot derive them from the frequency directly. They are like hand-tuned values that you have to write into those registers or register fields. And so as I understand it, there's a whole process where they qualify these values during chip bring up, and then they come up with these tables, and they're expected to end up in these registers to work properly. Yeah.
There are questions behind.
Sure.
Maybe.
We use the same thing for MMC, for example, where the tap delays describe at DDR50 how the timing looks like. Right now, the way that we have done that is to put it as part of the MMC node, and these are properties within the MMC node. But are they describing the hardware? They're not. They're actually describing the configuration parameters of the hardware. Pulling that out as a separate config property itself will be very useful. It'll be very clean to understand as well.
If I see this property correctly, there's, for example, clock divisor and so on. What will happen if I use device tree to configure some nodes for some specific clock, but it's not compatible to configuration profile which is used?
So yeah, the idea is that the driver would have to coordinate between. So you get the frequency from typically your device, your I2C chip is configured with the frequency, and the idea is that basically you would switch to that mode. You have the clock frequency of your block, and then you select the corresponding configuration for it. And there's perhaps some of these we could perhaps abstract in the like via a clock. Some sort of clock that we expose, but not for all of them. Then there needs to be software that coordinates between the actual clock, the frequency that is selected or required by the device, and selecting these options.
Yeah. So the I2C may be not the best example, because for I2C, it is not per device. You have the clock frequency set by the bus, or for the bus. So you can derive most of those parameters from the bus clock frequency, and you have to program it really once. And we had this kind of situation not with the I2C, but with USB, with the USB PHYs especially. And our engineers from Qualcomm tried to upstream different ideas, but we ended up with really just having the device-specific parameters telling the idea, fine-tune this named register to this value, So it tells us QCOM something tune equal this parameter. And more importantly, it's not a binary value. So on the right side, it's what's period? Is it seconds? Is it milliseconds? Is it microseconds? So we ended up insisting that the values there are either enumerated strings or they are just some kind of unit values. So please don't add raw register values into the device tree, because then for anybody else coming who does not have Jetson.pdf or, I don't know, Tigro.pdf, it is impossible to understand what's going on. So
yeah, this is I2C is just an example. We have this we need this for very different, like SPI and MMC, that kind of thing.
So some of this you cannot generate out of actual algorithms because you do characterization over PVT corners and temperature corners, etc. So it's not an exact science for us to put a timing value and be able to figure out what the register value looks like. MMC and probably many other interfaces are a candidate for that.
As I said, you have the base clock frequency, and that from that you can derive some of those. But if you have anything to override that, or if you have anything to specify the exact register value, then you also should use sensible values, not raw values. So that was my point. So if it is programmed in milliseconds, and if it can be 1, 3, and 10, then the device tree should say something MSEC. MS 1, 10, and 3, and this should be enumerated.
Okay, guys, maybe last question around here, and we move further.
So my understanding is that often this stuff is just stuffed into the driver as like tables of data. I see that a lot.
Yeah, we can't.
Yeah, usually like this.
We can't really do that because they are per board, so we would have to have tables per board, and then you can have.
Yeah, I'm not suggesting that, but I just like to compare it with pin control. For example, we have tons of data, and we put up with that, which I'd like to get that data into the device tree actually. Anyway. So,
folks, I don't want to interrupt the discussion, but I also have a few other topics to cover, and the slides are available. They're attached to the LPC event. To the session, so you can also find the LKML discussion there, or original thread, and join there, or just try it. Because I would like to also mention let me press, something which maybe you have concerns. So DT schema is quite tricky sometimes to use, and we know that, for example, the error reports are quite convoluted. And maybe you have other topics what could be improved, and just a caveat here that whatever you propose, maybe there's someone who will implement it as well. But are there any topics of concerns when you work with the schema and the bindings? Maybe more examples? I don't know.
The performance of DT validate is not at all what it needs to be.
This improved a few months ago, and DT binding check improved significantly. And Rob was saying that with the update to new JSON, it then decreased significantly. New JSON schema. So yeah, we are back to the previous stuff, but I understand. So anyone wants to rewrite it in Rust?
I'm supportive of that idea, but.
Yes, please.
Sorry, this is ancient history, but in Chrome OS we had a validator for this written in Python, and I did actually, it uses the DTB. I did actually show this, I think, to a couple of people many years ago when they were starting that up, and they said, no, we don't want that, but it was super fast. So, the reason I don't like the JSON validator is its error messages are just, it's like C++ times 10.
So we do have a proprietary JSON format for another project. And there's a schema validator for that as well. We had a similar challenge in terms of what DT validator is facing. The solution that we had done in our validator was to create a threaded solution. But it is a little involved, doesn't work on all operating systems, which is an option, if that is interesting. If the community is interested, we can put a couple of our upcoming interns in future on the project, if that's interesting.
Yeah, I think what can be improved too is, when we have blah, 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 DS, blah, 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 cells 3, impose a const 3, there is no description of what we have to put as argument when we use the p-handle. We know that we have to put 3 integers, but what are they? For interrupts, for instance, we have some standard properties, the interrupt line, if it is a rising or falling edge. But from other part, we really don't know what we have to put as parameters. So maybe where the dash blah 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 cells is defined, we can have also the description, the exact parameters we have to put.
So for the case of the p-handle array, so the p-handle which takes the arguments, we usually ask to describe it, and then you have a syntax where you have the items, and you list the items and description. One is the p-handle, second description is, I don't know, some file mode, and the third one is register, offset, whatever. So at least for the syscon-like p-handles, we really enforce it and ask for it. And for the other cases, I think because we ask, so maybe just the contributors should do it.
Yeah, like I think most of the standard ones, like things like PWM cells and all those, they're like defined in the either in like DT schema itself or in some like common schema in the kernel, and they're not described in any of the actual controllers that have the property in them. So like PWM cells, clock cells, all of those ones, those are never described, even if the syscon ones are. So.
Does anyone would benefit from more examples in the kernel, how to write some certain things? I don't know, raise your hand if you like more examples. Okay, few hands, so not that terrible idea. Question? Comment. Can you pass the...
Yeah, I think it was told already several times, can we have some HTML representation of schemas that we can point people to? That would be really nice. And
it's doable. You can create big PDF out of it. Someone has to, yeah.
And Christoph, for every review comment that you give, can we convert that into an example?
Every.
There's quite a few patterns that we see.
If you're signing up to do it.
Well, we can do a few of them, sure.
Okay, the wish list is over. I hope that everyone knows that the Linux kernel DTS is now used outside of the Linux kernel. So just in case if you don't know, the U-boot took it some time ago. So this was work of Sumit Garg, and it's already released in the U-boot. So several platforms in the U-boot take exactly the import the DTS from the kernel. It doesn't mean that every board from that platform uses the upstream, because, for example, in the case of Samsung, there's only just one board using upstream, and a few others just use still the U-boot 1 style. But I think for the Qualcomm, we switched to everything, so all boards use the upstream DTS. And what does it mean for the Linux kernel? So I was also proposing that time that we should have maybe a maintainer's profile entry to kind of that each of the SOC which has such kind of external user of DTS should know that you cannot break the ABI that easily. I don't know, maybe other ideas, how to make the SOC maintainers aware that the AB break or AB impacts should be different.
A comment.
Oh, sorry.
Yeah. Yeah, just a comment regarding people using device 3. I remember a patch set from OpenBSD people trying to add a device tree, and after 1 or 2 attempts giving up and saying, oh, that's too hard, we'll just stay with our patches. So maybe this can also be included into something that we can improve, because we have our own ways of thinking and doing in Linux community, but people coming from other sources or from other projects have different expectations and different practices, so we should be more open to them.
That's actually one of my next slides, that we might be accepting the DTS in the Linux kernel where there's no Linux kernel user of this DTS. And this might create weird feeling of people that we support that hardware in the Linux kernel, while that's not true, because no one ever booted Linux kernel with this hardware. Michal?
We are probably, so I'm planning on attempting to do the same thing for Zephyr. Try and use kernel device tree in Zephyr.
Trying to get them to use the same binding.
At least for my boards.
Wow,
I'm going to attempt. I'm not saying that I'll succeed. The thought philosophy in Zephyr is dramatically different. I realize that. The intent is to find where the deltas are, because there's a lot of software configuration parameter that they do use in device tree in Zephyr. The challenge is going to be, at that point, what is the kernel community willing to give, and what we will adamantly stand against. So this is something that will be very interesting to see.
So I've probably said this before, but U-boot stores some configuration in the device tree and needs to, and I wish that were allowed in the bindings. Zephyr absolutely does. And the reason, I mean, I was discussing this with them years ago when I was trying to get Zephyr in Chromebooks, that why they didn't use the Linux thing, and they basically said no, it's impossible. It's just too much friction. We'll never get it off the ground. It'll never happen. So there would need to be some give, and I think that's not something I've seen enough of myself personally. I'll give it back to you. Oh, I can't throw that far.
Wow.
Yeah, I think one concern, go back on a little bit on the previous slide, one concern that we run into is it's not always obvious when the device tree is binding change is causing an ABI break for other platforms. So I'm wondering if maybe there could be something added to DT schema or some other automated tooling that would say, hey, you added a required property, just be aware this is an ABI break, so we can automatically flag this sort of change to know when we might need input from projects that are affected by it.
I mean, it's tricky to make it automatic because when the platform is new, you are allowed to easily, if there are no users, you are allowed to change it, right? Add any required property.
And that touches on a similar topic, which is while we are bringing up a new device or platform, it would be nice to have some common marker for, say, this is experimental, and we have not yet entered the phase where we guarantee that we have settled ABI. Beyond that, for me, I consider the device tree in the kernel to be a convenience because most of the users are there. But I still think that the device tree should be seen as a separate project from the kernel.
And then another issue that's when we start using device trees, the same device trees in various other projects outside Linux, is we might have issues where we have the same multiple device trees showing different views of the same hardware from different, from the Linux capable CPU versus the microcontroller in the same SoC, and how do we, is it okay to have multiple device trees for the same SoC from different views, and how do we keep those straight?
So this is the system device trees, and I think this is already handled by the looper. So you have the device trees of device trees, basically.
But do you really want the system device tree in the...
They are not in the Linux kernel, right?
Yeah.
You mean that we can have the same hardware, really DTS for the same hardware from different point of view, or there are different parts of the hardware? Because usually CPU and the application processor and MCU are different.
The hardware will might, or in many cases, looks different from the different execution environments, and hence the DT should look different.
Yeah.
Yeah. So I guess the question is, should we then fall back to the system device tree and figure out how to make that work, or should we accept storing the different views of the world from the different execution environments?
Right, and if we're using something like system device tree, are we going to start putting system device tree in the Linux Git repository? Because this is sort of if we're using this for all the different projects, this is the source of truth for the system, as a whole device tree, right?
Yeah. Go ahead.
Yeah, so going back to the stability problem, so Barebox has been using the upstream device tree since it was since it has device tree support, so like, I don't know, 8 years, 10 years. And it breaks all the time, and it's not for new platforms, it's for old platforms. Sorry, but the TI guys really like to change their device tree all the time. A simple bus needs to become a simple PM bus, a network driver. Okay, we add a Neo network driver with a Neo compatible, switch it around, and all the time it keeps breaking. And I would really love that, someone enforces the compatibility of being able to boot an old Linux with a new device tree, or like an old Barebox with a new device tree. But all the focus is on a Neo kernel being able to boot an old device tree, and never the other way around. So I really like that U-boot also now does it for some boards. So it breaks more people, and there is some pushback, because I have no statistics, but I think it might be half the regressions we have in Barebox are device tree related.
No, that sounds bad.
Yeah, because it's every sync. So we sync with every RC, every kernel RC, and it keeps breaking all the time for various reasons.
So the ball goes to TI.
So yes, we did break backward compatibility in a few instances, but only when we are forced to. I would have, sorry? Yeah, so yes, the things have settled down at the moment, but again, this is about, there's a philosophy that we have saying that DT is completely an ABI, and there is another philosophy that assumes that DT is something of a hardware description whose definition we learn over time. So this is a constant conflict that we all have, right? Now, what's the right balance for it is that if I knew, for example, Barebox was using the system device tree, the kernel device trees, I would have been testing that as well. Today, I test both the U-boot changes and the kernel changes, and I do test backward and forward compatibility in my testing at least. So if you're seeing specific instances, let me know. You can look up the maintenance file for my name, or any of the TI guys know. We'll take care of it.
On this topic, one recent example from a TI platform, just by chance. The PCIe driver for the newest platform is implementing the reset of the PCIe with the wrong polarity. So after the probe, they assert the reset instead of releasing it. Solution, the device tree are defining the polarity of the GPIO inverted, okay? Now, I personally spent 2 days on that because it was a bring up of the new hardware, so I blamed all of you guys. And now, what should we do? I pushed a patch, for changing the device tree and the driver, okay? And this is going to be an ABI change, right? It's clear. I'm changing the logic. And not sure how to move forward. I am fine because now I know this.
So DTS should be here correct, right? And it's just the Linux was buggy. the Linux drivers did not respect the polarity, or you changed this in the DTS? Both were wrong.
I mean, it's working, so the driver is driving the GPIO the inverted way, so asserting the reset when you should release it. And to make it work, who did the device tree just defined in the polarity of the GPIO like there was a knot in between, okay? But there is no knot in the hardware, believe me.
Yeah, that's a common issue in the drivers.
This is something that can be solved with just better documentation of the binding, so you didn't spend days investigating why it was backwards, or like, I guess the question is like, how accurate does the device tree have to be compared to what is the requirement for stability? That's your question, right?
I mean, the problem becomes if you're sharing that driver with future platforms, because you don't want to inherit that problem. Otherwise, we could just ignore it, just state that this DT is wrong, and it matches the driver. But then when the next platform comes, you don't want to inherit that inverted bit, so all future ones will have to be incorrectly described. But I mean, the way we do that on the Qualcomm side is that we get together and we sort of negotiate what's the risk here of, or what's the cost of breaking this thing. And as long as we're mostly in Linux, I mean, it's fairly easy to get the community. But the further the DT spreads, the bigger of the issue that would become.
There was a question behind.
I just wanted to mention there was when there was this discussion about board IDs and so on, we talked about backwards compatibility, and Rob mentioned that he is working on a tool that inject in digests device trees changes, so the old device tree, the new device tree, and the bindings, and tries to flag stuff that might be break the compatibility of old kernel or bootloader with the new device tree. On the barebox side, we have also been working on something like this. So DTC now has support for minus big L, I think, capital L, I think. It adds local fix-ups, so you can have p-handles in the device trees. And the idea is that when we have the p-handle information in the device tree blob, we can more easily do a diff over the device tree blobs, detect all changes when we do an update, and then we don't match against the bindings, but we try somehow to find out which properties are barebox matching against and which compatibles, and then we flag it for manual review. Because a lot of stuff is, okay, we are matching against this device tree node, but now it has another compatible, or or something like a quirk has been moved, you add a new quirk property with a new name, which is a superset of the old quirk property, but the old quirk property goes away. So this breaks the USB driver, for example, and that stuff would turn up in such a diff. So I really think we need better tooling support to be able to detect these breakages.
Yeah, nice talks. We still have 5 minutes. So, by the way, are there any unrated questions? There's something.
Where?
Just a really quick comment. I think some word should be said in defence of ABI breaks. If you have a really hard policy of never ever being able to do it, it does create potentially a lot of code and a lot of problems as well.
It does.
I can still go through my slides, or if you guys want to ask something to Tyers. Oh, there is.
Yeah, short question related to your U-boot and OpenBSD and all this. So, is it a time to think about moving? Yeah, I see a smile. Moving device trees and maybe the schema out of the kernel tree.
So the answer is as usually, because some people bring it for a long time. For the bindings, no, because if you move the bindings outside of the kernel, you lose the exposure on the review. So no one will be looking there, and we need the biggest amount of eyes from the, let's say, people from the subsystems to look, to review the binding. So the bindings should stay where the most eyes are looking, which is the kernel. Now about the DTS, this could work. On the other hand, we already export the DTS. There's a repository which has all the DTS dumped per every kernel release. So Now the question whether you want to move the development there, or maybe still it's better to have the development with the most eyes. Will you be looking at different projects to perform reviews on DTS?
Or if it ends up on the same mailing list, then why no? So but that's maybe a question not to you, but to the SOC maintainers.
Yeah, that's a point. Yep. Oh, there is a SOC maintainer there.
So we've discussed this many times, and we've tried many times. So far, we've always failed because, like, I at some point I had another tree on devicetree.org. Well, that I think didn't get used much, and I lost interest in maintaining it because the people that asked for it didn't need it anymore, and it died down. So we had the plan to move it. I don't see a strong reason to try again at this point. I think what we have is working well enough. If there were major problems with it, we could move it.
The only problem was this OpenBSD. The only problem was this OpenBSD person who, I don't remember the name, who tried to upstream a patch and who failed because we are way too strict for them.
Yes, and there will always be problems whichever way we go. Maybe we should have been more welcoming. I don't know. It's
that's fair.
Yeah.
If I add my 2 pennies to the comment regarding moving out the DTS out of the tree, there are several reasons to not to do that, because first of all, this is a very good tool to remove the rotten code, right? If there are platforms which are not supporting or not following with the DTS, they are finally removed from the kernel. So if you move it outside of the kernel, then nobody would care. This is one comment. Second comment is that this is a very good motivation for the customers to upstream their boards, because there must be in the Linux kernel, because they need to be reviewed by many people, etc. If you have separate project, just dump it. Maybe some people would look on that or not, but you will have 2 parallel development ways for kernel drivers, and then matching device tree.
Okay, so quick comments regarding the device tree definitions, which are device tree document bindings and device tree source files. Just a week ago on the K-Summit kernel mailing list, I have discussed this with Rob and Connor. So there are some great points pointed out there. So if you're interested in the details and what is going to happen, I also want to modify the documentation on the device tree and what it is about. Is it going to be the device tree repository? But Rob's point was exactly what we already said here. A lot of kernel drivers, they wouldn't be bothered to work with another repository, so it should stay on the Linux repository. But I still want to push for complete autonomy of device tree document bindings. So yeah, please read the please read the communication on the mailing list K-Summit for what was discussed, because there are great points made there.
And with this, we are actually past the time, so sorry, Bjorn, because the next session should start. So thank you very much for coming. I'll be also here, so. Yeah, that's the next session. Yeah, let's go outside. I mean, let's keep talking. Next one. Next one.
Can somebody help me setting the slides? Anybody knows how this is supposed to work? The slides? How am I supposed to? I have them in there. This is the other session, so I guess I need to go to some other session, right?
No, that's all right. You need.
Okay. I'm glad I had you here.
Got you back.
Once more.
And yeah, you've got the left and right there, or you can select a specific slide.
Hello, everybody. So I guess we can get started. So I will first go quickly through all the questions so we know what is in the agenda, and then I go back and we can spend as much time as we can on what we care most. So well, we can start right away with this one. We know that several vendors who do accelerators have tried to upstream their own drivers, and for different reasons, I guess, they didn't manage. They normally stop quite early in the process. There's in the slide some examples, but there's more actually, which reach the mailing list, and how many there are who we don't know about because they didn't got out of the company. We just don't know. But people are having trouble, but there's interest. So that's really something. How can we help them? Are these technical problems, community, or is it just about internal company matters, lawyers, patents, that kind of stuff? I don't know. Okay, so this may be a big one. I don't know how much can we do from the kernel side, but well, this is quite important. GPU drivers have that, and that plays quite a big role in how the kernel drivers are maintained, because if we have a common user space API, we can have common expectations from the drivers. We have that for the graphics, we have that for OpenCL, for compute in general. We don't have that for machine learning yet, but well, there's some consolidation going on very slowly, and the divergence as well is still on APIs, frameworks, more likely, and there's some attempts on some APIs. We can talk about that if anybody has more information on this, and maybe we can help with that, because if there's no open source drivers, then the community can do less at the higher level with the APIs as well. There's less incentive to do that. Automated testing, well, everybody's talking about that at these Plumbers. Maybe we should as well benefit from that, and this is pretty much related to the user space API, I think, because for the graphics people, they have this API so they can use the test suites for the conformance of the drivers to make sure that they don't stop conforming. If we had that, we could as well do something similar. We don't have that API yet. We will have to do something else, I guess, for now. User space. So I'm the author of 2 drivers, and both of them have the user space portion in MISA, and I try to reuse as much as possible from what is already there. The other drivers in mainline don't use MISA. Each of them have their own completely different user space. I guess they will have different approaches to the common challenges that the MPU drivers find. Maybe it would be good to have some consolidation at some point on this. I have plans to work on more drivers, and I will be doing those in MISA. So, yes, sorry, before. There's this virtualization thing. There have been some research attempts and fixing that with Virtio or something. Well, we can talk about that if anybody has thought about this before. But I see 2 approaches. One is that from the VM, you lower everything and you submit separate operations to the host and then that's accelerated on the actual hardware, or you send the whole model, but then the host has to figure out with the resources it has, and then probably if it offloads to the GPU, then it won't be using Virtio GPU anymore. So you lose some abstraction from the guest into the host, and then as well for the CPU, it could be running on the guest, but if you send the whole graph, then it will be running on the host. So there's some downsides there. Let's see what ends up happening here. And there's tooling in general. Most importantly for me is Perfecto. We use that on graphics drivers. Probably people haven't seen this before, but you have a timeline and you have boxes that tell you what is happening in different places in the system, what resources are being used, might be blocking, how long stuff is taking. We can have some assistance from the hardware. We normally have a way of figuring out timestamps for different phases going on in the hardware. And well, you can also check memory usage and other things like interrupts. Firmware-mediated IP. So some of these MPUs, all of them have some front end that process the ring buffers or the command stream, and in some of them that's made on silicon, and some of them there's firmware doing that, and then afterwards write the registers on the actual on the different components, which are not accessible from the CPU side. There's quite a few of them. Some have a DSP. Some of them have cores, like for example Cortex-M. Most commonly, what I have seen is that they use OpenAMP for that, with Virtio queues for the communication between the CPU and the accelerator. And I have seen that maybe we can reuse something based on Zephyr. Anything else, reuse OpenAMP. Most importantly, we'll see. Maybe even some common messages for the common functionality, memory management, for example. And yeah, so it could be interesting. Now, another question that was proposed on the mailing list was about interoperability with GPUs, but I expanded it a bit more here in case there's other ideas about this whole problematic. It can be about interoperability within a single pipeline. You have a lot of stuff, camera, GPU, painter, some compute maybe for something else, which is not a machine learning, then machine learning stuff with the MPUs, and then maybe we want to compress that and send that across the network, compressed already. But there's another aspect to this, which is that when accelerating the execution of a graph, you can see. You normally will want to use the accelerator if you can, but accelerator is fixed function, so a lot of stuff cannot be run there. So you can fall back somewhere else. CPU is there, GPU as well, depends on the use case. Maybe there's some challenges that people have found with the other drivers. I'm right now just focusing on those models that can purely be run on the accelerator, but I will have to get as well to some offloading. And I know that there's something that's bothering people. Even the closed source drivers apparently haven't fixed this. And this issue is that you normally have more than one core, and you can try to split one big operation and run that concurrently in different cores. That's normally not very efficient because it's the same operation, they have to access either the same weights or the same input data. So you will have to copy those to be accessible to internal memory of each individual core. So normally what is more efficient is to run different models in each core. And normally, nowadays, these systems will have different models doing different kind of stuff. And the thing is that how do you allow user space to say, I want to run on this core, reserve it for me in a safe way, because one model might be more have a higher priority, and the other one might be an unchecked and vetoed application even. That can be a security risk. There have been proposals of solving this with C groups, which have some security around that, for setting a mask of cores like we can with CPUs. That's not merged yet. So, and then as well to limit internal memory. Normally these cores have SRAM in there, some kind of faster memory. Maybe we don't want for a lower priority application to use all the internal memory, a faster one, and slow down the more important one. So it's a common thing which has been proposed for GPUs, and we would also like to use that maybe through the GPU scheduler. I'm quite happy with how I'm using it in my drivers, but maybe people have found some limits on this. Memory management, DMA because of the interoperability thing, will be sharing buffers with the different components in the pipeline, and then synchronization. There's always interesting stuff there as well for pipelines mostly. Yeah, and that's it. So I'm going back, and let's see what interests people the most. So anybody has an insight on why we are not seeing more drivers being merged in mainline? Not here.
It's not the biggest problem to solve for yet. Everybody's trying to figure out what to do with the software from the other side.
So like interoperability isn't the biggest pain so far. And I also think it's, if you look at what's happening in GPU and what's driving a lot of consolidation there, is that it's actually in consumer hardware, and users want to be able to use hardware more generically. And a lot of these are still special purpose or more on embedded, where they're used to doing custom builds and all that. So I think it's probably on a lot of vendors' lists, but it's not in the top 3 or 5 or maybe even 10.
Being a mainline.
Being in a shared code base, we shared infrastructure with others in mainline or elsewhere. It's also, and I guess this might be a hot take, I don't know if it is, but being in the DRM subsystem, you're certainly not making your own life easy when it comes to backporting to older kernels and stuff like that because of the refactoring activity there, and it's hard to just backport a driver.
Yeah, I think GPU vendors as well had to get past that.
Just on the I started seeing. Have you seen anything about what the Intel and AMD, because they are now going to be in consumer devices. The Intel Meteor Lake has the VPU, and I think the AMD Ryzen AI has some Xilinx-based core or something. I'm not really too up on it, but like their user space stacks are a horrible nightmare that you could never ship. Like, I think the AMD one, I keep forgetting the name of it. There's some license manager used to deal with in Solaris like 20 years ago, and when you install their FlexLM, it's still their SDK has FlexLM license manager errors when you install it on Windows. It's that like code base that they've been bringing along for 20 years type situation. Yeah, and I think there might be a leverage, as I say, on the consumer side now that they're actually coming into products. It's like, yeah, we should like maybe try and bring that closer to this as well with on the ARM side, and seeing if there's a common space that we can drive those vendors towards.
User expectations.
Yeah, because they have more user expectations. They actually want to use these devices for something.
Yeah, I don't really know about the cloud and the desktop or something in the middle. But on ARM, people are using it, and they are being beaten by the cost of drivers, and they have been asking that because that's something that they did for the GPUs, for the codecs, etc. And then now they have the NPUs, they want to use them, and they feel that they are back to 7 years ago.
What's your feeling on the user space side from, like, I know you've done the TensorFlow Lite API, but, is there a common adapter where you could make, like, to, like, get the basics of, like, PyTorch and TensorFlow Lite? And
Yeah. So I started with the TensorFlow Lite just because that's what the users of the NPUs that I was going to attack first were asking for. And then I know that PyTorch has made several attempts and having some way of delegating that to accelerators. And the latest is ExecTorch. And that allows for an external adapter because that's needed because I cannot put the same user space driver into each framework. And I cannot either expose an unstable API from Mesa so that I interact with that, right? So well, I can only really support frameworks which have some external stable API that I can plug into. And Executorch has that now, so I want to look at it further. It's via Python, which is exposed. So exactly how I will be doing that in Mesa, but I think it will be doable. ONNX, it's a Linux Foundation project with governance and so on, but I was told that someone inside Microsoft has a team looking into that. We'll see what ends up from there. And what else? Well, besides those frameworks, there's those attempts at having a common API for different frameworks like OpenX LA. That's more specific to companies or frameworks, but there's the MLIR, which is kind of a component that could fit into that, which is cool, but it's generic enough so that people can agree, but it allows for so much flexibility that there's not a single MLIR. They are dialects, and everybody can do whatever they want. Up to some point, that's also true for SPIRV, and we did it, right? With SPIRV to NIR, we support different flavors. Maybe we can have as well an MLIR to NIR inside Mesa. Maybe, so it's still a bit early, but I think we understand each other's needs, and there's several ideas, and every company is doing their own thing, but we in the kernel, I think, because we are used to work from different companies together, maybe we can help kernel and Mesa. That's it. So there was some question.
Yeah, question slash comment. So speaking as a reviewer for some of the Qualcomm patches, they did a good thing on one of the family of accelerators by bringing it in and having the really open user space. But for another family of devices, well, this is not strictly ML, but just more of the accelerator, more of the DSP present on the other side. We are currently being bitten by the lack of the user space, which they think about providing, but this will be a long path. And at the same time, we are slightly struck because, there is the DRAM XL API, but it's not really clear, and it is not that obvious compared to the GPU side how to use it, what we can propose, what we should be enforcing. So if there is something more generic, if there should be a generic kernel API for the accelerators, so if there should be, what are the guidelines for using DRAM XL? So.
Yeah, I would personally go with the same we have in the DRM subsystem. I don't see it any different.
Yeah, I think if you were in the camera talk, the answer to this, there is no great guidelines. It's like we want people to approach with what they want, and we will then discuss with them whether that will fit within the model. There is the reason one of the reasons we separated Excel from DRM was to give that space for someone to grow in, because we don't know, and I can't tell you, and you'll probably come with something and I'll go, that's not it. And then you'll try again and we'll go, oh, that looks more like it. It's going to be one of those conversations. I don't think we can decide. I think the DRM model works quite well for these devices, because at least these ones, most of them seem to look like the GPUs looked exactly the same. Like, they often put a queue in front of them. They often model pretty much the same. So I don't think there's enough commonality at the command submission stage, or really, maybe there is, but they may depend on whether they're firmware programmed or not. So
there isn't, but if we have a firmware and it's common, then we can agree on something there. At that level.
But so maybe we have to just get 2 or 3 of them and see. But and it'll be one of those cases again where we do the first one and then it'll be like, oh well, they got away with a lot. The second guy won't get away with as much, and the third one will probably try and force it into more of a better model and iterate from there. Because I don't think it's very hard to do an abstract and say we can come up with the answer. So I'm sort of happy to let the Excel have a bit of leeway and not be as quite as stuck. I still have the user space, stack requirement, but I'm not as like with GPU. It has to be Mesa. With Excel, I'm like, we can go a bit further. It's a flexible, but I can't give rules because, as I say, every time I give a rule, someone games it. So it's up to the community. It's up to try and get the people together and talk about it and figure it out. So.
It's a bit early, but I hope we'll get there eventually. Yeah. But if we have a way to support different frameworks, then we'll also have a way to support one API that may be the one actually, and if instead of Bain, we'll have been supporting it from the start already. So we'll have help for it to become the standard as well.
maybe not that many platforms. I think so far there's too many, when we're talking about the GPU or the accelerator here, there's too many use cases here today. One is still the existed, the graphic part, like the DRM, we are already using method. But there also, the other there's like, we talked here, the PyTorch, Tensor, this kind of machine learning kind of platform. Their use case is quite different. I'm not quite familiar with the graphic part, but for the machine learning part, they are more like focused on the memory, like because all these devices has big memory. So like maybe we can come to a platform like more towards to the machine learning kind of compatibility.
So I haven't felt the need for anything drastically different in MISA for the accelerators I have supported. Maybe that won't be the case for TensorStorm, maybe. I can imagine it being very different. But it's basically, I mean, modern GPUs are really close to what the MPUs that we are seeing today are, especially if they have a programmable core, like some of them have. It can be a DSP, it can be some IP which was used in GPUs actually, and the IP vendor then reused that for their own MPU. It's very similar.
Yes, they were. That's why I thought like, also another reason I bring it here is like, there are so many vendors here, especially this machine learning trend here, more and more there. But on the other hand, like, do we really want them all? Because even for the vendor themselves, you can see they are not consistent that either. Some like generation 1, and maybe there are no generation 2. Or when it comes to generation 2, the hardware design is already totally different.
So what happened, I mean, it's everything new, so we are seeing a lot of movement. What happened was that SoC vendors wanted to have accelerators because of the hype. They had to check that box that marketing people gave them. And they didn't have anything, so they went to the existing IP providers that they worked with, and they quickly hired something. Sometimes it was based on some DSP that they already had. They just bolted some multiplication units next to it. Maybe they were selling GPU IP, so they took their cores, they removed the graphics stuff, and then added some matrix multiplication to the side. And there might be as well some other cases like ARM with the Cortex-M. Again, they took a core and then put that. And the thing is that I think, well, it's a bit on the record. I think that they were trying to screw up the customers because it must have been very expensive because as soon as possible in the next version of the SoCs, they started using their own IPs. But also, there was a lot of trying to lock those customers in by using a closed source stack, which is not just the OpenGL driver. They also have components on top of that because there's no standard API, and then other boxes on top of that. Now the thing is that the SoC vendors are trying to do the same. They also have, of course, binary drivers, but they also have to try putting a lot of other blocks that the customers are used to invest and use, and then it's much harder for them to move to some other vendor, right? But that's kind of what happened. But actually the hardware that I'm seeing that people are using the newer SoCs is the same idea. Once I reverse engineer it and saw how it's done, I don't see fundamental differences, and I have the impression that they just reached a plateau, at least on the embedded, on the edge, and so on. And they are just there, and I don't really know what will happen. There's some interesting stuff like totally different ways of running these networks, but I don't know if it's practical at all. I haven't seen any real use yet. We'll see what happens.
Okay, thanks.
I wonder if you can say a little bit more about your thoughts on the firmware-mediated IP stuff, because I think that's also an area that might be easier to explore in the early stage, and also the analog with what's happened in the audio subsystem, right? You see a lot of the sound open firmware type of approach. So I'm curious if you have any thoughts of or rough sketches of what you think that firmware interface might look like, kind of like what happened in sound open firmware.
So lately I have been looking at ARMS. ARMS MPU is great how they have great open docs about it. They have an open source kernel driver, which is not in mainline, and they also have an open source user space stack one can look at. And then there's firmware. It's not that they have it open sourced, because I think it's not what actually companies are running. They normally give blobs to the customers, but ARM has an example of how you will be doing such a framework which works with the kernel that they actually have there. And it's using OpenAMP. It's very similar to what ByLibre submitted once for MediaTek. I think it's in this slide. And I think it's fine. I really like that. And then we could move dealing with the differences in the command stream submission within the firmware, and then the kernel driver, I won't say can be the same, but then I guess the differences will be up to what kind of memory is used to interact with the device, if it's what kind of coherence is there, and so on. And the rest will be really, really similar. But probably we won't have a single kernel driver for different MPUs and abstract everything inside the framework. That might not be that practical, because we wouldn't be sharing that much code, because in the DRM subsystem, the framework gives you all that already. So you will be just gluing different parts and not really implementing any of it. But I think what you did matches what I would like to see for supporting different firmware-mediated IPs.
Yeah, I'm not sure, how many of us have been working with multimedia before. Before they have, this thing called OpenMax. Actually, the codec, video codec, encoder, all these things are totally a mess from different SoC vendors, right? And then I think, well, after Android actually take OpenMax, actually, it's a spec, set of things like, what kind of hardware block diagram you should have, and the boundary of the SoC, to the interfaces to the middleware, and from the middleware to the upper layer, right? So a lot of like APIs of like enumeration, buffer management, enumeration, all these kind of things, like workload submission. I was thinking maybe we can actually try to, leverage some experience from them. Because, I think for the vendors, they don't have the requirement, like, I want something to be unique, right? But I think for us, if we, trying to take a look at that, maybe, well, if there's opportunity, we can also talk to Kronos, like, okay, maybe based on OpenMax, can we, have something similar things for ML? I would just say that would be much more helpful, because it did solve problem. We have the successful case here. But I mean, it's not solve all the problem, but it solves a lot, I would just say. If you check the Android code nowadays, I would just say, yeah. So that's something from my comments.
Okay, so maybe the Android people formalized a bit further the OpenMax spec, because I remember working with it that different implementations, they were conformant, but each behaved so differently that your application had to know what hardware it was talking about. So it wasn't really abstraction; it was a leaky abstraction.
Yeah.
So I guess Android is something similar to OpenGLES, in which they added some restrictions, and they added a test suite, a conformance on top of Kronos.
Yeah, correct.
Okay.
Yeah, but I think OpenMax is more is doing more than OpenGLES. I would just say it has a spec even like for your hardware type. What kind of hardware type diagram you should have, and enumeration interface you should have. So
I haven't seen that much complexity in GPUs.
Okay, I see. Yeah.
I don't know if the complexity on OpenMax was as well, because it tried to show a pipeline in which there would be different components.
Yeah, correct.
But in this case, we only have one component.
Okay.
I really hope we won't need all the complexity on OpenMax.
I see.
But yes, for sure, working with Kronos, I mean, I guess they have already been thinking about that. But I think they are a bit stuck, because they have to cater for the needs of their members, and each of them want to do something else. And they have been a strong appetite for vendor locking, which goes completely against interoperability standards, right? But if we have some open source drivers in mainland, people are using it at different companies, even if we don't have yet that common API, but we support frameworks, it will be much easier for Kronos to make the point for, hey, your vendor lock-in is not going to be there anyway, so let's work together and get to a different phase.
So in order to pull in vendors and other manufacturers to actually utilize mainline, there needs to be an incentive somewhere, as in we need to make the mainline interface provide some functionality, some utility and hooks into user space that make them want to actually use it so they don't need to develop their own stack and components there. So if we really want something, there needs to be not only a standard, but also hooks into the existing user space components that have already been developed.
Yeah, I'm making use of those in MISA. There's those IOs which are specific to each driver, which are related to the command stream, but the other ones, it's not really that much, to be honest, because there isn't really that much functionality that gets exposed. I mean, this is really simple hardware. There isn't really that much there. But in any case, in my experience, you don't need to convince the developers or the engineers at those companies. Those people are able to understand why it's better from a technical perspective. It's just a matter of getting the marketing people, biz dev, and the politics running to them. Because what I'm seeing is that the software managers, they feel that they are losing power if they have a mainland-based solution, because they are not gatekeepers anymore. People can go directly to mainland and set patches, right?
But I also think they're not going to go with DRM.
Well, if you write the drivers,
I think in this space, the kernel is not the motivator here. The kernel is a minor part of the interface to these type of devices, and same in DRM. The motivator is providing them with some sort of user space framework that they can trivially plug into and they don't have to worry about. And I'm like things like, I'm a bit all over the place what's needed in user space, like, what is there space for like a common graph compiler? What should we do? Could we pull one DNN out of the one API solution and build that as our common graph compiler? Can we take pieces, all this code's out there. Is there an ability to build enough pieces? Like I've got someone working on this at Red Hat at the moment, looking at like trying to pull one DNN out, trying to see if SYCL can be used, trying to see if there's a way to, just get the pieces that are already existing, that are in vendor stacks and impossible to use now. But if we could go, we just take that piece from Intel and we use this piece from like adaptive CPP, or we do, and trying to build that framework in user space, we have a common thing, and then they just go, all I have to do now is plug in a list of operations, or and then it's easy. I think that'll drive it more than the kernel. The kernel is not that interesting for this.
Yeah, I think we can give them the same tools that are useful for the GPU drivers. They are also useful for the MPUs and so on.
I think the analogy to what Android did with OpenMax is a good one, because OpenMax was kind of an abstract concept and a pile of wishes and ideas, some of which never ever got implemented. But Android with StageFright gave you a very concrete thing to nail down. But where I think it's quite different to this is that, doing stateful codecs was fairly well understood. Like, in terms of GPUs, you've got GL and Vulkan at the top end, and you've got some hardware at the bottom end. With OpenMax IL and what Android did, you had, H.264 at the top end and a well-defined bit stream and some hardware below that. So it was a pretty well understood transformation. But, we've sort of got the closest we get to something vaguely common at this level is like TensorFlow and PyTorch. And like Dave said, the kernel has almost nothing to do with it. It's all of that interesting functionality is in user space and how you deal with the graph compiler and translating that down to the ops the hardware understands. But that's completely a user space thing, and it's much more sort of wishy-washy than the codec situation was.
Yeah, sure. Well, Something interesting, there's a question there, but something interesting about this is that it's not just for the accelerator what you want to expose in user space because of some user space functionality that some other component needs, but it's very often what the hardware can actually do. I mean, and what happens is that there's always an opt-in interface so that you can compile to what the accelerator can, and what you cannot, you just bail off. You just say, hey, I cannot deal with that. I will be run on the CPU elsewhere. So it's a bit two ways. So we have more flexibility there. We don't really need to support everything. We don't need to compile everything so that runs on the accelerator. We can just give up if needed.
I see another limitation for upstreaming stuff, and that is in that particular community, let's say, if we can call community, they tend to rely a lot on vendor-provided BSPs, and they use very outdated components often, and the SDKs are pretty much the same. So it's a combination of all the stuff, and that's why many find hard to upstream stuff. They are working with much older versions, and it's a hard sell internally for the engineers to get things upstreamed. They are fighting against management all the time, and if they do go with mainline first, then basically nobody will use their work. I have seen it firsthand that I will port something, it will work much better, and still nobody use it.
Yeah, sure. I mean, that's the thing that we see with anything that lands in newer kernels. But I'm sure that there's some companies which are fine with using vendor BSPs with very ancient components and with no updates and so on. That might change with the new European Union regulations. But I hear from the companies who actually want to use the newer stuff, want to have updates, security, and those are the ones who come to me and say, our partners are not giving us mainline drivers. Can you help us? And those are probably the people we should care about in the kernel, not the people who are using a downstream branch of an ancient kernel with an enormous delta. They just dug a hole themselves into a hole. It's our job to bring them out if they don't even want. I don't know. There's some devices in which it's not really that important running the latest bits, but those people are not part of our community either. They just don't care about it, and that's probably fine. But there's a lot of companies who really need to have MPU drivers in mainline. Those are probably the ones we want to talk with.
These kind of changes usually ends up being driven by customers, whether that's a company in between an IP customer and actual end user of an SoC. Sometimes it's end users, companies.
Yeah, sure.
And I'm really hopeful about this. The industry is very early. Nothing is done together. The whole upstreaming, it's not that people don't want to do it, but or that you necessarily lose power, you lose predictability. You can't, your marketing team needs to ship this SDK in time for when the hardware is ready, right? And upstreaming timelines are always uncertain, right? So it's hard for them to make that call when it's not a priority, right? When it's not a customer requirement, the driver's upstream. We'll get there someday. I like everything is going well. I like that people are frustrated it's not happening fast enough. And I'm sure we'll get there. I mean, it's a natural. We've seen a lot of subsystems being cleaned up, and this is the journey they all take. So it's good. I think most drivers that have been upstream so far are fairly simple, right? It's a fairly basic offload, maybe matrix multiplication, some more advanced ops. But there haven't been any like highly complex, like the hardware we have is extremely flexible. It's also not load store based, it's data flow. So like the programming model is slightly different for the hardware itself. I guess it remains to be seen how those end up fitting in and also into DRM, right? Because everything there tends to be SPDM.
Yeah, I don't really see the edge getting much complicated any time soon. They seem to be just.
Yeah, it's some image recognition type workloads and maybe some voice.
I'm curious about automotive because they are using some SoCs with similar MPUs to this, I mean, but they also want to scale further, and I don't know at what level they will get between the desktop and server ones and the currently used in the edge. We'll see. But yeah, hopefully, I think we'll be able to work together on this. It won't be radically different. The thing is that I think it's more of a market maturity thing, that there's a lot of consolidation in terms of features on the edge that allows us to also start making, consolidating it at the software level in the kernel and in user space. But for those segments in which there's so much innovation, everybody's doing in different ways, maybe they are making more complicated ways than needed because it's not clear what's needed yet. So we can probably help those less right now, but we have to start somewhere anyway. So.
Yep.
Any questions from internet, actually? Okay. Yeah, I don't know. We still have 15, no. How much time we have? Yeah. Okay, so is there anything we haven't covered that maybe somebody?
You had test suites on one of the slides there. What is the state of test suites for ML for the edge kind of workloads?
So of course the testing was for me. I was the main user because I needed to move forward and I couldn't be regressing all the time. What I did was creating a test suite in which I have the operations I support in TensorFlow Lite in that case, and just with gtest, it just makes a combinatorial combines all these possible values, and so I have thousands of tests that make sure that I support convolutions with all these different parameters, and I use the infrastructure which is already in Misa for running them in parallel, so it runs actually fast, and then to run those on CI. But it's specific to TensorFlow Lite because we don't have a common user space API. Once we support PyTorch, we'll have to also do something through PyTorch because the operators will be a bit different. That's what we have today.
Okay.
There's a question here as well.
We'll go that one.
Yeah. Thank you.
Yeah, just for clarification, like you had this list of drivers that were sent upstream, and then you have some drivers that are upstream. All those went via the DRM subsystem and mailing lists and stuff, right? Or is there?
No. In many cases, they just sent the downstream kernel, and it was a MISC-car device. In some cases,
okay.
In one case, it was an Axel. It was using modern stuff. Actually, because normally you see that out of three kernel drivers, they try to be as self-contained as possible, so they don't have to have so many ifdefs, because stuff changes in the internal APIs in the kernel, right?
Okay, so they let it be like that. They didn't try to integrate into the rest, but they just, okay, all right. Okay, fair enough.
In most cases, yeah. Then people told them, they saw it was a lot of work, and they stopped sending versions.
It is soft.
It's because you mentioned OpenMax.
Targeted. One thing I haven't seen mentioned, I don't know if you've looked into the ARM tensor operator settings. I can't remember what it's called. Is it TOSA or?
They were doing CPU?
Yeah. I think it's for You know, it was more generic. The only reason I know about it was when some of the Vulkan internal discussions were brought up. That was the sort of idea, was like, oh, let's just take this ARM tensor operator set and try and see if we can build something off that. But that hasn't gone far. But I was just wondering, it seemed like they were trying to make just a standard set of operators that could be used then to build the API. Everyone would have to support those operators or something.
You mean extending the ISA of the ARM?
No, this was just an abstract.
Yes, it's TOSA.
Yeah,
right?
TOSA, tensor operator set architecture.
No, well, it's like MLIR. So
Yeah, is it more like MLIR?
We need something like that, but the most important thing will be if everybody uses it, right? So people have to agree on that, and well, we can help them, I think, by having drivers in the kernel and in user space, and it would be much easier for them to figure out what could be something that works for more people, because nowadays each is working in their own silo, in their own stack, right? So it's much harder for them to find a commonality. Maybe we can help them with this. So, no other questions? We covered everything.
I'll queue up a last one here.
Yeah.
If there's anybody here who really likes working on these things and is looking for something, come find me. We're hiring.
Sure. Oh. Okay, so we can just use the rest of the time for whatever else. So thank you, everybody.
So I've only started recently reading up what you guys.
What's that?
I have to start reading up the internals
Literally
of your
everything is
test
on
talk.
GitHub. Like everything is open.
Yeah.
In our case.
But just
but
even
the
the
driver layer is shit. And we're re-architecting it.
But the programming model for the devices, how?
It's. I mean, it's open as public.
But no, but I just mean how you use it. You know, how,
Yeah, you want to look at Metal, Metallium. It's our bottoms-up program with C++, each core, whatever. And then it's a never-ending stream of needing to write more operators.
So the hardware as well, the hardware is like no doubt. It has to be that way. That it has to be that way. The API at the kernel level, the architecture matches what I saw as the needs from the code and also what the hardware is.
Okay, yeah.
I mean, in both ways, it's in the middle.
But there's no like company platform. It's just that you are a ton of work. I guess it's easier to write that shit.
Yeah, I just think that if we came up with something totally different, we would end up with basically the same thing. So why?
I'm mostly working on GPU that's better learning parameters. If it's just regular, like in our case, the manual programming model, machine learning is hard because like we have 8 by 10 or 10 by 13 graphic design. There's no need to there's 5 reasons.
Yeah, there's a bit of also for example you can transpose the SRAM via VGL. You can say this section of the
so they work on SRAM, that's it.
Yes, can do that. But it's not for tensor, right? But that's not exposed. This about the framework that's internal to the pattern. You just do whatever you need to do for that is fast as possible. And then you have actually in the kernel the DMA gives that if the compiler thinks it will be faster, you have to have those buffers in SRAM in allocates because too much. So that's something there.
There's spatial and temporal, right? If it is spatial, yeah.
They started by fixing Python first. Yes, yeah. There's an interesting area that I see, middleware, and you get some of your and they have done network and he chooses that if you control the infrastructure, and it turns out they're different applications what they build with a super set. And then the line over there. It's usually a real over time. Yeah, well, I have no idea what the point is that I have no idea. This teacher doesn't some of the only know I
There is some from that here.
Some wells here doing cocoa stuff for them as well.
Everybody else has to one case.
That's
Yeah, I mean, we were just pretty
no other vendor like supports the same
I mean, equivalent, we have functional equivalent. We just I mean, NVIDIA started with that. So what's the AMD one, the binary one?
they changed the EU to
Oh yeah, 4 points.
No, So because then, so this only doesn't finally.
No, it's translator.
Yeah, just PTX. But we also you don't have the PTX. And PTX is NVIDIA's body. Yeah, NVIDIA gave like and the compiler binders. Yeah. And so they only ever looked at PTX. On NVIDIA, they're going to but they're using the PTX. So they were the PTX is just documented. They don't do proper document. So that EOLA is not.
You are currently the only person in this conference.
Yeah, we're looking at it. But again, the problem with that is it's so CUDA is so tight. Unless the hardware, you end up not doing it. Like AMD changed a bunch of their hardware. They changed their waveguide to they added a bunch of stuff. Yeah, because there's no much quality in the
But there's also you need to be 100%
no,
you're not going to be better than
more.
we get at third GPU, right? You got to take a bet on solving the problem. They can trade off from like 1 year's case versus another.
Yeah, and you gotta go for like an hour or a few of that.
Yeah, you got to optimize some sort of or being
but then with AMD,
it has some benefits we are seeing that they don't need to education, same foundational model, different terminology, versus having to completely imagine a different way of thinking.
Yeah, not in some way we're figuring out GPUs probably take something
It's still too thin. You'll get there. 5 years.
Because like every hardware is different, like then there's like proprietary binaries, right? And like
you have to follow your perspective, the program models. So
yeah, but like imagine if you are like making a product, like it's hard to like pick the right vendor, right? Because like there are no benchmarks, like
there are games. Yeah, exactly. I think we're going to go like, can I buy this? Yeah, Can I get my hand on enough leave to do my business, and then I'll take my mouse and hospital.
By the way, if you want hardware,
Yeah, I'm going to ask you.
Yeah, I've been resident. Well, I guess you might have to drive with your don't waste your time getting upset about it.
We see that for the applications, which is
So at that time, we don't
Yeah, of course.
He's giving me all the no GPUs.
Oh, they're all DPUs.
Is every letter the underscore PU? V, I.
FPU would be a non-functional.
Yeah, it's already done. It's the originator. Progenitor or what?
BPU is waiting.
Yeah, BPU is next.
Or ZPU.
That's my next product name.
We were hoping to get a moment.
Well, and recently we started to realize that Nova might be part of our future, right? And so now we're wondering, well, shoot, if that's the case, what happens if they split up Nova into those two pieces?
I would like to find out beforehand, it would be using the piece for people and seeing having the replacing and then maybe the upper layers, because then you can still find moves and that would be like a status possibility. No, I think I just failed to work to show that it's actually possible and works. It's like, that's the No, just our thing is that case connects. And we wouldn't need to, of course. We would have brought all these oh yeah, down in this case, no need to go out. Yeah, no, I just that's also
I'm right now here, I really chunk down.
Like Apple is trying to close the gap on the one that so we have letting go already. He's trying to close the gap on the government side. I'm missing like the extra data line.
Did you say GitHub?
Yeah, so yeah, I put the that's like really cool for that's like the core. It's just not missing all those control buttons that you need.
You mean the SGT, right?
Yeah, SGT bindings. And I'm sure we'll find five more before we get to the end.
I'm sure it's like, so this is like systems of how.
You can't clean up all these. I'm sure you remember.
There's a big problem of right mode or right binding for example, you know, how to
That one, honestly, I don't know how it's going to be. You're talking about coming on suspend
So we're supposed to go into where's the schedule review. What one are we logged into?
Friday?
Yeah, but we need to make sure we're logged into the right.
That's the book.
Yeah, I just need to get to a page where we can make sure that we're logged into. So this one's not logged into it either, okay.
I was talked into
Hey, what's up, Kevin?
I don't know what the problem is with session keys, like I don't know, like the big blue button session itself. Away we went, you know.
Okay, I will be there in a minute.
After we were done, he moved up.
keys are supposed to stay signed in, so I'm not sure. That's why it kicked you out. Oh yeah, that's annoying. So they had to restart Big Blue Button to get the chats fixed. So that's why this one got kicked off. We are displaying it back from there. I understand, but then for you to be able to toggle from it from up here, we just log into the message. We log into the same session from up here. That way you can toggle through it up here. Hey, off the top of your head, do you remember what the password is for logging into Big Blue Button? Because every upfront computer has now gotten kicked off too.
Yeah, hang on, let me look. I'll text it as soon as I find it.
Okay, yeah, I was trying to find it and I was having difficulties. Did I put it in notes? Yes. That one needs to go where that one is. That one needs to go in that corner. Yeah, and we're just going to tape that one to the wall in that corner. Not right now, yeah. Why? Speaker at LPC.events. Why? Login host, no such user. You lie.
So do I take off this one from the stand? You have another stand to put it there?
No, I was going to tape it to the wall.
Okay.
Try to use that tape because I didn't bring it. I understand I've been removed from this conference.
Oh, you just put up a whole is it, right? That's amazing. Then should be. You just have to select like session.
Turn on the head now.
Excuse me. How can I take my presentation? The presentation is here. Friday. Here. The presentation is here for this, but it does not appear in the list.
You uploaded it and it didn't appear.
What I can do is just download and then upload it again. Here.
Yeah, if you can upload here. They had a reset big blue button, so I'm not the expert in
Okay.
in that
So-
part.
So, yeah. Okay. Download it. Not download. So it's yeah. Okay.
Okay.
Thank you. So, you were there, and at the presentation? No. So, this is above to discuss about trying to find a way to define a set of ABI for performances, because when we go through the different cooling devices, we find a Tamanet framework on out of 3 kernels. We see that there are a lot, more than 100 cooling devices, and so the cooling devices just export a file where you can set an index, a value inside, saying set current state, and then we find cooling devices doing brightness for the backlight. Some is just changing the current, giving the frame rate, and so on. So that's all. That is the sign that there is something missing in the framework and missing in the kernel, giving the possibility to the different SOC vendors to use the provided IBI by the kernel. So could have at the end a unified IBI. So the result of that is the user space is just trying to set and get values per platform. So it's a specific code for each platform. And what we would like to do is to try to unify this IBI so the user space doesn't have to write its own code at each time to reach the different devices, but can use the framework available, and with a configuration file, just access the right one, and can describe profiles, and then set the performances limit on each devices. So the proposal, so for the set of these devices, we have some of them does not fall under the performance umbrella, so we might have to find something else for that. For the ones falling in this and the scope of the performances, then we can provide this framework. For devices where we can get the power consumption and set a power limit, then we can use the power cap interface for that. Otherwise, we would like to have a performance interface. And what we can find is in the performance-wise devices, we see that they have specific constraint like applying temporary constraints. So you set a limit and then automatically it will remove after a while. And they specify also throughput, and also they use /dev because they remove the constraint automatically when the process is exiting. So the interfaces we are proposing, I'm proposing, and to be discussed here, is normalized interfaces called perf normal min and max, which are normalized through 0 to 1023. And we can also put a map where we put the operating point, the performance operating point with frequency, and the performance value, normalized value, corresponding. So if we need to find which normalized value correspond to which operating point, we have in this map this information. We have some devices wanting to have a throughput value to set the performance. So we can use that. As far as understood, this is something we can put.
What would be an example for throughput on a device?
I think it's yeah.
So I was thinking about like somewhat yesterday, and I just use normalized thing without the kbps part because it's hard to get right.
Okay.
Generally speaking, and then you know, just perf min, perf max.
This is for just cooling, thermal stuff?
No, it is specifically not for for thermal stuff.
Okay. But if that, I know, prefacing, let me That's confused. But if it's for QoS, I do see some value. So if it's for,
Hello, okay. Yeah, if it is for thermal, I'd see some value in normalizing because that's good enough. But if it is for user space to ask for some performance, then I agree with the point somebody else raised in the previous previous microconference, saying if you want 100 kbps, you just want 100 kbps on whatever system. You don't want to figure out what percentage does it translate to. Right? If it's a video decoding, and if you need only X Mbps for a 1080p video, I don't want to figure out is it 10%, 50% based on the SoC. But I also see a problem with the units exploding. There are multiple units to add.
Somebody needs to figure out. The problem is that somebody needs to figure out that so the hardware in some cases exposes like performance interfaces in arbitrary units. And you don't know how much performance you get in kilobytes per second at each level, right? So you have to, somebody needs to figure out that will be either the kernel or user space. And let me finish. I think that user space is in a better position of figuring this out than the kernel is.
I've just seen the answer here with the map, so I guess we would be able to look up what the 100% looks like, right? Like how much.
Yeah, maybe we can just have perf min, perf max, and just a mapping file.
Yes, I think that makes perfect sense.
Frequency, or we can have kbps, and we do the conversion.
Yeah.
If we give this information.
What I think is ambiguous here is what happens if you have a value of 0. Does that mean it's completely off and it doesn't do anything, or does it mean it's the lowest performance state it can have while still running?
I would say 0 should just be the lowest. Basically, you're saying I don't need anything. It's up to you to do what you want with it, which should be lowest. 1 second. But the map, again, if it's frequency to perf value, so perf value is the normalized value, I'm assuming. Then the question still becomes like, who's going to figure out, is it kbps to perf value, or is it IOPS to perf value, right? So you still have a unit issue there. And I disagree that it'll be easier for user space to figure out, because now they need to understand the SoC. And the frequency could translate at different kbps depending on the bus width and all the complications that a bus might have, an interconnect might have. I don't think we should push this to user space.
So I have a specific example in mind, to be honest. So in the Intel PC driver, we have the interface on the hardware side is actually in performance units, which are not strictly related to frequency, and it is a pain to have to convert those units into frequency in the driver, so we can use the CPU freq interface. So we would actually prefer to have a generic abstract interface in arbitrary units, so we can just use it as performance levels and don't care. And because otherwise we have to provide a scaling factor which is not just per chip but per CPU class in a chip.
Yeah. Quickly. I mean, that's like the P core and E core, yeah. So are you going to talk about instructions? Another way to look at it is you can say, I'll give you performance as instructions per second, right? How many instructions you get to run in a second. I'm just making shit up now, right? MIPS, right? But you're not saying that. You're saying you want to give a normalized value, but if it's normalized, if I'm a system that wants X amount of MIPS, how do I figure out what I'm going to ask you? I don't want to figure that out. The whole point of the kernel is to abstract the hardware so that you can talk to it in a common language. Saying I'll give you a normalized value and saying you figure out how that translates to my hardware seems like the opposite of what we should be doing. I want to give.
So I think having a normalized value by default that can be used is fine because for CPU performance, how do you translate that? I mean, but for other device, it's far easier to use a unit that the device is understanding. I mean, when the device it's about bandwidth, typically, it's easier to say, okay, I want this value. But what we should take care is that the value is the user space value, which means that at the end, the driver can set twice because there is the user, but all the overhead around that. I mean, it's not about mapping directly to the low-level bandwidth, but the end-user bandwidth. Otherwise, we are facing the same problem. You need to understand how much overhead you have internally, so you have to.
Yeah, I mean, I mean, PMQs in this case would probably be like a minimum request, right? So nobody's saying you won't get more than it.
Yeah.
So that's kind of, I guess, assumed.
Yeah, so that's orthogonal to the unit choice.
Huh?
That's orthogonal to the unit choice, right? But so I think that the QoS kind of interface is the right choice for this because it allows you to give a desired value to the kernel, and then it may be taken into account in different ways depending, right? So it's aggregated somehow with some other requirements from somewhere else, right? So this is and that needs to be done this way. So to me, QoS is the right choice. Now, for units, right? I agree that in some cases it is better to operate in a specific unit space. But then again, as long as this can be, this will have to be translated into some hardware performance level anyway, somehow, but by somebody.
You talk about. Oh, sorry. You want to maybe? Yeah. You talk about setting the performance to 0.
He's off.
Okay, that's an interesting use case because if we have just CPU freq and we say we have discrete values, then we cannot set the frequency to 0. It's not possible. But if you change the semantic of performance and you want to say, okay, when I'm setting this CPU on this device, but assuming it's a CPU, for example, to 0 on performance level, then you can somehow pause the CPU. The CPU not be used anymore.
So in a PMQoS case, the 0 would just mean no request.
Yeah. Zero means, because you can have multiple people asking, right? PMQs allows you to aggregate them.
Yeah. OPP does works the same
No
thing.
request.
So
If
if
there are no other requests, then you can just turn the thing off, right?
Yeah.
you release your vote.
You what?
You release your vote. Sorry, I have the mic. I'll just
When you
repeat
said
that.
zero, when you said zero in the PMQS, but I'm talking about the performance, the ABI. If you said zero in the ABI, that does not mean you said
Yeah,
zero to
I
the
think the ABI should
PMQS.
be the same.
But you can do an action, a different action. If it's superior to zero, you are in a discrete values provided by the different step of the OPP. But if you set zero, you don't go through the CPU flag. You can do a different action, reducing totally the performance.
That doesn't make
It's
sense,
an
right? You can't,
example.
like, in the CPU case, you can't just pause the CPU. It just means you don't want it, right? PMQ is always about quality of service that you get. It doesn't determine the finals, doesn't give you control of the final system state. And then going back to the units thing quickly, I think I agree that we should have like a normalized way to set it, but we should also definitely provide a unnormalized unit-based way to set it too.
So we can provide a map file for each unit.
And I think if the main issue is the name of the unit, like for example, right, if you expose it in sysfs or in a struct, some ioctl, whatever you expose it to through, right? Or one of the concerns was, okay, this is one unit today. What if you have 10 other units tomorrow? Maybe we should just say per unit min or whatever. And what that unit means is going to depend based on the device. So for interconnect, it would be Mbps. For SD card, it'll be IOPS. 1 second, Rafael, right? So that way we leave the sysfs interface, the user space interface, as common name. But you let the device define. And I think whoever is using a SD card will know they're using IOPS. They're not talking about frames per second, right? So I think it's kind of obvious based on the use case. Maybe that's a good intermediate.
Yeah. What if you have two different units? So SD card can be throughput and IOPS.
Or kbps and mbps. Maybe that we can say, hey, if you're writing a interconnect, make it mbps or something.
So okay, so that's actually easy. So if you have performance unit, just normalize units as the interface, and then you don't need a map file because it will be linear mapping. You only have to say what value, what unit, what's the what the max unit means, right? So 1023 in your case, you can say that this means 100 kilobytes per second, for example, for this particular device, and expose it in sysfs in a file. And now if you have different units, you can expose multiple files, right? In the multiple mapping files to the
Acting like you. So the two parts, right? It could be interconnect, and some could be kbps. In some cases, it could be mbps for on a more performance system. In that sense, if you're saying we should have a perf max unit whatever file that says 1023 means it'll be 100 kilobytes per second in one system, 1 gigabyte per second in another system, that's okay. But I think your point is different, which is in a given interconnect, you can ask for latency and you can ask for bandwidth at the same time. But I see this as two different qualities to ask for. They're not two different units.
Well,
They're two different attributes to ask for.
That's no problem. But
Huh?
if it's, as you just said, IOPS, and that's not well, is that latency?
So we have
Yeah. So you have IOPS and bandwidth, right? I'm saying those are two different attributes to ask for. They're not a unit issue. They're an attribute issue.
Units file, right?
Yes.
Yeah. So in Power Cap actually there is a units file in sysfs, and you no confusion. Yeah. So you use abstract the normalized interface and then provide it what it means like in the normal.
I don't see value for normalized, but it's okay.
In some cases, this will be just normalized and then no mapping to a real life. Because, like for the CPU use case I was talking about, we don't know how much frequency this means. It's like performance value.
So shall we put, for example, just two files, performance min, performance max, and then.
And a third one, performance unit, which can be normalized by default or kilobytes. Or IOPS.
And a unit file.
A unit file.
Yeah,
a
so
file where you can get which unit is used to set the performance. which can be normalized by default, so between 0 and 1023, or you can say my unit is kbps, and my unit is frame per second.
Or 10 kbps. You give the list of kbps, or a list of frequency, or a list of something else?
Yeah, so basically...
And giving the performance, the normalized performance association.
Like you don't need, you don't need to normalize all the time.
Okay, the two options,
if the interface is normalized, and you act on the interface for min and max, then you have to do a translation between...
Yeah, but do we really need to normalize in this case? What's the benefit of normalizing when you know that you can set the kilobytes?
No, that was my point. I'm saying I don't see a point in normalization, but if some people want it, we can allow both.
No, yeah.
Okay.
I think you want a normalized interface for the case where you don't have any real unit for performance of the CPU. I want just 0, 10, 23, but otherwise I want to set kilobytes.
Yeah, then we can say perf min, perf max.
And perf unit.
And perf unit. If it says normalized, it means 0 to 1023. Yeah. If it says kbps, it means kbps. Yeah. That works.
But then the question is that how many units... Yeah, then the question is that how many units you want to define? Or you want to start with? Normalize and kilobytes? Yeah, but you need a list.
So it depends. I think it depends on the number of dimensions in which you want to set this QoS, right? So for each dimension there will be 1 unit, but you may have. So we need to think about it. There may be more dimensions than just 1 in which you want to set those values. So.
But what I don't understand is why can't we just use a file?
Can you speak into the mic?
Yeah. Why don't we can use a file? So we keep perf min, perf max with the normalized unit always. So we don't have these strange things that sometimes you could accept kbps or something else. But we provide another file, which is optional. The driver can describe it, telling if it's based on frequency on OPP, which gives the different frequency and the corresponding normalized value. If it's kbps, then you have kbps and the normalized value.
So the point is that you...
Yeah, what's the value?
The value of what?
You have to do twice the translation.
Ask him what's the value so that others can hear.
What's the benefit?
What's the value? Okay. So I think the point is that you only need to map the maximum to a specific value in real life units because the minimum is always there, 0, right? So it does need to be mapped.
That provides some other problem.
Okay. Yeah, or whatever.
No, yeah. The main. So I'm not sure to understand what the benefit of having this mapping. To be honest. And then, so what it means? You will map the 0 to the perf min to a minimum kbpf, or is it 0 to say I don't want to use it? Then you have to find for the map.
So from the QoS perspective, 0 means just 0. I have no requirement, right? Then if you say run, I want at least 1, right? In whatever units it is.
So when you provide a map, if you need to provide a map, we will have this question. I mean,
no, 0 is 0.
0 is 0, and then because this is a linear mapping, then you only need to map the max.
I don't think you want a linear mapping.
Yes, it has to be linear.
It has to be a linear mapping because why not? Because otherwise you have to just provide a function on.
The mapping would be if you have 5 OPPs.
Yeah, so it's not a linear mapping.
You have 5 normalized value corresponding to the 5 OPPs.
Okay, so it's not a linear mapping.
It is a linear mapping. Okay.
0.
But then
how do you convert any frequency to normalized value? You divide it by the max frequency and multiply it by 1023.
That's exactly my point.
That's a linear mapping.
The mapping can create some. So if you have a fixed number of OPP, okay, but if you don't have, you have to provide the step. I mean, if you have a 100, 1,000 step. I mean,
1 second.
You will enter in this situation that the mapping is not really always easy to do. That depends. If I agree, if you have 5 OPP, that's pretty easy. If you have a linear increase, how do you describe that?
You don't put a map file. It does not make sense.
going back to the earlier question was, why do we need a map file if you can already request on another unit? Who would choose to use a map file?
I think this is related to the question of what we read back from the file after setting a specific value. So if an interface has 5 discrete states and we write a 73 in it, does this get rounded to the normalized value of the state that it's actually picking when we read it back, or does it stay at the value that was chosen by the user and is not actually corresponding to the state that's there?
With round to the...
Do we need to read the actual, I mean, yeah, that's another point. So you can set a performance, but do we want to read the actual level? I mean, I set 120.
Obviously, yes. So you need to look at it from the user space perspective. So user space has no idea about how many states there are available, what's the, how far they are from each other, is this a linear mapping or not. So user space will just have a requirement, right? I need at least like this much performance.
So we don't write the actual value. We just write one direction. I want this value.
But but the user space...
I think you should be able to read, because when you do that in a PowerCap framework, when you write, PowerCap, the extension DTPM, which is based on the energy model, when you set a power value, and the power value is corresponding to, it's in between two steps, then you will choose the step below, the limit below, and when you read the value, then it's not the value you set, it's the value the system set.
So that depends on the design, to be honest. So either you give the written value back always, right? So the value that you have written and you read back your own value, sort of, or you give the effective setting right back from the interface. Both have there are good reasons for doing either, right? You need to decide which one you will choose, because there are arguments, right, for each of them. But so the point is that from user perspective, they just want to say how, their requirement in terms of performance. So how much, I don't know, frames per second they want. And that's it. And then they don't care about why this is mapped to whatever performance states are available in the hardware, right?
Also the two aspects, right? If you're talking about reading and saying how much we guarantee the requester, the user space, that's sure. You can give that. But trying to say this is the hardware state and this is how that translates to how much they're going to get, I don't think that will work, because for something like bandwidth, it's going to be additive. I might ask 1 gigabyte, he'll ask 2 gigabytes, so the hardware might be set to 3 gigabytes, or you round it up and set it to 4 gigabytes. Me reading the value as doesn't mean I can actually use 4 gigabytes. Right? I asked for 1, and I should only be doing 1. And I think the rounding down, maybe that's for whatever reason they did that design choice. And I don't think it's right, because especially these PMQOs are asking for a minimum quality of service. You can't round it down, then you're kind of violating the basic principle of it. Unless you hit the F max or something, then you can't give. That's a different story.
But I think we need to define whether we round down or up for any of these. And I think it's useful for the user to know whether it has been rounded up or down. So I think for the CPU frequency, right now the minimum gets rounded up and the maximum gets rounded down. Is that right?
Yes. You round up the min, you round down the max.
Round up the min and round down the max, because the max is a cap and the min is a floor, right? So for this interface, it's probably a good idea to have that too. I mean, like the floor and the cap at the same time, in the same units. And then there may be multiple dimensions. So there may be I don't know. I have no specific example, but
But I do have if you're talking about exposing back to the user, I don't think we should expose the hardware performance state, because I think that'll give the wrong impression, especially if it's a QoS request that can be additive, right? It's just they're going to think they have way more than they're actually having.
Because it
But then, so we provide this min and max, and behind that we have discrete state. So let's say that the min and the max are both between the same discrete state. How do you deal with the floor and the sail? Because you can't.
You fail the request.
Let's say that I have.
You fail the request because it's true even for CPU frequency. You can set CPU freq min to be more than max and max. You don't allow that to happen. You fail it.
No, that's not my point. Let's say that I have. Let's say I have 1 gig, 2 gig. I set the min to 1.2 gig and the max to 1.3 gig.
I know, it's an invalid request. You can't service it.
It's an invalid request?
Yeah.
So we have to deal with that there as well.
It already should be doable, I would think, in PMQoS.
How? Like,
I don't know what the actual interface is, but fail it. If it's a write, fail the write. If it's an API call, fail the API call.
Because it's not clear that this is the right thing to do. Failing the write is actually an awkward interface for SysFS. Because
for PMQoS either.
Yeah.
Yeah. So basically, we need to decide how we are going to resolve this. But let's say.
We will have this situation for sure.
So the alternative would be that the minimum takes precedence.
Yeah.
So if you set a minimum that gets rounded up to something higher than the maximum gets rounded down to, they're both set to the minimum.
I agree with that if it's like, say, your minimum is greater than my max. Two different. But if you're requesting a minimum and a maximum that can't be satisfied, if you're the only user, I think it's right to fail.
So if I'm the user and I write 512 into both the minimum and the maximum because I wanted to run it after performance, the sensible thing is to still have it run at the minimum, yes, at the nearest power state rounded up.
Okay.
Yeah.
I think.
That's fair enough, yes.
Yeah.
So we have a weak maximum and a strong minimum.
Yes.
I mean, we just have to be aware. Yeah. Yeah, I was saying we have a strong min and a weak max, in fact, in the rules.
And then is there already an interface for PMQoS for user space, or this is all new? And if it's all completely new, again, if it's SysFS, I don't even know how it's going to work.
It's new in the way we want to present the normalized value. It's new in the proposed feature like temporary constraints on it. There is already defrec where you have minimum. It's not unified.
Not defrec, but like, is there a unified PMQoS interface in the user space where they open a dev and do an ioctl or something like that?
When you set the latency, there is this PMQoS, but
is it like
not
a device?
for the performance, except the.
Should we just kind of extend and make it something similar to that? Because you're initially talking about some sys devices, but I don't think you're expecting people to write to that, right?
Latency is specific for idle state.
Yeah, we should, I'm not saying extend the exact same file, but we should do something similar, right?
No, not the exact same file.
Right.
Aggregated bit.
Yeah, so this is going to be like a file they open and then they call an ioctl? Is that how it's going to work? It should be, right? Because we shouldn't want...
Yeah.
One quick thing, so for me to play around with it, it'll be super handy to debug using like a writable sysfs or debugfs API, but the final API should still be like a file open so that if it crashes and closes, you release it.
Then yes.
Yeah, so the problem with this is for an ioctl interface, you need to have a device special file, which is
You mean like a MISC file?
a bit. Yeah, a bit. So for CPUs, that's kind of okay because then you know what you are doing. But for the devices, especially devices using different units, you will need multiple device special files.
Can't you have one file you open and you?
Yeah, and that gets clunky. So the sysfs interface is a cleaner one. But the problem with the sysfs interface is there needs to be an entity in user space that will marshal all that because user space. So there will need to be a daemon or something like that controlling that interface from the user space perspective, and different processes talk to this instead of talking directly to the interface.
And going from, I don't know, 10 years of past experience and how CPU frequency min and max are abused, you'll have like a user space agent doing it. Somebody who doesn't know anything about it will say, oh, I can set the min, and they go overwrite what the user space daemon was setting. I think this causes lots of hard to debug issues if you have a file that anybody can write to. I think like a... plenty of root only.
There are multiple things running at this route, right? This is the point, right? And they don't necessarily like each other even. They may not be talking to each other, but not liking each other as well. So we're on the same system, so you know, it's like, well, so, but I do think that, you know, going the device, the ioctl route, it gets very nasty very quickly if you think about like multiple devices that you need to control that use different units of performance, and then you have to define special commands and things like that for talking to individual devices, and you know, and so on and so on.
So,
yeah. I think it's up to the distro to decide who's in charge of writing to this. There can be any number of things that read from it, and I absolutely think that sysfs is the better choice here than character device, because it's just you have so many things that might have these, and the character device, like even connecting a sysfs thing that we know about to character device.
How do you deal with wake-up sources? I'm sure you went through the same issues there too, right? I think we gave a sysfs API, but people write to it and crash, and you keep the system awake forever.
Yeah, but so this is, it is similar, I agree. But you know, in the sysfs case, it is at least obvious which device this is related to. Whereas in an ioctl case, you would need to point somehow to the device you are.
Symlink from this to the device file?
Well, no, this doesn't work. No, you need to have a command that, you know, a format of a command that will point to the device, like what device it is. So would you use a device path in sysfs in ioctl? So. Yeah, so
This devices, GPU would have like a, I don't know if it's possible, have a symlink to the
But so would you create the device special file for every device in the system?
Yeah.
But you still can't prevent multiple people from opening.
So do they have to have the same ID or not?
I don't think it will fly.
Do they have the unique IDs for the?
Yeah.
What's the problem? Is the number of files you're worried about, or the IDs are going to be?
The number of files and.
Finding the right one. Can't you have multiple people open the same file anyway? So
That you can still handle it because you can tell it's a different file pointer.
No, not a file pointer. It is a file object. It's the device special file. Yeah. Okay.
Maybe I'm not using the right term, but if it's have one device file and multiple people opening, you can still distinguish them apart because you get a different handle or whatever.
But you need to know that there is a device special file in dev, right? But you
Yeah,
need
yeah.
to know what
Which device file? I know, I understand. But I don't know, name it similarly. We have plenty of device files. You can name it to match bus:"device file name. That needs to be unique.
I still don't think it solves any problem, because you still have to deal with the exact same problem of having multiple people trying to control the thing.
No, that problem isn't there, because if you and I open the same file separately, the driver will get two different handles. So it can tell your input apart from mine, and it can aggregate it correctly.
No.
Yes, aggregation still needs to happen in PMQoS. PMQoS supports multiple clients. Some of the clients could be in the kernel.
I propose I continue the discussion in a hacking room, because now there is
another buff. Sounds good.
Beginning now.
Thank you.
Thank you.
I don't think you can rely on having something that keeps the file open. I mean, you can do it.
I know, I can, but so many.
I never did it myself, but I know how it works.
Okay, so because I'm in the room right now in the BBB thing.
Yeah, but you need to be made admin.
Exactly.
Is there the room owner here? No. So maybe we expect. Can I make you? You are. What's your name?
Yeah, that's me.
Yeah.
Yeah.
Can I make you admin somehow? No.
What if you?
No.
What if you make presenter?
Ah, yeah, and now you can. Yeah. Thanks. Sorry.
No worries. We're getting there. All right. Cool. All right. Hello, everyone. Can you all hear me? Also remotely, ideally. Okay, so welcome to this BOF session on everyone's favorite topic, Linux CVs. I mean, I think we all are pretty much familiar with what's going on, but just wanted to have a quick introduction slide so that we are all on the same page. So yeah, since February 2024, Linux is now its own certificate numbering authority, so it can issue CVs. I'm putting a link here to a presentation that Greg gave us a couple of weeks ago at CNCF. Where is Greg? He's around, by the way. So thanks for being here. So yeah, this is, I think, the most up-to-date resource if you want to know a bit about what's going on under the hood. But yeah, so the reason why we're here, I think, is to try and get a bit of discussion happening between the people who need to deal with the increased CV volume that we have seen. We were receiving around 20 CVs per month before this change, and now we are around 60 per week. I know we have opinions. I know some people here have also strong opinions, but I think the point is not exactly trying to stay too much on this number, but try to adapt to them. So I think like the main challenge that we have here, is how to triage all of these CVs. And there's companies who cannot be upstream aligned, who need to take decisions based on the severity of these CVs. For a cloud provider like Google, I didn't introduce myself, but I work for Google. I work for the production kernel security team. We need to choose whether we care about a commit, whether we care a lot about it, so that we also need to live patch some machines on the fleet, or whether we can maybe even ignore it because we don't even compile the code, right? And applicability depends a lot on the threat model and on whatever deployment you run Linux on, but there is also obviously some common points where we can perhaps have some collaboration going. So here I have 3 ideas. They are probably wrong, and I'm hoping you will destroy them. But at the same time, they can, get the discussion started. And they're also not mutually exclusive or perfect or anything. But like one idea we came up with, one first potential approach is kind of trying to address a layer that is missing right now, because we have the stable guys who are giving us a lot of CVEs, and then we have the companies downstream that try to do something with them. And there's a layer missing in between that is providing the severity, reachability, some kind of assessment that right now nobody is doing, and every company is doing to be revoked, but that's apparently a bar that is too high for someone to just take care of it, and they tend to prefer to just not care. So
that's kind of how it's worked forever, though. Now.
Yeah, exactly.
Yeah. Because we will revoke it. We don't have a web form like Reddit.
Sure.
Before you couldn't do it. Just email us. If you don't want it, we'll reject it.
Yeah, and this is it's great that this is possible, but at the same time, it requires someone to context switch, go back to that old commit they did a few weeks ago, and sort of revisit it. So the idea here, and again, I acknowledge that this would mean probably spamming, patch authors, and they're probably not going to like that. Is
decided no.
Yeah.
It's coming up. Talk to maintainers. We will not notify authors that they got a CV.
So yeah, this is exactly what I was hoping for.
Yeah. So this has come up numerous times for the record. We've talked about it a lot. We will not spam authors or maintainers that they got a CVE for that patch. If they want to, they can. It's easy to filter. You can put up a LEI filter and see what you get because we publish all this stuff. You can put a JSON thing on the feed. If you care, you're going to be instantly notified that way, but we will not be spamming through email other people because we get too many emails as it is.
Yeah. But this happens afterwards. You see what I'm trying to say here,
I
right?
totally agree it happens afterwards, but it would be happening afterwards when the CV assignment happened.
Yeah, for sure. Yeah.
And I think the CV assignment also from a maintainer perspective.
Can we give KP a mic?
It is very threat model.
Hold on.
First, maintainers are burdened, right? It's hard for them to get to all of this. Not everybody's a security expert, so they may not have the right sort of view on that. And the third thing is there's a very fine line between CVE and bug, right? So I think the main point here is that you have to look at every patch, as Case mentioned earlier on.
Yeah.
So I think what we need is community attention side of things, the people who are consuming Linux to look at these patches and find out for their threat model, is this patch relevant, important, and then prioritize.
But it's not, by the way, it's not necessarily about I want or I don't want a CVE for my commit. It's also perhaps about providing even like, I mean, really thinking out loud here, but even like a better commit description or some tags in the commit description that says this code is network reachable, right? So at least you know, maybe you're a net maintainer, right?
I know.
Yeah.
I mean, as a kernel maintainer or something, there's no way I can do that. So the kernel
Maintainer of a subsystem, there's no way I could do that. And I would never ask a maintainer to do extra work. And you're asking the most precious, overworked resource that we have to do more work, and that's not going to fly.
Yeah.
Already, we have the rule that you don't have to participate in stable. We discussed maybe we want to revoke that last week or a few days ago, but there's no way we're going to tell somebody to do this, especially when we have a really overworked ecosystem.
Yeah, I mean, I was aware of
And
this.
the only people that care about this are the downstream, a subset of the downstream.
Yeah.
So it's up to you to do that.
Do you think there's any scope for deciding on an opt-in format or standard or mechanism for patch authors to include information about, like, I'm fixing a bug here, I happen to know that it can only be exploited if the attacker has capnet admin.
It's in the changelog. It's a changelog description.
Okay, but...
Better changelog description.
Better changelog description. It's there.
Okay.
You have that ability today.
But people very occasionally do it.
Some do, some don't.
Yeah.
That's up to them.
Okay.
The way is education, right? You have documentation that you can point to, present here, like, hey, you're writing a patch description. This would help security people. It's opt-in, but you cannot enforce that, right? But if, yeah, I just give it.
Well, I mean, while a lot of this is a pain in the butt for downstreams, there's a problem with end users and consumers in some aspects, though, that we're having to deal with now. That there are companies, for compliance reasons, that have to patch every published CVE, whether it's exploitable or not, and that's becoming a bigger problem. And analysis is great, but I mean, even if the analysis says, oh, it's a low priority, people are having to patch it for compliance.
But that's not...
So I think this is where the compliance side of things, right? Are we giving is the compliance regulation being done in a way that gives you a false sense of security? Because you have 20 CVs a month. Now you see syscaller bugs and UAFs that were not awarded a CVE actually being exploited. So maybe the compliance has to catch up there, right? We need to tell people that your idea of these CVEs that were actually being exploited or it's changed. Every patch needs to be reviewed.
I'm not saying the compliance rules are correct.
Yeah.
But they exist, and so the work.
Yeah.
Yeah, I mean, I don't agree with a lot of the compliance rules there. I don't think that they're correct. They're not. I mean, it's just like in pretty much any other government document on security compliance, right? It's a whole bunch of nothing. But they're required. And so you're still putting work on all of these companies.
I think it gives them more reality to the compliance.
There is an issue with the number of CVs that are going up at an exponential rate. We are not alone. WordPress is doing 200 a week. GitHub's doing 150 a week. Mitra's issuing 500 a week. OS X, Windows is doing 10 to 20 a week. We are not alone here. So that's a different ecosystem question that the CVE board knows about and that it's up to them to work on. It's not up to us to work on.
And I always try to get people to think about what the actual, what we're representing. CVs were supposed to be a stand-in for flaws. And so the real world situation we want to deal with is addressing flaws. CVs are just a poor mapping to it. And in the past, we had effectively false negatives. We had a huge number of flaws that had no CV mapping, and we've traded that now so that we have false positives, but few false positives. The compliance was designed to say you have to fix flaws. And so the problem now is companies that couldn't fix flaws before, that had flaws because they were just not assigned CVEs, have to now fix the flaws. So it actually is the correct state, and the sort of whiplash on dealing with, oh my God, all these CVEs, is the realization that there is an outstanding number of flaws, and that all the companies that are feeling that pain, unfortunately, now need to figure out, we actually have to fix the flaws. So anyone that says we can't keep up with the CVEs are declaring to the world, we can't keep up with the flaws that are in here, that are being fixed. And so, like, I think CVE is a weird, like, it has created a problem for a lot of people because that was the attachment that was made. But honestly, for the actual deployments that we all care about, we want to fix the flaws. So that's the real key to this.
Yeah, and I think the way you fix the flaws and the way you sort of do your qualification, your updates, and your deployment of the kernel has to adapt to this, right? The 20 patch, which results in 1 or 2 fixes every month, that mechanism has to change. The way this has to change is why we're all here.
Well, I mean, I'm Fedora, so I'm pushing every stable update, but once, twice a week. That's fine. I mean, it's not a lot of extra work there.
Yes.
I mean, yeah, I'll let you finish. Then I would have an additional point.
Oh,
Yeah, go ahead.
yeah, I was just, I mean, from my standpoint, we're already pushing this stuff anyway. So it's, in fact, it's basically just some extra work for me to go back and say, oh, yes, that release I pushed last week fixed all of these CVs. Not a big deal. But, I mean, we do hear about, people complaining about the number of, well, we've got all these CVs, we've got to now reboot. And that's just passing that on.
Yeah, which is why I was hoping not to go too much into the number of CVEs as an issue by itself. Like, that is what it is. And frankly speaking, again, if we want to talk about our opinions, I think this gives a better picture of what the security of the kernel than what it was giving before. So we talked about false sets of security. I actually agree with that a lot. So let's talk about how we deal with this, not about changing the numbers.
We all feel the pain, right? Damiano and I work on kernel security at Google. We get these CVEs, we look at them. All of this analysis is happening siloed within various corners of the industry. We just need to do what we do best, open source it, right? The analysis need to be open source, and we can tackle this. We tackle Linux as a development project as a community. This can be tackled as well, I think.
So I want to point out, yes, and the CVE.org allows for overlays on CVEs in the JSON format to allow for analysts. They've already approved 2 different companies to do this. If you watch the Git tree from CVE.org, they hit all of ours. Every single CVE got hit with this template change. You guys can do that. We can add the analysis to the JSON record if you provide it to us. We have the tools for it. I'm more than willing to do that, and CVE.org is very happy to have that. So there's no pushback from me on this. And the infrastructure's there to provide this in a public way, if you can give it to me.
Yeah, sure.
So give it to me.
So a couple of years ago, me and a few others from the Arch Linux security team, we sent out sort of an open letter to a bunch of the product security teams and CVE teams in different Linux distros. So we made this RC channel called Distro Security, which had this intention of sort of sharing analysis and sort of CVE assignments around the Linux kernel, because all of SUSE, Red Hat, Arch, Gentoo, all of us do sort of the same analysis, the same sort of which patch do we need to backport and stuff. So that's a venue we could maybe do more open collaboration on. It sort of lost a little bit of steam a couple of years ago because CVs are difficult. But the RC channel still exists, and there's still people there sometimes talking about different CV assignments. So I think the open collaboration thing could maybe fit in that venue, and we could go and ask the different people there what their thoughts on this is.
So I don't think the open collaboration is possible, because to triage a CV, you have to have a use case, right? You can't just globally triage a CV. Depends if it's like an enterprise distro, if it's an airplane, if it's that friggin' helicopter on Mars, right? They're all very different. And so this is why like the next idea is giving some context to how we care only about things that affect cloud. And that's a group that could triage. And then they could add it to the JSON and say, hey, this is the cloud consortium, and this is how we score the CV, or this is the enterprise distro folks, and this is how they score their CV. But you can't have like this global CVSS score attached to a CV, right?
I agree it can't be global, but I agree also. I also think that there are some things that are common to everything, right? So if you don't think so,
I don't think so. Stuff like the CVs that are assigned to Warren, like they might affect Android devices because they reboot them. But if your distro doesn't have panic on Warn,
so you actually picked the right example. So we don't care about warnings.
Oh,
so if you could label a CV as a warning, for us it would be very valuable, because that would be something we can discard.
So the problem is if a warn can be triggered.
No. I know some people care, but some don't.
I agree. So that's very obvious in the thing itself. So provide that information.
It depends why the warning was triggered as well.
It depends on why. So sometimes those warnings are actually an indication of a real issue.
What I'm trying to say is that
sorry.
if a warning is only problematic on panic on warn deployments, those who don't have panic on warn can.
But I'm saying yes, and that involves a lot of triage.
Okay. Yeah.
And a use case.
We're switching. I mean, that now 0.1 is quantum state.
But I mean, I think what you're talking about is if we had a machine-readable form of describing characteristics for a given CVE, then people in idea 1 can apply their threat model to those characteristics to get the information they need, and maybe add further information. So that, I mean, I think those combined make sense. But
yeah. Cengiz from Ubuntu Kernel Security. I'm still wondering why we are not actually. I know it's not designed for kernel per se, but we are not actually providing real CVSS assignments to kernels, right? I know you have.
Because we're not required to, and we're not told to, and I don't know your use case. It doesn't matter. There's a very good quote on a bug is nothing to you, something to you, and it's deadly to them. I can't give you a CSS. And NIST, who's doing the add-on? They've given up.
No, that would be NBD.
NBD, yeah, there's no way. You cannot do, it just doesn't work.
So we are just basically using the description field.
Well, you guys, you know your use case. I don't know your use case. I've already triaged this for you.
You're not producing these for us, so.
Yeah, it's up to you to do the next part.
I think what Sasha said is pretty good, right? Have few common threat models, describe them cleanly in the JSON for each threat model to your assessment. Add some common tags, which somebody who hasn't put their threat model can use, and here we go, right?
No problem with it. Yeah.
So this is kind of cloud TS. It's not only because I worked in the cloud company. Like if I was so this is why we can't give CVSS scores, because score for canonical will be different than the score for what I'm working on now, right? You can't score that. But if you define your use case, if you say canonical, Fedora, like all of those groups kind of do something similar, have a similar threat model, you can score them, and it can go into CV, like it'll go to the JSON, and you can say, hey, we scored this a 7.0, and you can share it with your customers. Like the infrastructure is there already. We don't need to invent anything. Yes.
I'm asking the infrastructure talking about this ADP, additional data provider for CVE layers. Yeah. Okay. Sorry.
We do have ADP additional, but we are the data provider, and there's a ton of fields that we can just give this information in as the data provider. If you guys want to just form your own group and be an ADP on its own, that makes my life even easier. We don't have to do anything. And you have right access to our records. But otherwise, we can provide this too. There's so many fields we're not using.
When I was saying CVSS, of course, I was not, defending the use case of CVSS, but for me, like, as a consumer of this, like, I have to have a quick glance, like some keyword table, maybe even, hey, this is net filter. Yeah, it might end up a use after free. Hey, and it doesn't, like, it can be triggered by user namespaces, right? So
That's pretty easy to implement the tooling.
yeah, we already do with our own scripts, but I don't want to go fully parsing this full text script again and again, because sometimes words change, and I mean, my model is not that flexible.
That's
So
the same problem as we have. That's the same problem we have.
yeah, so thank you.
You're a general purpose distro. Yeah, good luck. There's that problem. Just fix them all.
Yeah, I guess for the record then, yeah. As distros, we got the same problem. We don't know what our customers are using our distro for. They could be using it for anything. But we do need to give them some information that helps them determine whether or not they need to apply this fix.
Yeah, which is why I don't think either the CVSS score is a particularly meaningful metric. It's highly dependent on deployment, as we said, but some perhaps different tags could be, right? Like the ones changes talk about, for example. I think Brendan or Greg?
I do want to point out for the record that all the hardware bugs, like Spectrum Meltdown and any other hardware issues, do not get a CVE from us, and they do not get tagged by us, and they do not get notified by us. That's up to the hardware vendor, and that is a huge hole, and you need to take it up with the hardware vendors. So that's something that everybody is missing in this whole thing, because we have had a lot of Spectra fixes over the past 6 months, and they just cruised by everybody. Nobody noticed. That wasn't good.
I mean, CPU bugs, yes, they're complicated, right, KP?
That's not the first wave of the bug, right? The first wave gets a lot of attention.
Yeah.
But then suddenly something breaks. You've been insecure. There's a patch that lands, and that can get a fix. Right? That's more worrying.
One problem at a time, folks.
Yeah.
Too specific, but I'm curious about the distro kernels. What are the cases where, so you said you kind of have the same problem as stable, right, which is that you don't know what your users are doing with the kernel. But you said that you have had some, like in the past, some process where you're able to distribute information that users can be downstream of. What are the cases where they don't want to apply the patch, and how do you identify that for them?
I mean, you've got, I don't do live patch for Fedora. RHEL does live patch for certain things. But does a user want to reboot? If it's something that is only exploitable by a local user and it's a system that has exactly one local user, they may not want to. There's not a reason to. It's bits like that. Sure, there's vulnerabilities on the system, but do I have to patch these now or do I patch these next month? And it depends on my use case. We've got users who are using, I mean, look, on the Fedora side, everything from HPC to phones. It's all over the map, so I have no idea what they're doing. But we at least should let them know, is this something that's locally exploitable? Is there something that's remotely exploitable? Does it require certain privileges, anything like that, so that they can make that determination themselves?
How do you give them that information at scale, or do you just do that and have them read everything?
On the
Fedora side, I really don't. I just attach. ProdSec does a lot of that work for CVEs that apply to RHEL. A lot of the things that apply to Fedora, because we build a lot more drivers and things like that, don't necessarily apply to RHEL. So it's like if we get that for free because they're doing that for RHEL, that's great. If we don't get it, I mean, I can only do what the upstream sources are, right?
This again gets solved with the threat modeling exercise. You can describe the threat model with certain categories, right? Cloud threat model is effectively untrusted code virtualized, right? A single user system, right, is another threat model that you folks have. a cellular automobile. You can have all these threat models and then assess the CVE separately for that. And there are separate big chunks of people in each threat model who would be hopefully willing to contribute there, right? And then it becomes a very rich assessment of the patch, which I think was the original intent of this CVE thing. Oh God.
I think it will be interesting to sort of map where the fix happens and what are the chances of this being related to certain threat models. That will be really interesting because that could be automated.
You guys do realize the rate of change here, right? So, I mean, this is high volume. So for you guys to keep up, I wish you luck. What's just keeping you from taking everything?
Stability.
Then what is broken in your testing to prevent that?
Sometimes gets missed that we, like as Google, for example, we take everything, but we have to remember that applying a commit to a repo isn't fixing anything, right? So sometimes that's not anywhere near enough, and we need to have an operational, organizational response, and that's the thing that we're most interested in figuring out, right?
But, I mean, from my kernel.org security position, I know we have major security things fixed every week that are now getting CVEs, and I swear 3/4 of this room will not notice. That's not good, but I can't tell the world. But I'm now telling you with the CVE, don't ignore that.
Yeah, I mean, what Brendan said is like, I agree that being closer to stable is the way to go. I mean, of course, if you can, but if you can't reboot machines, that's problematic.
Yeah, and there's some people that physically can't reboot every 2 weeks. I understand, that's fine. I mean, that's physical limitations that you guys can work on. Android has its issues, but I mean, this is my worry because I know what we fix, and we just watch the 60 a week. Review it. Give us help. We would love help in reviewing and triaging these and finding them ourselves. We take help, and we do this all in public too. You can see what we're reviewing in public ahead of time before we give the CVEs. Help us.
The organizational response we take here, is the fact that we deal with code provenance. We don't want untrusted code running without 2 layers of isolation, right? That's one way to eliminate a large quantities of bugs. So you focus on networking and you focus on KVM boundaries, and that narrows your lens a little bit, and you live patch these. But that's not everybody's model. So but hey, for Google it works.
Okay. So I don't think that's true for the clouds, for example, but for some distro users, I think the duration that we have for the stable trees are not long enough sometimes. Again, today you might have some distro users, for example, they prefer to stay for 5 years or more with the same version.
Many times and publicly, there's a whole webpage. If you want an LTS to go longer than 2 years, talk to me and provide the resources, and I'm glad to do this. In the past, that's what's happened. I'm not the one doing this 6-year stuff. Google is paying Lenaro to do this work. Google has stepped up. Now with the new laws and the changes in the way mobile works, they don't have to support them for 6 years anymore, so they're going to back off this stuff. So if other people are relying on this, step up, and if you want it, I have the infrastructure for you to help. I'm not in this alone. But realize the older the kernel, the more work it takes. And I will argue people on those older kernels don't really care because we have known major security bugs that are not fixed in them, and it's public knowledge, and nobody seems to care, that affect almost all these use cases. So nobody's caring about that. I will call Android for actually caring and do backport it. But Android, again, so 60 a week, I did a math, 4. It's averaging 4 a week for Android that affects their systems. And actually, that's better than iOS. iOS is 5 to 8. So look at your model.
One thing I've talked with some people about is being able to pick which is more work or less work is what you want to go after. What's less work is examining every flaw against your threat model or fixing why you can't use stable. And if you don't want to have flaws, that's the choice to make.
I think we use stable, but the reboot and update cadence becomes an issue. So we need to look at everything and see what affects more.
So why do you need to reboot?
Sorry,
why can't you reboot? That's what I mean is, what is more work? Doing that piece or fixing the process? That's
I think both. Both are complicated problems, right?
Right, yeah.
And you tackle it with both.
Neither are easy.
If you're cherry picking individual fixes, you still have to reboot.
No, like
That works with everything?
Almost.
Okay. Okay. So what I don't understand is why it works for 50 backported commits, but it doesn't work for a merge commit.
Time, the effort.
Okay.
And live patches are also, they take time to query, right? You have a thread sitting somewhere in the corner with the old
Okay.
symbol.
So more patches, more time, and that's exponential.
Ops load for every live patch.
Okay. All right.
So I think what case I wanted to say, just 1 second. It's actually, the flaws have categories, right? So the best is to eliminate the categories of the flaws. What you've been doing painstakingly with the Clang, like compilers to eliminate, like, hey, no out of bounds here, more strong type checking. That is the actual way we get rid of some of the others.
Yeah.
So
I'm trying to make this number go down.
Yes.
And you are making it down, and Russ will make it go down a little bit more.
So in the deeply embedded space, what I mean by that is basically not Android, but real Android stuff that goes in hospitals, for example, there's certification, and you cannot just change software every week, right? So the problem is that if there's a really serious security issue, you can pass it through the certification process, but you can't like let in like hundreds of changes just because they might fix some flaws. So there's an issue of categorization here. So yes, you can say the certification process is broken, but it's kind of the compliance discussion that was there earlier. It exists, it's there today. So how do we deal with it?
This government knows this, and they are working to solve that because their cybersecurity work is, they're changing the laws and they're changing requirements. So at least the US government, the EU government also understands this with the CRA, and they're going to be mandating, and they have special categories and what they must and must do, and they must be able to take updates and retain certification and quicker certification stuff. So the legal infrastructure behind that is changing. It's going to take time, though.
I think, no, you changed.
We've got, excuse me, we have 5 minutes left. I'm wondering if we can make any action items. How are you actually going to move forward? We've had a lot of discussion. Can we wrap up? Can we? How do we move forward?
The sort of approach that seems to be the most reasonable one, according to this discussion, is let's do something like idea one. So let's define threat models, separate ones, one for cloud providers, one for distro distributors, one for, I mean, everybody gets a threat model. Who wants a threat model? And then the analysis is then to be performed based on those shared threat models. Now, where these threat models get published, how we get people to actually contribute, that I think is something that is yet to be discussed. I don't know if we can do it in such a big room with so many opinions and so many companies and so many different use cases. But at that point, it becomes a problem of the single threat models. So the cloud people can address it one way.
What's the next first step? Is it a mailing list? Is it an IRC channel? How do we now communicate and take this out of this room?
Let's do IRC, right? Apparently, there is an IRC already existing.
Yeah, but are you happy for us to take that on? Take that over?
So the IRC channel we had which has current product security from Red Hat, SUSE, Fedora, Gentoo and stuff, is hashtag distro-security at Libera. It's sort of an open channel, not a lot of discussion happening there, but I think it's a nice venue to do this. Another option is to use the OpenSSF Slack, because there is a vulnerability disclosure working group there, and it could work as a SIG. Personally, I'm partial for the RC channel or a mailing list, at least.
Linux Foundation had on from a legal point of view, be very careful here. There's antitrust issues. That's why the Linux Foundation was formed. We can talk about this in public, in a form of a trade organization, having closed channels. You enter into monopolistic issues where the lawyers do not like. So make sure it's done in a way that's open and collaborative and that follows the lawyers of our companies care.
Yeah, no, of course, yeah.
Closed IRC channels. Very, but you know, it's just
So,
very
so the next step is we'll try to keep an eye on the mailing list, Linux CV announce. We'll try to list a few IRC channels that you can join. Maybe keep it simple, kernel security, right? And the other one is Damiano and others like at Google, there is a cloud LTS project we've been trying to get off the ground. I think there is enough shared interest in the room that can be bootstrapped. We'll share some GitHub links.
Are you happy for that to feature creep and become cloud and mobile and IoT OTS?
Exactly, yeah.
Okay.
That's the best name we could come up with because
All right.
we are biased.
Can we change the name?
Of course. We do that all the time.
All right.
Touche. That's true. Yeah. Well, now there's 1 minute left. So does anybody have anything else that they wanted to share with the room?
I think we should have CVEs for every Cisco level.
We almost do.
Can you move out of the way?
Every unfixed Cisco bug.
Yeah. Oh wow, yeah. Good luck. Good luck.
Yeah.
Oh, he said yes.
We seem to all agree then.
The goal is to address the weaknesses, right?
Yeah.
Okay.
This is very. I'm so happy that we have company and camaraderie here at least. Not alone.
Yep.
Indeed.
All right. Thanks everyone then.
It's
Let's go for
lunchtime.
Remember the time NFS4 was just blowing everything up? There's like the NFS thing that was like scrambling over memory addresses.
Oh yeah.
And then we were just getting like just sysbot count. Yeah. Like 1 a day, 2 a day.
I know that Dimitri tends to catch a lot of those. And just like, oh my god, I saw a huge spike in random crap that couldn't possibly happen. What is going on? And you're like, figure out like, oh, this commit from here forward is chaos. It's like a wild memory corruption.
Yeah.
Makes sysbot go nuts.
I was. I did do my own works from it. If you have any questions, let me know. I was pretty guided into there may be something that I missed.
Well done. Very good. Nicely handled.
Yeah, I did my best. Not the easiest with so many voices in
Well,
there, but
yeah. But well, it's a BOF. It's not a presentation.
It is.
If it was a presentation, I'd be upset. But the whole point was to facilitate discussion, and I think we had that, right?
Yeah, I think so.
I like the fact that we had lots of points, and you still summarised on the thing that you wanted to push.
Yeah. Somehow. Yeah.
Now I see the real reason. Nicely done.
So you feel unhappy? No, I'm not sure. I used to work on that compiler. So yeah, we have to follow
Okay.
Nice to meet you.
Oh, okay. No, he left.
CV integration.
Yeah. I'm not sure how it's going to be. So yesterday I gave a quick presentation. I introduced myself. Generally, I can fix anything. I fixed it.
they maybe
I have this conversation.
Greg and I have got
We should also I was doing some security work. Doesn't matter. A few times. Mirror measurements.
We only review safety.
If for some reason you have fixing a typo, do you
Say again.
a typo?
Okay.
So it's not a real change.
Yep.
How do you identify that and say, oh, that's not a signature?
I just
You check everyone?
Yeah, everyone. So I will read that and say that is not CVE, and I'll press the correctly binding thing. And then I'll read another one and use off the yes. Read another one.
Then you have some automation to generate.
How do you
Yes, we absolutely do that. I'll tell So I'm the only person that review scripts and review helper. Greg uses Muck, so he's reviewing upstream package, and Sasha uses ML and then just reads the GitLog. Then there's a voting script that pulls in the yeses, sees how many people contributed to the vote, and then we take a ratio. It used to have to be unanimous, and there's 5 reviewers, 3 out of 5 have to say yes, something like that, or 4 out of 5. And then, it gets piped through those results then get piped through a script and rates the CVEs and then makes fairly manual, but there's help.
Yeah, there was like a CVE. Is there any room in there in this process, for example, to include more information? Because, I don't know, we could have information.
The only information that we have is that
No, actually the change itself. So it's mapped to with options to drivers.
To read the code.
Yeah. Again, that doesn't need to be done by upstream.
We don't do that at our level. We're already doing the most we can. I'm already
That's why I'm thinking about that.
However, and overlays will be the answer. So we will publish it, and then we can update the JSON that we submit to MITRE, and then that can provide additional information. And I don't know if the tags that Greg's talking about, but there's a bunch of tags that we don't use in the JSON, and some of it is correct. So we put in the description, when it was introduced, when it was fixed, how it was fixed, various other pieces of information, which you can see on the MITRE website. But there's relevant.
But that's manually.
By JSON, however it is. So you probably have some tooling to add it, and then you re-upload the JSON and then add an overlay.
Yeah, because I'm thinking if we have the information for the system that CVE is the function, the clouds, they don't need to care.
But that's at the next stage.
But you're considering to have something.
We are
discussing about it.
Yeah, we're considering that we will take that information from another group, this group, and we would apply that. But the amount of review that we do, we're not doing any additional. But we would take it.
And consolidate.
We're already doing it.
It's like you have any time.
Yeah, it's not even my goal at the time, so I still maintain Android. This is my additional task.
You can start with looking at every file and a lot of these steps.
I've looked at this make it a bit easier, so I like each individual through highlights keywords. So I can normally get these are not going to have those are harder. Use off the word.
So I think it's impossible to have an hour.
Kind of like that relies a lot on how well you relies on how well.
Sometimes they don't provide the fix, and they don't provide the fix things. For example, some of the defensive people have to figure out something. We don't know if they commit this and you have to commit run predictor and you draw.
The biggest issue that I see at the moment is all this work, your work has been duplicated by other people.
We don't have the process right now to feed that information back to you.
Well, that's what
You're right, but we don't have anything right now.
Well, we have email. Nothing is set up. There is no that's what that is doing, Canonical is doing, Oracle is doing, and you're all in silos, and you're all complaining. You've actually got this massive pool of resources, but you're all doing exactly the same thing.
But that's why we need to have, I'm saying that we need to have
Well, that's what
process.
Because when it started to be like that, everyone was assuming that they can handle this regularly. And then suddenly we found ourselves on top of the mountain with the biggest event. How did I come up here? Like, and everyone is on different hill.
I think it was a bit more complicated. Nobody knew what was the amount of CVs.
Well, we didn't know. In fact, if I would have known, I probably would have done it.
To be honest, I wish that we had that discussion before.
The discussions did happen. I understand the latest of Greg been having these discussions with predominantly Red Hat.
I still have one.
Oracle and Brothers, and then it was like really
and then like they get pretty good at like making policy packages that influence the more complex architecture. But it's still like, especially one is just like you have an if condition. I mean, for sometimes like we receive some MIPS, for example, that you can make
That's hard. That's even that is
really there's several things that are really challenging. Severity analysis, which they to do one patch, it takes a security engineer. Yeah, I remember those like we don't support
what else?
What else?
The rest collaborate in problems of trust, because you will have to trust the neighbors.
For example, sometimes we don't have or that introduce the problem, so we can share that information together and we can consolidate that through. We have a process, for example, to fix that.
Even that is not always some cases easy.
Sometimes it's not easy, but you don't need to do it every time. If you cover 80% of all the CVEs that don't have the information, that you have a
That is fairly objective.
Yeah, most of the time. There are some cases that you have a combination of changes that you want to get time. And it takes a very long time.
I mean, it's almost like you should see very objective, right? Because statistical stuff depends on how pessimistic some person is. Nah, maybe it doesn't. I don't know. Just the capacity and checks that move down the ground. I said, hey, sometimes someone comes along and they anticipate it and jump on this particular function, and then they take over the whole network, and I have no idea.
Sometimes you can tell that
but we don't know that.
No, because maybe the other thing is if take production.
well, in some cases you know.
You start the fire, now it's burning. Nice. It's okay, I think I have 5 of them. Everyone, they are not alone and everyone has their own perspective and own. Even Greg said,
Yeah, we also if it's 60 per week, and there's 6 companies, like I actually do the job I want to imagine if it's heavy. So, and if it's more than 60 but yeah, I think the config on I understand what you're saying.
and there's also lots of other CVs coming from driver vendors and other.
Of course. But I mean, I hope what is because we've been trying to get for us, we have I think people don't want to be on board. Don't want to invest on something. Dedicated. So the point is, companies' motivation to be like, okay, let's try to use it because we think it's exactly. And so far, this has happened. I hope on board, whoever we can.
Without trying, we cannot be sure that it wasn't doing it. Anyway, this might turn out to be a great justification for dumping the whole CV. Like 2 years later, matches went, they tried this, it didn't work, so you have to accept the fact that you need to get actual patches. So it's true, and then you have to justify.
I guess for us it's not so much we already take everything from us.
Yeah, we do, but
it's not right. It's just way to make. Yeah.
One point is actually getting
But also for us it means like, does it have to be now, or very urgently, or can we just, whenever it's get ready?
So we can just, sometimes we look at an issue like, yeah, let's get it 60. Well, then it's on a river base. Some other times you want to be like, oh, packets on the internet can crash everything, but maybe we should just like, the net differentiation is
the worst moment is how much we use it, and then I look at the board and say that we cannot use this in the next cycle, which is going to be 6 weeks from now. That means we have 7 weeks to do this. And everyone is now going to try to POC on their machines and go, hey, you are vulnerable. Look, I got look. Okay, I know. It's going to get there soon. I know. I can immediately be able to patch to you. Or it has to be done, right? Yeah,
Like, I wonder, I mean, the question is like, how, I mean, they get a lot of submissions, so, but is there also like a differentiation between, we got this through someone who's saying like, hey, I know how to break the system, or is it just something that, yeah, we found a bug
I
or...
think those days, but
yeah,
we should ask for
because that might be one of the tutorials to say like this is something more severe than the
I
other.
think this is one thing, but then the CVs are also simply just assigned by looking at them, see them stable.
They are the publishers basically. So you set the commit was backward to the stable, and he released it and said, hey, this might be a vulnerability. But all you have no idea that it was a stable or not, because the problem was not security aware anyway.
Frankly, I'm not with how easy and person writing the patch is the best person on earth to know how that code looks like and how, like, I mean, okay, maybe you just like testing this, right? They have their own test, whatever, but they have a better idea of whether, at least they can get there faster than anybody else. If I look at that code, it will take me a while to understand if I will never understand what's going on, specific function, which certain function calls from systems, the fact that so I think it's a pity that took information is but I acknowledge that it's complicated to get it. This will be materials of other problems.
Yeah, I just but sometimes send emails to the page of the saying, hey, can you please send me the POC forms? And they say, not really, sorry. Okay. I mean, I know, I understand, I don't trust anyone like that, but I have no way of testing this because I don't know the flow. It takes 13 different IOCLs to reach the
I mean, I also work a bit on PostgreSQL on trying to combine, and sometimes I have like 100 entry points for user available entry points. Some are going to be, some are going to require privileges, some not easily, right? It's complicated, and then who knows what kind of user space program these guys have.
They run their own syscall instances and then boom, they come up with something like this and I go, hey, there might be a reproducer, it's a private syscall.
I mean, for like user and like end user lineup, right? If you tell me that I have to rotate, that's not really like I can rotate. Do you have a mechanism to hot patch? So,
Only for x86. And only for certain changes. Because
that's always.
Frankly, I had a brief moment working on live patches and I think it's voodoo. I don't really like the concept of changing function pointers live. But then again, we have, and it's also available for individual users, right? And you used to don't look at it for live patches. But not for everything. For CV and
also it's usually what gets tried to tell the customers all the time. It's just live patches, just so you can choose when to. But there's a lot out there who know that okay, I never have to read it again.
Yeah, it's very hard. I mean, Ben simply just copies the whole driver sometimes. He changes it so that there are no inlines or statics all over the place, so we point to those. It's a mess. I truly don't understand how this is working at the moment. And I still don't understand. Like most of the clouds they are working on stateless when you think about it. They can just delete them all.
It has always been like this. I can't tell you exactly, but our machines are so overloaded that they have stuff running on them the whole time. And the problem is that whenever you're taking I mean, you can't go one by one, right? You have to go by side by whatever Google is telling you were using. Yeah, then we have SLA and SLOs and it's actually have machines that have enough time of years.
0.00099999.
I mean, the problem is live migration. You need live migration for that, and that is kind of.
That's another kind of one. Let's go and enjoy the. Thank you so like this was wonderful. Thank you. And let's keep on touch.
I mean, I'll be around today, tonight, and then you can
I mean, it's we were attacking on 3 different fronts to that side. And
so you could actually, I don't know, I think we needed to have that before the change, like that, because now you have a bunch of like running users, companies,
the way I understand it,
trying
is that at some point they just did it. They didn't really ask, shall we?
No, exactly.
But
that's done. There's not.
But there's regulation.
Yeah, it was not.
But again, we're learning about that now. So.
And now you know who is winning? The vulnerability companies. Yeah, they're just saying lots of inspections for 25 grand. They say, hey, you're vulnerable. The report costs 30K, sorry. And then I say, oh, look, you are vulnerable to our CV. Nice, thank you. All they do is change, like, scam change. Yeah, let's go. Thank you. See you.
We should have people whose full-time job is just trying to.
Can we not have at least one or two?
No, but I'm not positive. That would be a positive. If we do, they don't seem to find anything. Because they should be filing CVs on bugs.
Because other companies that I've worked for, they all have them. Well, so what my biggest concern about all this stuff is Red Hat has a new product, LAI, and it's doing all this AI stuff, and cybersecurity can't even, they have zero time to even think about that.
You're just like trying to like store metadata about
But what's different?
Yeah, but then you don't have to like have code to.
So Matt actually is making them, makes the safety issues to be assigned SLAs, like severity, all that stuff, and he wants those policies for the safety issues to align directly and keep up with how CVEs are handled by Red Hat. And I said, that is the worst idea I've ever heard in my entire life. And then I said, I'm leaving this meeting, and I left the meeting. Because I was like, that's not happening.
Yeah.
And there was one product security guy, and it was like a 2-day, 4-hour security meeting for Rally Eye. And there was only one product security person, because all the product security heavy hitters and other were in our channels inside.
So your database is going like, oh, I've got these pages that are like, my database level patch. Double those pages, but you don't like.
I mean,
you don't.
They already have CVs coming.
There's
a lot of attention to design.
There is, but that doesn't mean it's not exploitable. You know how many CVs where I get from a guest access data on another guest running in an isolated host? I mean, those come out every few years. Or
Amazon, AWS is all over those because.
right. Or I'm running the host and I can access all of the guests, or I'm the guest and I can crash the host, or.
Yeah, but that's a perfect example though, that's exactly what people are thinking, and probably why product security is not even paying attention really to.
But my point is, if you focus on the container part, well, I
Not necessarily.
No.
It's impacting the raw AI application.
Yeah. Yes.
Well, and RHEL AI is more than just a container. It's got a kernel, it runs on bare metal, and then uses containers for things like.
But I thought that was partly because it was
Is it? I thought they were both separate kernels.
I'll find out soon, because I'm assuming I'll be building that.
Oh.
With Jared.
They keep talking about that. Yeah. But at the end of the day, like this, what I was in a meeting with Gunnar, and like we're back, and Gunnar's like, yeah, he goes like, we keep thinking that's the answer, is to build all these different kernels on.
No, it's not the
And
answer.
he goes like, it just bites us in the ass. So, automotive has a custom kernel, but for specific reasons. So if RHEL AI does that, if they're going to say, they're reevaluating their story, saying, we need to show that the RHEL kernel isn't good enough for RHEL AI. And if it isn't, we need to have a clear reason why and what we can do about it. And it's not going to have four kernels, one for each vendor, it's going to be one.
It shouldn't even be that. It should be the RHEL kernel. And anything that's missing for AI right now needs to be put into the RHEL kernel.
And that's, in the last couple months, Gunner's been turning, thinking about in that direction. That the RHEL kernel is the answer, you need to prove why it's not.
Automotive makes absolute sense, because I know what they're trying to do there. They need a separate kernel. That's fine. But RHEL AI doesn't need a separate kernel.
So
and I already told Matt that Fedora doesn't need a separate kernel for AI.
So the idea is if you get RHEL kernel, RHEL base, and these put AI containers on top of that, if you just, as long as you keep RHEL secure and stay on top of that, RHEL AI gets.
Yes, mostly. basically any bugs in LAI would be OpenShift bugs. Any real security bugs there would be OpenShift bugs. And that's, I mean, they go into that product. But there could be something in the container that lets you exploit memory in some way that's unique to RHEL AI, or to the containers we're shipping with RHEL AI, that, yes, they're OpenShift bugs, that they need to be fixed in OpenShift, but
They also, the scary thing about that, you know, I was telling you that some of the people on the team, you know, well, most of them don't have computer systems background, like it's all computer science stuff. And in the Slack channel yesterday, I saw Christian Himes having to explain to every single person what DRAM was. And I'm like, this is so embarrassing. Oh, RAM, they didn't even know what that, they didn't know anything. These OpenShift is so, sorry, I don't mean to like be mean like that, but like, they just.
That's the advantage of a lot of the old folks though, in the kernel side, most of these guys are.
They also don't teach it in computer science curriculums, and that was like a huge reason why Joel and I started Kernel Development Learning Pipeline, was because we started to notice like RPI has an amazing curriculum, but they're a victim of this too. They, in their computer science curriculum, you only are required to take 1 C++ course and 0 C courses. 0.
I like computer science for like the building on computer. You want to start building
Computer systems or computer engineers, not computer science people.
Yeah.
Computer science people just like to do like fun little coding things, or I mean, I have people that, you know, I forget the language that's used for data analysis, but they're like, I'm a computer scientist, and I'm like, no, you do like finance, like you just, you know, wrote a couple lines of
Visual Basic.
Visual Basic. Like that doesn't actually count, but it's like some people are actually getting degrees in computer science and only know like languages like Visual Basics.
Well, I mean, there's a lot of people who are they're just in it for the money. It's not a hobby, so they've never like taken the time to study or learn. And I will say, I mean, I've almost always built my own computer systems, but these days it's actually a little bit more expensive than just buying off the shelf. So you have to really want to do it. It used to make more sense. Now it doesn't. It used to be cheaper. Now it's the other way around. So. Framework is basically a modular laptop. I mean, you still buy it, but you can replace all kinds of parts in it. So, they've gotten rid of I was about to say they got rid of a lot of that for a while, and then they're bringing it all back because they want to get smaller. So, which is why now like you can't upgrade memory a ton of people.
Even though you kind of look at a phone, like you're trying to figure out how to make these smaller, I think we're trying to fold in memory into the CPU chip or something so that reduce all the components so they get more space on here.
Yeah, so the problem is the biggest component is the battery. And to get more battery, they need to do that. There is a company that's doing technology behind the battery. I think it's aluminum oxide or something like that are, they're in like gel packs, so they can fit into any size they want. They're, what's it?
So they can just spread all the open space.
Yeah,
right?
they can do it into the open spaces, but if you, when they replace an iPhone battery with their battery, it's got 4 times the capacity and charges in 6 seconds. Well, the biggest problem with lithium, with the batteries that we have in our phones is they're unstable. So you can charge really fast from like to a certain point, but as you get higher and higher, you have to be very, very careful or they'll explode.
That's why they eventually the first 5 or 10% is really slow, and from 10 to 90 is fast, then 90 to 100 is
really slow again, and they have to do that for the safety of the battery. But these batteries are stable; they don't have that issue, so you can dump as much power into them as quickly as you want.
These patterns aren't scalable, right? Is that why they're not really going out?
They are scalable. It's just that they just started going to production. I think last year for some things.
So there's a lot of cool battery technology that's still in the research stage. I think they're just improving out.
мема включая, что в продакшене есть. Нету. Yeah, been told that everything we're doing in Blue-based SAN is wrong. What? Everything we're doing in Blue-based SAN is wrong. Why? We should use user folder D. That was David H. Who is, at least he produces impression of a knowledgeable person. So instead of doing prompt, yes, he said like, no, you don't do this. And he's actually has a student who's doing rewrite of ifans using memfd, and he said that he tried to run bash with ifans, the original one, and it takes 15 minutes, but with memfd it takes 10 seconds. User folder T. Because why is it better? Because mProtect it splits VMAs, it creates VMAs, and ifans it creates 10 million VMAs, and it does it on every modification. But with user folder T this does not happen. There's a single VMA and there's like you don't touch MMSAM, you don't change. And then how does it protect the there's something, so you get notifications. I don't know what's like effectively the page is protected, you're getting notifications, but the VMA state stays the same. And I will ask him for the code for use. And for the Quasar emulation, for the TBI emulation, well, basically he said you intercept fork with different fork of the interceptor, and you call it. Why it doesn't work? I tried this for the BPF, the user space BCPUs, it doesn't work. And what's not working? There are some weird libraries which don't use pthread at fork, and we also have death test. Death test uses clone, and it doesn't work for those big pipelines. So I tried pthread at fork, but it doesn't work because there are some cases which bypass.
Do you have one for microphone? Sorry? Do you have one more soft microphone? No. Like the CV time discussion, it was mostly the discussion between two people.
I know. I will check.
Thank you. Like it could be not easy to connect and other stuff. Just asking just in case.
Yeah. So who will rewrite with ASAP? We hire Matthew to do all of the kernel work, and you can do with ASAP.
upload the slides, I have to make myself presenter temporarily and upload the slides, right? Okay.
The thing is, I'm not.
I will try.
I'm not responsible for it.
Yeah.
The thing is, you can upload your presentation somewhere, and then you have it on that computer that is connected right there.
Yeah.
That's what I heard.
I'm gonna try this.
Should we ask somebody else?
No, I think I figured it out. There we go.
Okay. I like the way you sort of requested by.
Sorry?
Just requested by just alphabetically.
Yes, it's easy, right?
The best possible.
How do I next slide in this thing? I'm not. Ah, right. Good enough.
Hey, Marco. How are you? All right. So, what do you need to do?
I guess it's just if there are questions, tricky questions, or if you have, for example, yes. So I have a slide on discussion points, and one is, where does the sanitizers work well for you? And if there's no one that wants to say anything, you could say you've had great success with sanitizers. That's what I see.
All right. Yes. Okay.
Yes, I wonder the hazard pointers though. Why didn't you say that it's possible to remove the barrier on the weak side?
Yeah, I did.
You did?
I filled the battery with health, if that was possible.
Thank you.
Oh, okay, but though, as you just said,
You
listed
can't,
on the
you can't,
slides.
yeah, in fact, what I said is you can, but the real-time guys don't like it much, so you have to be able to do it both ways, which is fine. The guys don't like the extra IPIs. So, that's what I thought it was, but okay.
No, if you
Yeah, you just put that there and there and there, and yeah, update side, round IPIs.
Or wait for those.
We can log in first, you as the user.
you can log into the source, they sent the email for us.
One of the advantages of hazard pointers is that you have less update side delay, and therefore you can clean memory up quicker.
Yes, but on the when third memory files up, right, by those fixed.
Yeah, you could use a hybrid technique where you avoid memory barriers or something, but then you still have a delay. You have to wait for everything, and then you have to wait for everything to get on board with the protocol. And you could use IPIs to make that happen.
But even if you have full barrier on weak side, you still need to wait for the object that you as a filters.
The thing is, the cool thing about doing it that way is that you can free everything that's not pinned right now. Without
Yes.
waiting for anything.
But this is
Okay. Yes. Gibt es Fragen oder?
Na, die machen was wollen. Ich fahre das jetzt alles mit der Hand. Ja.
Yes, but you still don't reclaim unlimited amount of memory, which is yeah. But no user like actually care or know about any of it. I disagree. Okay. If you're out of memory, you want to clean up everything you can now. So how much will you take in bytes? I really have experience for failure communication between I'm not sure how to put this. Look, if you're out of memory, you want memory back. And you can't have the stuff people are actually using right now. Yes. But you want to have all the stuff that they were using, 100 microseconds ago, and aren't using that while back there. Might not be. Yes. There can be also memory that is used, so you still can replay it now. Well, yeah, but the thing is that back in the day, you could just give up on the memory. You should just not have the out. If you use that line of reasoning, you shouldn't have memory processing whatsoever because we're not getting it. We do, therefore we do care.
Is there someone announcing that we should start? Or we just
You are. You are.
Okay. Okay. So yes, hello everyone. This is the BOF session on kernel sanitizers, and actually that's also followed by the BOF session on Sysbot and Syscaller. So both of them are this kernel sanitizers, and Syscaller and Sysbot are closely related. So it may be that there's some discussion from bleeding over, but it's up to you, I think, how you want to shape the discussion. So I think I wanted to give a brief introduction on all the sanitizers, maybe to jumpstart your mind. But if you have questions right away, please feel free to ask whenever convenient.
Does the mic work?
I think. Hello?
Yeah,
Okay. Yeah, it works.
Okay.
Maybe we should.
I just didn't hear it.
No, we just turn it louder.
Okay. Right, so I think I'll just, again, feel free to interrupt at any time, ask questions. This is what this is about. But again, I will introduce all the kernel sanitizers that we have. And in fact, the last time that I attended Plumbers in person, this was in 2019, I think we only had KA-SAN and some form of UB-SAN. Since then, we have grown several other kernel sanitizers, in particular KC-SAN and KM-SAN. So what are the sanitizers? So they're ultimately, it's a form of dynamic analysis. And what we're doing is we're analyzing a piece of code as it is being executed. And dynamic analysis typically will point out system errors or failures. They will very rarely be able to tell you what actually is the bug that caused the error that is being reported. And the quality of the diagnostics or the reports that it's showing you is often also inversely correlated with the performance of a tool. And that's actually a big part of what the sanitizers are doing versus more bare bones mitigations, is to record state to be able to tell you as much useful information as possible about what's going on in the system so you can actually debug and root cause the issue. And one
important thing to note is, yes, with dynamic analysis, you're only analyzing the state space that was covered during execution, and that's why it is so important and also very powerful to pair dynamic analysis tools with a very good fuzzer or tests to cover as much of the state space that you're interested in as possible. And most of the sanitizers work by instrumenting the code that is being analyzed with the help of compiler, and then there are various runtime components, all part of the kernel, which essentially use these hooks inserted by the compiler to do all the analysis. Most of these sanitizers are about finding undefined behavior. And well, why is this? Where does this problem come from? In the beginning, I guess most of you probably know this, but C, as designed, it was for fine-grained control over very low-level details, and it's a trade-off, right? In this case, the language simply says that some well-typed programs are undefined. It's resulted in a simpler type system with higher performance. Ultimately, safe languages with manual memory management are rather hard to design and implement, and I guess Rust is an example of that. And one of the most critical kinds of undefined behavior that I guess we have are memory safety errors, and these are also the types of errors that lead to a plethora of vulnerabilities and ways that our systems can be exploited, especially if these types of memory safety errors are in the kernel. And we have various types of memory safety errors. I'm sure that you're familiar with out-of-bounds accesses, where we access memory beyond the allocated memory. And this, again, may read random data, corrupt other kernel state, and allows potential attackers to control the kernel in unintended ways. The other kind of memory safety error that is rather critical are heaps use after freeze. We're accessing recently unallocated heap memory, and again, we can read random data or corrupt the kernel state. Similar, if you have memory on the stack and you try and pass a pointer out to somewhere else, and then you deallocate the stack frame, again, this can corrupt the kernel state or read random data in various unintended ways. And one of the tools that can help you with these is KASAN. KASAN helps you detect out-of-bounds accesses, heap use after freeze, and stack use after returns. And there are various versions of KASAN implemented over the years. So the default mode is the generic mode, which uses the default compiler instrumentation and rather heavyweight shadow memory to maintain state of basically what's allocated, what's not allocated. This is only for debugging kernels. There's also a software tag-based mode, which uses new features of CPUs, in particular ARM top byte ignore, or Intel LAM or AMD UAI. But again, the hardware for this isn't that widely deployed, so by default, KSAN will use the generic mode. And then we have the last variant, which is the hardware tag-based mode, which requires a CPU with ARM64 memory tagging extensions. And this is, in fact, usable in production kernels, but again, the hardware for this is rather sparse. If you do have a Pixel 8 or a Pixel 9 in future, then you can actually enable this. And there's another dynamic analysis tool which we've developed, which is called kernel electric fence, short KFence, which can detect heap out of bounds and heap use after free accesses. It's a low overhead sampling-based memory safety error detector, so it won't detect bugs deterministically, but it was designed for production kernels with low overhead to be deployed at scale. And if you deploy this across a very large fleet of machines, you will over time cover enough code to find lots of bugs. And I think we've had great success with this. Also, if you do a Google search for bug kfence, you will find various bug trackers where people have reported kfence errors in the kernel over the last few years. Uses of uninitialized memory also can lead to reading random data or even old data from recycled memory, and this can also be used to exploit the kernel in various ways. Yes?
Can kfence be used with any of the other sanitizers in the same kernel at the same time?
Yes. So kfence is in fact designed to be paired with any of the other sanitizers. The various compiler-based kernel sanitizers are mutually exclusive, so you can't pair, for example, KASAN with KMSAN, but you can enable kfence with all the others. Right, and then, well, again, uses of uninitialized memory can also be used to leak sensitive data, especially out of the kernel. If there's some secret data somewhere and that data is ending up in a copy to user, you may actually end up leaking sensitive data. And one tool that can help with that is the kernel memory sanitizer, KMSAN, which is a fairly recent addition to the kernel. You can enable it with config kmsan equals yes, and I think it requires a relatively recent version of Clang, right? It doesn't work with GCC yet. Alex? Yeah, okay. Yeah. So kmsan, you need a relatively recent version of Clang. Again, this is only for debugging and testing kernels because it allocates huge amounts of shadow memory, so to keep track of the state. One thing to note is if you are worried about uses of uninitialized memory in production kernels, there's this also, it's a mitigation option, config init stack all 0, which uses recent compiler features to initialize all stack memory by default. Data races. So another class of bugs that are, I think, a lot harder to understand versus the, I guess, the memory safety errors are data races. And the Linux kernel has its own memory model, and that also defines when data races occur. I think I won't go into too much detail here, but if you have questions later, I am happy to also discuss that in more detail. But in short, if you do have two concurrent conflicting accesses, and they conflict if they access the same location, and at least one is a write and at least one is a plain C access, then you have a data race. And this can lead to various, well, unintended consequences as well, depending on what the compiler does with these accesses. And it will also, so data races are also a symptom often of, for example, missing locking. And it can be one of the hardest kinds of errors to root cause. But we do have a tool to help you detect data races, which is the kernel concurrency sanitizer, KCSAN. And you can enable that with config KCSAN. And the default config is relatively conservative, so there are a bunch of options to reduce the number of data races reported based on idioms that have been common in the past. But if you're paranoid about concurrent code, then I do recommend enabling config KCSAN strict, which enables more strict checking and can actually also find cases of missing memory barriers. Other types of undefined behavior. So we do have the undefined behavior sanitizer. I think, I don't know if Case is here. If you want to talk about this, then go ahead.
Yeah, this sanitizer is made up of a bunch of much smaller individual checks, whereas the others are much wider and cover a lot more. So we have a couple that we can actually use in production for finding out of range shifts and bound array index violations where they're out of bounds. And then there's some more pedantic ones that we can't really turn on the kernel yet just because we haven't solved them all, but you can find them with those. Under development is dealing with integer overflows in a way that is meaningful to the kernel. The existing sanitizer options are extremely strict. Doesn't work well with the kernel. And then there's the behavior for trapping. If you emit only a warning and continue on with whatever undefined behavior was going to happen, continues. Or if you trap and just kill that running thread. I don't remember if I have another. Oh yeah, I cover each of these. So in normal case, you're going to have a kernel image that's about 5% larger just from all of the instrumentation, strings, and everything else for giving a much more readable warning for when you trip over anything out of UBSAN. So for example, this is array index out of range. The index was 7. It was for this type of an array that had only 7 in it. If you run with trap, you don't have the change in image size, and you get a really terse output which says, oh yeah, the class of problem was this. Go figure it out. So in the shift being out of bound, we're going to catch negative shifts, and we're going to catch interference with the signed bit. Like when I checked, we had like 110 of these fixes in the kernel over the last 5 years. It's like almost all of them because of syscaller, which is great. And then UBSAN bounds, again, this is either finding a fixed array size index violation, or more recently we can do this counted by annotation, so we can actually do a runtime check of array indexes that have been specified at runtime. So we've got about 93 fixes over 5 years. This does depend on a lot of the refactoring work that we've done recently in the kernel to get properly well-defined flexible arrays as opposed to all the stuff that have been used for decades to approximate it. And then we should talk about semantic faults.
All right, so I guess undefined behavior comes about because of the language that we're using. And but of course we do have way more bugs than just undefined behavior bugs. So I guess if you write any piece of code and you make a logic error somewhere, then you still end up with a bug and the system will not behave as intended. So these are called semantic faults or semantic bugs. And these kinds of faults basically, well, they don't cause undefined behavior, but still result in system errors. You might even crash the system or leak sensitive data as well. And the system will deviate from its intended behavior. The question is, who defines intended behavior? And I think this is where it gets tricky, and I guess in the most rigorous cases you might have a formal specification, but it's rarely the case. You might have a reference implementation, documentation, or manuals, and in the worst case it's not written down but in the programmer's head, and that's when we really have to, I guess that's when I guess we see some of the discussions on the kernel mailing list to flesh out what is actually the intended behavior. And this is much harder to detect. I guess in the most basic case we do have tests to check that the system behaves according to the intended behavior. We have assertions, warn-ons, etc. Or we might employ a more defensive programming style to avoid certain traps, for example, missing case statements, and so on. And there are also some tooling that's coming up that can help with that, and the sanitizers, I guess, are part of this. So again, I will hand over to Case.
Yeah, those are a repeat of a slide I gave earlier this week, but I talked about the sanitizers for integer overflow. We have a large collection of sanitizers looking at signed and unsigned integer overflow as well as truncation. So where you have, an integer might be being assigned to a U8, and if that value is larger than 255, you're going to get a truncation, which is like overflow but is technically considered a truncation. And the characteristic of overflow is that that's a condition, and then how you react to it is what happens on the other side. So with unsigned types, you wrap around, and that's well-defined. That is not undefined behavior. And with signed types, under normal circumstances, if you overflow, that is considered undefined behavior, but the kernel has actually enabled the compiler flags to treat it as if it were an unsigned type. So basically, you get well-defined behavior, but it also wraps around. Other things you could do on overflow are saturate or trap or do whatever. So this is effectively get the trap mode for those things. Yes?
Is there some way to flag a given integer as wanting to behave one way or the other way?
You should come to the integer overflow BOF that already happened, and if you succeed at that, I want to know how. And yes, we have. Right. There's a lot of plan that is still being fleshed out, trying to understand it. But yeah. The complications we have, of course, in this are a definitional one, like it's not undefined behavior for signed, and it's not undefined behavior in the kernel. Sorry, I said that wrong. It's not undefined behavior for unsigned types, and it's not undefined behavior for the kernel for signed types, but all of this is still collected under the undefined behavior sanitizer, which is strange because, as pointed out, this is really a sort of a semantic problem. In trying to fix this in the kernel, we've had a discussion with Linus where he was asking for the compiler to be omniscient, which we narrowed down to just trying to find situations where the compiler can, in fact, determine that you meant to overflow anyway. So there's a bunch of these idioms that we're able to detect and say, do not run the sanitizer for this because the only possible situation is that you overflowed. So you can't instrument it because that'll interrupt the intended code flow. So there's still a lot of discussion on this. And then for the kernel, we want to be able to filter either by type or by application. Like we can mark things as, we expect this expression to wrap around or not wrap around, or we expect this type to wrap around or not wrap around. So there's a bunch of stuff happening here, but it's all driven ultimately by those sanitizers that are doing the overflow and truncation.
Before I continue with this, any questions?
So, presumably some of the
There's a microphone.
Presumably some of those UB-SAN things can be used with some of the other sanitizers, or are they completely exclusive?
No, they work together.
Cool.
Okay, then I will continue also. So I guess there are also concurrency bugs which are not data races, and I will just introduce this short example. So let's assume we have a thread which locks a spin lock. And then there is a nice comment here which says, careful, there should be no other writers to shared foo. Readers are okay. And then it does a write once. And in this case, if there is another reader, that is perfectly legal. So this is not a data race because here it's using write once and read once, which are marked accesses. And this is, according to the kernel memory model, not a data race. But then you might have a third thread which does a concurrent write once to this shared foo variable, and that is in fact a bug, but KC-SAN would not tell you that this is a data race. And well, this is a bug that if you don't have any other diagnostics, it will just keep running. There are no errors reported. But KC-SAN introduced assertions to essentially say where you want concurrency and where you don't want concurrency, and it uses basically the race detection machinery that KC-SAN already provides to help you detect cases of concurrent accesses which you did not intend to happen. And in this case, the comment can be turned into an assert exclusive writer, shared foo, and it will then be able to detect that there is a race if there is a concurrent writer, and it will create a report for you. And there are various macros. So this assert exclusive family of macros, there's one, the assert exclusive writer, where it is allowed to have concurrent readers, but no concurrent writers. And then another kind, assert exclusive access, where in fact it is not allowed to have even concurrent writers nor concurrent readers. And during the initial, I guess, implementation of this, there were some discussions around bit flags as well, where it is actually allowed to modify flags, but only a subset of bits of those flags. And it became a bit complicated, so we introduced another variant of this called assert exclusive bits, but I don't expect that many uses of that, at least initially. And yes, so that's that. If you have questions. Yes.
Thank you. Nice talk. I have a question which relates to most sanitizers and user space and I guess kernel. You mentioned that it's based on compiler instrumentation, right? Like a lot of them, not all. And I guess you do manual annotation of assembly code where compiler does not have much visibility.
Yes.
And how about like third-party libraries that either completely written assembly or like users don't have source code for them? I'm sure if it's common in the kernel space, I guess maybe with some modules, NVIDIA, I don't know.
So in user space, this is, I think, more of a problem. And yes, there are cases where, for example, KMSAN, so not KMSAN, but rather the user space version of KMSAN, which is memory sanitizer, you have to have actually fully instrumented standard libraries, etc. Otherwise, you get lots of false positives. And this is a problem in user space in particular. But in the kernel, not so much, because we do compile the whole kernel with these sanitizers enabled. With modules, I think it's just not a supported use case to load a module which was compiled with different flags or compiler options or different configs and expect that to work. There were some discussions on the mailing list about this, but I think if you compile a kernel module with a different config, let's say, that doesn't have the kernel sanitizer enabled, and then try to load that into a kernel which has a kernel sanitizer enabled, we don't really support that, and we do expect things to blow up at that point. So that's
So about inline assembly, like kernel is full of inline assembly, right?
So inline assembly, we do try to handle that. It requires manual annotation. So this was actually something we, I think, only got properly fixed maybe 5-ish years ago. So for example, a lot of the atomics in the kernel use inline assembly, and back then KASAN was actually not able to detect memory safety errors which involved atomics. And we went and actually recreated wrappers and so on, and added the annotations so that if there is an inline assembly atomic, but you have, say, a KASAN, KMSAN, or KCSAN kernel now, it will add the instrumentation. It's a manually inserted instrumentation. Some of this is auto-generated. There are some complex scripts, like I think Gen Atomic scripts, etc., that help with some of this. So, but yes, it required a lot of manual effort to get to this point. There are probably still cases where we do not instrument inline assembly. We've had some cases where, for example, KFence detected a use of the free in some inline assembly, which KSAN wasn't able to detect. So there are still some cases left, but it's gotten a lot better.
Okay. I guess my follow-up question is, like, there were memory tools before sanitizers, right? And one of the first ones, if not the first one, was like Purify, that relied on reverse engineering with, I guess, all the drawbacks. It wasn't as fast like sanitizers because it uses compiler, right? It can do way more efficient instrumentation. But for cases like assembly, I think the more scalable approach is maybe try reverse engineering. I wondered, like, anyone considered doing reverse engineering for assembly or inline assembly? And it will come with a performance penalty, of course, compared to, let's say, annotation or compiler instrumentation. But is it still better than nothing? Oh, yeah.
It depends on the semantic you want. So for KC-SAN, one of the reasons you have to manually instrument the atomics, and why we wrote those wrappers, is that we need to say what the atomic is actually doing, whereas you can't really reverse engineer that from the assembly without full knowledge of all of the instructions and what the high-level intent of that was from the compiler level. So for some things, yeah, if you just care about reads and writes, you could do that. Yeah. But for some of those sanitizers, it's not sufficient.
So also, again, this depends, like if it's kernel space or user space we're talking about. So I think in kernel space, it's very hard. So and I think, as Mark mentioned, right, so we have to retain some of the language level semantics for some of the tools, in particular the data race detector, KC-SAN. We did try to actually, when we started data race detection in the kernel, there is a completely different algorithm based on thread sanitizer. I'm sure you may be familiar with the user space thread sanitizer. It uses a happens before race detector. We tried to port that to the kernel, but it just didn't work because we had to annotate so many synchronization primitives to get to the point where there are basically no false positives, and it didn't scale. So we came up with something else, which was KC-SAN, but still we required a significant amount of higher level language semantics that the tool is aware of to avoid false positives. And false positives really is what I guess makes or breaks a tool. If you, I guess, I don't know, on the kernel mailing list, occasionally we see reports from new tools, and if the false positive rate is too high, kernel maintainers will just reject it. In user space, I think there are various tools which do dynamic binary instrumentation, which are still valuable. But in the kernel, I think the main problem will be false positives.
So there are no active plans to...
Not in the kernel, I think.
Okay.
Thanks for your talk. So I have only used KSN and UBSAN so far, and I'm interested how does the sampling-based sanitizer work? So
right. So this would be, I guess, KFence that I mentioned. So KFence, so we had also after, I guess, a bunch of we developed the compiler-based sanitizers, and then the question was, okay, how do you detect more bugs, right? And I guess one thing was, okay, we can see from various crashes in production, etc., over the years that bugs do escape into production. And one idea was, can we build sanitizers which are so lightweight that we can deploy them in production? And the idea of sampling came about. So, of course, it's a completely different algorithm. So what KA-SAN does just couldn't be ported as is into a sampling-based sanitizer that could somehow be deployed in production, but the algorithm is completely different. So in KFence's case, this is actually, there was a version of this for user space first, and then we ported the idea to the kernel. The way it does it is it allocates whole pages, and then it samples heap allocations, and for a small fraction of heap allocations, in the case of the kernel, it's sampling frequency based on time. By default, it's about every 100 milliseconds. It reroutes that into the KFence allocator, which picks a free object page, returns the pointer to that, and then around that object page are guard pages, which are unmapped, and if there's an out-of-bounds access, if it would access one of the guard pages, it would page fault. We can generate a report from that. And after an object is freed, the object page is, again, unmapped. And then if there's an access to it after it was freed, we get a page fault again, and we can report an error. The devil is in the details. Actually, we did publish a paper on this earlier this year. If you're interested, it's called GWP ASAN. The paper includes details about deployment in user space on various platforms, and also the kernel, the experience we had with the kernel.
In the KC-SAN documentation, it says it can also detect some kinds of DMA memory corruption, and that's the only mention of DMA in the whole document. So if that takes too long, I can ask you later.
Oh, I think, okay, I know what you mean, yes. So basically KC-SAN So the data race detector, the way it works is that if it sample, again, for every instrument it access, it randomly decides to watch an access for potential races. But one thing it also does is it basically takes a snapshot of the memory location's value before a small sleep, and then it refetches that value after the sleep, and it compares it. So if there was a race, right, of course, if the racing access changed the value, then the value would have changed. And in the same way, so if there is, for example, a racing write to a memory location that is instrumented in, say, that's running on the CPU, then KCSAN would be able to detect that the value has actually changed. It will not be able to tell you where the racing access came from, so the diagnostics there is not optimal, but it will be able to tell you that here was a race, I don't know who the racing writer was.
So explicit barriers or the MA sync and so on, they would remove that, they would say, yeah, okay, it's from now on it's okay to change, and if it changes before you move ownership, then it's detected. Something like that?
I think maybe I don't quite understand, but the barriers would just have to, so if you do have a synchronization mechanism with your device, somehow that ensures that the device doesn't race with the CPU accessing the same location, it would detect I guess it would detect the consequence of missing synchronization. But
I think I had the same idea. So if we do a DMA from a device and we use KASAN, we should actually poison the buffer that gets DMA'd from the device. So that if there's an access to a buffer while it is owned by the device, we would trigger it because that's a bug. And also if we expect to see data from the device, but the device doesn't actually write to it, it would be nice to notice when the buffer is still uninitialized.
That's actually a great use case for KMSAN, and I think Alex has maybe implemented parts of that already, so I'm not sure what the current state is.
Yeah, so we have a bunch of annotations for KMSAN where we actually know that the page is used for DMA data being fetched from the device or to the device. We cannot really detect every like rewrite. So if say your device is constantly putting more data onto the page, we won't detect subsequent updates of that. We just mark the whole page as being initialized. In that case, we don't report bugs there. But if we say if that's a page readable by DMA, we can report uninitialized data put into that page as being leaked to the device. So in that case, we may report an error. I think right now we don't have enough of those annotations in the kernel. So there is a call for action. If anyone knows where to put checks for data being sent to DMA, please add them.
Yeah, so I think in the sync operations we have the right semantics. We should also do it on the entire cache line. So if we sync part of a cache line for a device, that means that also the part that is not given to the device should also not be accessed by the CPU, and we should be able to just mark it all as poisoned in some form, that any access to a cache line while being owned by the device is a bug. And I know we have a lot of those. Yeah.
So these are two kinds of problems. So what I was asking about KCSAN is to detect if DMA happens when it shouldn't happen, while the other one is if the CPU accesses the buffer while it's not owned by the CPU. And I actually implemented that last week, not for the kernel. Barebox has also kernel address sanitizer. It's a bootloader. So, but it has the DMA API in a simplified form like in Linux, and it works well. I poison it when I give it to the device, also align to cache lines, and I unpoison it when I get it back. And I have been meaning to see how much it will catch before I try to port it to the kernel. So it works, and I can even use it to detect duplicate things that are unneeded, which is nice for performance. So sometimes you map and then you have the same driver doing a sync into the same direction. It's unneeded, but if you check, is it already poisoned? A second poison you can detect. So yeah, I think it would be nice to have in the kernel too.
On this call to action, it doesn't relate just to DMA. There are lots of such checks in other subsystems that can be added. Also, say USB and networking and block devices where some particular data should not be accessed by the kernel, or we need to check that it's initialized, for example, when it's sent to USB devices or network. And the problem is that our team doesn't know all of those details about subsystem, and in particular details like that we should say extend the range to the cache line, because that's the guarantee in this case. So that's very welcome if you know some subsystem and you know where such checks can be added.
So I think it all comes down to DMA in the end, to the streaming API. The interesting one is, I think, we should poison the entire cache line before we send something to the device, and we should unpoison only the parts that we receive from a device. So if we have a case where part of a cache line is then read after another part of the cache line has been written by the device, that should be treated as uninitialized. And I don't think there's anything like that at the moment. I have one completely separate thing about, so one of my pet peeves about all of the sanitizers is the extended stack usage, and we get a lot of warnings from that, and some of those are actual bugs. So if we have a production system with hardware ASAN, we would actually introduce security bugs where the stack overflows. Even if we double the stack size per task, there's a risk of having additional bugs. So I had some work that I put into finding those more easily, where I have a patch to make the stack size per thread variable and then incrementally make it smaller during a test run. So if I run syscaller, I just remove a couple of bytes every few seconds and then see where it crashes first, and then see what the actual greatest stack depth is, because with vmap stack, you immediately trigger an oops and get a nice backtrace. I hope that we can integrate that at some point.
So you mean that when you mention hardware, is that so the software tags-based version?
The hardware tags.
Hardware tag. So with hardware tags, there should be no additional stack usage.
Oh, there is.
Really, Andre?
I was just going to say it would be stack exhaustion, which would run into the vmap. So no security vulnerability beyond denial of service.
Yep.
I think the stack usage you're seeing there will be due to, in the rare cases, it calls out-of-line functions, forcing more stack spills rather than because it's doing more work, right?
Yes. So it's mostly from stack spills where it uses more registers because it does more things during the same code.
But if it's the hardware tag-based version, there should be no compiler instrumentation added.
Is it? Okay, maybe. Yeah.
So just to check, hardware tags with stack, so you can do
No.
empty stack tagging?
So I think, in the kernel, we haven't added that yet. So there's no stack MTE yet in the kernel.
Okay. So you're on about what's called hardware tags, but actually is software tags.
Yes, it's the software tags. It's like this in-between thing.
It's
right?
using hardware support for tagging a pointer,
Yeah.
but it's actually using a software shadow for tags, and that does introduce a whole bunch of things.
Yes. So the software tags-based version still relies on compiler instrumentation, but it uses an additional hardware feature to tag the pointers. But that version is also not supposed to be used in production. The one that is supposed to be usable in production is the hardware tag-based version, which should not any compiler instrumentation, and if it does, it's a bug.
So that also doesn't remove the aliases between stack slots? So if I have, no?
No, it shouldn't add any, like there should be almost zero like changes in code gen.
Okay. But anyway, I found a few nice bugs where we have very deep call chains, and it would be nice to integrate that in the kernel. I just haven't sent those patches.
Cool. I think actually we have, how much time do we have left? We have 1 minute left, and then we have to start the next BOF session.
The assert exclusive writer macro, I would assume it, like developers would consider that more important than just a normal data race because they specifically added this annotation. But there are very few users of it, mostly in the RCU subsystem.
Yes.
The question is, and I guess to everybody, like, are there any common APIs where we could add it to detect bugs more widely with it? For example, RCU assign pointer, would it be an appropriate place? Or maybe there are other similar ones where we can catch semantic bugs of.
Good question. So I wish Paul was here, but he had to run to the next session. But I know that, yes, Paul very much likes these assertions, and he has added a few of them in the RCU subsystem, and I think has successfully found bugs with them, or actually while developing find bugs and then be able to develop a new feature in RCU more quickly. So yes, the question is where else can we add them? And I think this is also like the other annotations for the other sanitizers where you might poison or unpoison things. This requires developer knowledge. Where are the right places to add some of these annotations to find more bugs? I think, yes, that's basically also a call to action. If you have ideas, send us emails or patches or, yeah. And thank you. And I will, I think now we have the sysbot and syscaller BOF. Just quickly share the. So did you join this session? Microphone. Yes. No, just temporarily, so you become presenter, and then I will make you presenter. Then you can upload. Just yes. It's fine. From here. So now you're a presenter, and here you can upload.
Sorry. Taken back presenter. Now you can just control it here.
From your laptop.
Sorry?
From your laptop.
From this laptop. It's the.
Not your,
it's not mine.
So, can you hear me? Yes. Okay. So I think we can start. Thank you very much for coming. This is our SysBot Syscaller BOF. My name is Alexander Nagih. I'm part of the SysBot team at Google. And let's start. So yeah, I assume most people here are already familiar with the SysBot and SysBot reports that we sent over the LKML. But just to recap, Syscaller is a standalone kernel fuzzing tool. It appeared in 2015, and SysBot is a continuous kernel fuzzing system that also builds the kernels, fuzzes the kernels, aggregates the reports, and sends them out to the mailing lists. So far, it has uncovered more than 10,000 findings in the kernel, and in the current day, there are almost 5,000 kernel commits that mention SysBot or Syscaller. Our email reports look like this. We include the information on the kernel tree we have been fuzzing, the console output, the kernel configs, reproducers, whatever we could collect. And also, just in case, we also have a web dashboard that's accessible via syscaller.appspot.com. If you click there, you will find 1,200 open bugs, and as you can see, you can also filter them by your subsystem. So if you're only interested in a subset of them, you can click on the subsystems menu and select the ones you're interested in. Okay, some figures of this year, and just to ensure fair comparison, collected them up to August. So this year we have already reported almost 1,500 bugs, compared to 944 for the same period last year. There have been also more fixes, 530 fixes compared to 479. And there is growth in the number of text-tested fix candidates. That is, if you have a patch candidate for a SysBot bug, you can ask SysBot to apply to the kernel, to build the kernel, to run the reproducer, and report you the result. So it's good to see that more and more people are using that feature. But unfortunately, yeah, there are still many bugs that need to be addressed. This year, a lot of effort has been invested in improving the actual Syscaller fuzzing engine, which did not receive that much attention in the last years. I won't go into much detail here because, well, it's a Linux development conference. But overall, Syscaller architecture consists of a host process and of a number of virtual machines that the host process has created. It used to be the case that each of those VMs had their own mostly independent fuzzing engine, which, well, was good for spreading the load, but it made them less efficient, and we had to do a lot of work to coordinate them. Now we have consolidated all fuzzing engine functionality in one place on the host, and it has allowed us to make it smarter and much more introspectable. Also, consolidating the fuzzing engine in one place has let us implement snapshot-based kernel fuzzer. That is, after the virtual machine has booted and is ready to execute programs, we take a snapshot, we execute program, and then we roll back to the point where we took a snapshot. That way, we ensure a very good isolation of the programs. And our objectives were to get a much more stable coverage of the kernel code, and hopefully improve the bug reproducibility. And so far, it looks like it works well. We have set up a snapshot-based fuzzing instance on Sysbot. It has found 3.6% more coverage than other Clang-based instances, which is a lot, given that we have not really contributed any new kernel descriptions. It has found more than 60 bugs that were not detected by any other instances, and out of those bugs, 75% have a reproducer compared to the usual figure of 40%. So this is also a good figure. So yeah, as I mentioned, Syscaller needs descriptions of kernel interfaces to be able to fuzz them. And there have not been too many changes over the last year. The most notable one is that we have enabled bcachefs fuzzing, which has already uncovered 144 findings. There have been notable improvements to BPF descriptions. There was another LPC talk by Paul Changyong, which is linked in the slide. And there have been improvements to the KVM descriptions. We also have an ongoing effort of automated description generation based on Clang static analysis, but we don't expect it to work very well for non-trivial kernel interfaces. But hopefully it will work well at least for netlink descriptions, and maybe we can get it to work with many outputs, which will also be hopefully bringing more bugs. Okay, so the results of the fuzzing engine refactoring and a bit of the new descriptions can be seen on this slide. So overall, every month we now report 1.5 to 2x more bugs. Also, I would like to highlight that on our web dashboard, you can find a tab that lists commits that Sysbot thinks fix the corresponding LTS kernel issues. That is, these are missing backports. Many of those, unfortunately, do not apply cleanly, but we are currently preparing an experimental batch of backports just to figure out the right process of pushing them. And the direction that currently seems to be the most promising one is moving towards fuzzing not just the kernel trees, but individual kernel patch series. That is, for example, suppose there's some subsystem tree. We build the kernel at the head of that subsystem tree. This is the kernel A. We apply a patch series that's currently still under review on top of that kernel tree. Say it's kernel B. We perform focused fuzzing of the patched kernel. The current idea that once we have found the reproducers, we can run the reproducer on the subsystem tree, and if the subsystem tree turns out not to be affected, we can claim that it's very likely an issue introduced by the patch series. We do have a prototype that's currently still in progress, but the preliminary results look good, quite promising. So the precision is quite well. It's reported very few false positives. And at least compared to the bugs that Sysbot has been able to detect later, it also finds quite a significant percentage of them. So if this system actually gets the production and starts reporting bugs, we expect that the number of bugs Sysbot would have to find and report later would decrease proportionally, hopefully. Okay, that was the short introduction into the what changed over the year and what we currently think would be the right direction for the next development. But of course, it would be great to hear your ideas and your feedback. And just a few points that I would like to highlight is that to find more kernel issues, Sysbot does need some human aid. So that includes contributions to the Syslang descriptions of the subsystems of your interest, or at least highlighting something that should be improved or fixed there. By adding more assertions to the kernel and adding more self-checking functionality, we can also help the kernel itself detect more bugs, and therefore Syscaller will be able to trigger those issues. And the one probably not immediately evident, but by fixing the currently open bugs that are probably not that deep in the code, we actually let the fuzzer go deeper in the code and find much more interesting issues. And the questions, some of the questions to which it would be great to hear some ideas or feedback, for example, could be, do you see any repetitive cases of non-actionable bugs reported by Sysbot related to your subsystem? Is there any extra information we could report that could help you debug those issues? Don't know, are there any other kernel trees probably you would like us to fuzz? And whatever else you have in mind. Same.
I have a question in slide next patch fudging, currently work in progress. There's some patch series and focused fudging of V, right? Can you explain more detail in focused fudging of V?
Yeah, it's a good question. Yeah. So when Syscaller is a coverage-guided fuzzing. So when it knows after executing every program, it knows what kernel code has been executed. Well, during those system calls. So Syscaller is able to figure out what programs affect specifically the code changed within the patch series. So by focused fuzzing, I meant focusing specifically on programs that exercise the changed files, changed folders.
Ah.
So this increases efficiency of the patch fuzzing by a lot.
So focused fuzzings are some narrowing down some filter-like things, added filter-like things, and I have some question for this. This focused fuzzing are manually executed or automatically executed? This is a question.
Yeah. Yes, it's expected to be, that focusing is expected to be done automatically, of course, because, well, as I tried to estimate, there are like 50 to 100 new patch series every day. So it's unrealistic for us to be able to manually adjust the fuzzer to each of them. But yeah, it's not that difficult, given a patch series, to extract at least the list of files affected in that patch series. So we can use that list of files to focus the fuzzer specifically on those files.
Thank you. Thank you for your hard work.
So, actually, related question. So I run my own Syscaller instance within ARM, and I normally run my patches on that before I send them to the list. So if the functionality to say, please focus on this was available in Syscaller rather than Sysbot, or was available for some repo, that would be really useful as preparing a patch tool.
Yeah, to some extent, it is already available in the form of coverage filter. So you can, in the Syscaller instance, you can specify the list of files only for which it will be able to get any coverage. So in that respect, it already exists. But this one is a bit more vague focusing, and yeah, it will also be upstreamed once it's.
Yeah, one more detail, like next weeks we'll be discussing a lot of like 2025 year plans in Sysbot team, and like sharing your concerns or your use cases like here. You just highlighted the importance of directed fuzzing for you. Just give us the keywords, what's important for you. What features do you need? It will affect our prioritization approach a lot. It actually is a quite huge problem in this team. Like we have more ideas than hands. And like prioritization is one of the main complexity points there. So thanks, directed fuzzing, other things maybe, I don't know. Andrei, for example, softly and indirectly pointed to the documentation quality. Things like this. What stops you? What can enable some additional work on your side?
Yeah, so currently there is one form of focusing the fuzzer. It's already in place, but yes, I think it's not really documented. It's only documented in the our source file, at least the options, right? But yes, this all will be, of course, technically it's already upstream because it's in my fork, but it will be upstream to our main repository, and it will be available in Cscholar as well, and it will be also available, I think, as a standalone tool for fuzzing the specific patch.
I personally feel it's some kind of different problems that we have Sysbot and Cscholar, so people can use Cscholar locally. They have their unique use cases, and we have no idea how is it used, like what parts of Cscholar need more attention, what are frequently used, what are abandoned in fact, and it stops a lot of things. So personally, I believe that moving more to the web dashboard will give us at least some introspection regarding what features are used. But I know I'm not a kernel developer. I like work on Sysbot, but do not contribute to the upstream code. So the guys say like upstream developers are not about web dashboards. It's about plain text and mails. So if you have some ideas how to get that feedback regarding what features are really useful, that also can help.
Yes.
So first of all, thanks for the tools, quite nice, quite useful. I'm curious if there is a way to obtain a full message when you have reports. I don't know if increasing the console log could work, because I see that there is kind of, it's restricted for the moment of the failure, like a bug, it's reached. So you have like an excerpt, like a snippet, but not the full logs. Would that be possible, or is it currently possible to get that in the...
You mean the logs from the...
from the kernel, I mean, the message.
Crashed.
Yeah.
I think we now share up to several megabytes of kernel console output.
Yeah, so the report has the little snippet, but if you go to the dashboard and through to the thing, there's a link, yeah. On that, the console output link, there is a much more complete log.
Just check that here, like we are checking, and there was a small log in the console. You mean console, right?
It was in the dashboard.
In the dashboard, right? It was
in the dashboard. When you see every fail run, there's a log, and it doesn't show the complete log.
There is a link called a report, which only shows the actual kernel. Kernel report includes a few stack traces, but it's rather short. And there is a console output, or strace output, I think they're called, links, and at least they should include.
They should include, even from the beginning, from the boot time of the guest, more or less.
Up to this certain
limit
size.
Sure. We trim it after booting, after the standard boot So, but after that, you should see output. Maybe there was just, if you looked at that, maybe there was just no output between boot and the crash. So that may be the case. But generally, you can see previous messages.
And it's in the
there.
console. It's not a message. I mean, it's capturing the console. So if I print stuff in the console,
Yes.
because I want, like, I change that and patch to print stuff, it would show there.
Yes, yes. People actually do this. You can send your debugging patch as a test patch request. And it will say like it still fails, but this is also your debug output. So yes, you can do this.
Has anyone had, say, recent experience writing C-Scholar descriptions for a subsystem of your interest?
Thank you. I am physical user, and I have some question for when I'm using Sys Manager with a config file, right? And I want to update my configuration on Sys Manager on runtime, but I have been a physical manager with shutdown physical and again and up and running again. So there is any plan to a runtime configuration updating?
And but how big are the changes you typically do when you would like not to restart, but just to apply it dynamically? Is it about, say, the number of virtual machines, the number of enabled, disabled syscalls? Like, I'm just curious, what are the changes you want to make dynamically?
Actually, some filter. I want to updating some filter configuration in a runtime. So, is there some plan or features in physical? Something like that.
Mm-hmm. Yeah. So far, we are just, as Taras mentioned, we are constructing a plan. So yeah, we have noted the feature.
Right. Thank you. So.
So I have a one feedback for Sysscholar. So recently I updated Sysscholar, and then the syslang and system log is now currently logged separately. But sometimes before it was mixed in the log, and I prefer that because sometimes I try to salvage repo candidate from the syslang, and it will be started from the syslang that is close to the crash log. So it's very hard to correlate the crash log and syslang. But recently, Sysscholar's process name has the sys executor's ID. It's very nice, but sometimes the process, crash process name doesn't have the sys ID, and in that case, it's hard to correlate the crash and syslang. So I prefer, I appreciate if there is an option to mix the syslang and system log.
Yes, you're totally right. I think up to the recent rewritings, it used to be the case that the executed programs and the console output were intermixed in the logs. But now it has changed a bit because, well, it used to be simple and probably the only way, because the virtual machine itself were printing the executed programs, and it was mixed with the console output just right in the output from the virtual machine. Now that much more is done on the host, it's become a bit more tricky, but I guess we can still do that, right, Dmitry? And yeah, Dmitry said that we could find the program that crashed the kernel from the COM line. But yes, in the question, I remember you told that it's not always the case, and indeed, it's if there was a specific program that crashed the kernel, you can in the crash report there is a comp field that mentions the sys executor process. It's sys.something.id, and using that ID, you can usually I think it's not really gonna help you in that regard.
Thank you.
Oh, and I know one more feedback. Sometimes the crash has the syslang ID, but sometimes the log does not have the syslang ID. So probably it would be better to log the syslang first and then learn it later. Probably. I don't know.
Yes,
yeah.
Yes, we understand the problem.
Yeah.
We will note that it should be addressed but we need to think about how to do it best within our architecture.
Just one very small observation from a first-time user. I've only used syscaller once with the patch that I mentioned earlier for detecting stack overflows. And I was fairly scared by the complexity, just reading through the amount of documentation before I got started. There's nothing to blame. It's just huge, so I think a lot of people are put off trying to run it at first. But once I had it running, it was very pleasant to use, and I was very impressed. Thank you.
Would it help to have a simple script in the kernel repo under scripts or somewhere to, I don't know, help you set up a syscaller instance? I don't know if it's appropriate to add it there.
I don't know. I don't think there's anything really you can do. It's just already at this complexity where you have to get over this. Like, you have to know that you should need it. Like, it was perfect for the job I wanted it for, and yeah, I just had to really have a reason to start using it, and I hope that I can use it more.
Was there anything problematic or hard to do? It was just lots of documentation.
I don't think it was. I don't think it was particularly hard. It was a little bit tricky to set it all up with KVM on ARM64, I think, which wasn't, I think, enabled by default. But I might also misremember that now because it was a few months ago. Like, getting it running the first time took me a while to figure it out, but I think it was all in the documentation. I just didn't read the right bits first.
So getting it running with KVM on ARM64, you mean running under QEMU in KVM mode rather than TCG mode, because the quick start guide is in TCG mode, I think.
I did not get the details, but I'd like to write them down.
So I think there is a quick start guide in the syscaller repo, which is good, but if I remember correctly, the quick start guide for ARM64 sets up QEMU in TCG mode rather than KVM mode. So if you have an ARM64 server and you want to run syscaller on it, it won't be running fast by default.
Yeah, that's a good point. Thank you.
So one thing that I wanted to do in the past is try to reproduce fixed issues in a given kernel binary. But I couldn't find an API that I could ask Sysbot, give me a list of the reproducers and give me de-reproducers such that I can run them. Is it something possible to provide, or is there something that already exists for that? So one possibility is sending an email and say, please run with this tree, but I don't want it to build it. I want it to use a binary that I already have.
So you wanted to have a list of reproducers for the fixed bugs, right?
Yeah.
So we have, I think, a special Git repository that lists all such reproducers, right, Dmitry?
Yes, but it's not updated.
Not a good throw.
There is a repo on the kernel.org. It's called Linux-arts for something, stands for something. It has a collection of reproducers for fixed bugs. We didn't update it for a while, but I mean, we can probably. There was also an idea of integrating this into a Linux test project and use all of those as a Linux test project tests, but I'm not sure it was if it was merged or not, but there were patches with that.
You mean LTP?
Yes.
And we also have a dashboard API that you can use to get the list of bugs and some information about each bug in a JSON format. I think that's not really documented.
Like we can export these things directly, like it provides some API to do it, but I'm not sure it's a correct approach if the upstream community already have some web portals and instruments to download like test programs. So it's a to-do for us probably to discuss it together what way looks the best, but you are not the first person asking about it. It happens at least, I guess, once a year or like once in every 9 months. So okay, we'll either export them or consider integration with some existing systems. I'll vote for integrations if we have something stable upstream, like the Linux test project you mentioned. Okay, thanks.
So you're interested effectively in a test suite type of thing, right?
Yeah, I was.
And
So I think that distributions and even LTS and kernel CI project would be interested in having that because they don't want to regress. They want to make sure that they have fixed the bugs. And I think for the cases of vulnerabilities, for example, we want to make sure that, okay, any syscaller report that has a fix does not affect the particular kernel, for example. That would be one of the uses for that.
And the stable kernels.
Yeah, and stable kernels, yeah. Want to make sure that you have that quoted. I want to make sure that the stable kernels are not affected by any of those, especially the ones that has fixes.
We actually do have some kind of that information on our web dashboard. Like there is.
Yeah, I think it works much easier for stable kernels because you can just, please test with this tree, but it wouldn't help the distribution. So if Red Hat, SUSE, Canonical, Debian, they want to test their kernels, it would be possible to have like the corpus of the tests that have been fixed.
yeah, we had an idea of actually testing distribution kernels on Sysbot. If anybody interested, like Debian, SUSE, Ubuntu, and Fedora. The issue was that we're not sure if they're actually interested in fixing bugs. So if you know, we can do that.
Yeah, distribution testing was, or distribution fuzzing was the thing I wanted to mention. But like, from our perspective, current problem and current bottleneck is a bug fixing. So we can find like more, but does it make sense if some maintainer is already overloaded and it celebrates every sysbot site failure because of like for a month I can like be safe?
Yeah, I have a different point of view. My point of view is that users are running the distribution kernels and they are affected by the same bugs that have been fixed. So the point is, how can distributions, and they would do that, their work, they could provide all the infrastructure, it's just that they would need help picking up all the tasks that have been fixed and how to identify the tasks that have been fixed, how to download them, and then they would be able to run on their own and they would make sure that users are not affected by the same bugs that have been found and fixed. I think that's the point of view that I'm trying to present here.
I'm just going to kind of say things because I don't think anyone noticed that I'm here. Hi, Neil Gampa. I do Fedora things and stuff, and possibly things in other places. But I'm also a distribution kernel maintainer for Fedora Sahi Remix, CentOS Hyperscale, and a few other things. I would say that from the point of view as a distribution person that winds up having to deal with industry integration issues, I would say that from our point of view, I would be interested in seeing these kinds of things integrated within our pipelines as well, because one of the things that's quite interesting as a as a distribution maintainer is that we will see side effects from the fact that we build them differently than what you guys do. You don't necessarily have in Syzbot and Syzbot upstream, you don't necessarily have the same kind of build flags or config coverage that maps to distributions. I think one of the most recent examples of something like this was, not necessarily a Syzbot case, but a different case that occurred was there was a breakage for ARM 6416K that basically no one had caught because it just wasn't part of any config being validated. And if there was integration points or the ability for things like this to be used for kernels and builds and configurations that are being used by distributions, I think we would have much more comprehensive coverage and honestly a better quality upstream too. I think that it would be great for being able to improve the relationships between downstreams and upstreams and making it so that we have just a better Linux project overall. It's just my piece on it.
Thanks, Neil. But would you be interested in that we test specifically Fedora kernel with Fedora configs on Syzbot? Because we can do that too.
I would be interested in that for sure. Fedora kernels. The other thing is that I noticed with the way that you guys do Syzbot, you're testing against say Debian 13 or Debian 12 or whatever with a particular compiler, and the challenge here is that your bot is only half, adding our configs is only half the coverage. The other half of it is making sure you're using the compilers that we use too. That build environment has an influence on whether you see certain types of or certain classes of bugs. Fedora is often ahead of literally everybody what's testing upstream in terms of compilers, libraries, integration points, build flags, and the whole works. And so we tend to get surprised, I think, a little bit more often than a lot of the other distributions because of us being ahead on that front. I would love to see that as part of Syzbot, and maybe a Fedora environment in Syzbot which tests these things with the latest Clang and GCC with our configs would be beneficial. I don't know. Maybe that's something you can do. It's just, I don't know. I'm just bringing this up because from my point of view, I've experienced things where I've noticed that there are gaps because of some of these environmental or cultural or whatever differences that you wanna have there.
Are you already integrated with other systems? Something like kernel CI. I'm thinking about does it make sense for Syzbot to pay more attention there?
So mainline Fedora, its kernels are validated through CKI. And so it has a battery of tests and things like that related to it. But to the best of my knowledge, they don't do anything related to what Syzbot does. So that is something that's missing. For good or ill, the CKI tree is, for the moment, only RHEL and Fedora. But because of what Red Hat is mostly doing, to note background here, I'm not a Red Hatter. I'm just a guy that exists on the internet. But like, well, I have my own business and whatever, but that's not the point. Point being, there is a difference in coverage related to all these. I mean, I'm sure there were other talks about this, about all the different ways people are doing testing. You know, I know there's KCOV, there's kernel CI, there's KCI, there's CKI, there's all over the place, but none, like my experience looking through all of them is that while there's a lot of overlapping coverage, there is no 100% overlap for all of them. And that can be good or bad or whatever, but Syzbot, I think, is valuable to integrate. I mean, I would be okay with seeing Syzbot pulling in like Fedora configs and Fedora build environment to the general test suite. I don't know whether you guys want to do that. But another way is to see if the CKI folks and you guys, I know the CKI folks are there in person, can talk to you about integrating Syzbot into that as well. Like, I don't think it's a bad thing to have this connected to folks like Fedora and OpenSUSE and whatever, because you know, this is the primary way people actually consume these things, and it has much more of an impact if you catch them before they're getting released to people.
Thank you.
Thank you very much. Yeah, so, yeah, thank you very much for participation. We're unfortunately running out of time. As I understand, like, next there's break. So, yeah.
To an offensive security conference and ask people what kind of things they need, and then we're going to get a lot of tests.
And I've been maintaining their X390 architecture, and I've got I've been working in Debian packaging because there's many architectures like power or S390 or like things.
We need some proof that these reproducers are
but they're
somebody uses
Debian maintainer.
So I think we need both.
Utilizing some many other architectures.
Directly get
There's some other machines,
yes,
so
we can share the
I want to
database,
share
simplify
this
integration.
opportunity using this color to other architecture. So I'm packaging this color, but I want to know some modern policy because when I looking at the physical GitHub page, there is no release version or like things. So there's any policy to the broadening physical. I'm looking at some master branch, and there's some commit. So I want to packaging some date, commit date, and commit plus commit hash. So there's any
to package or
right. I'm working in packaging to Debian.
That's all I remember from Korean. And one more thing I can say is
generally should be the last
yes, that was important to survive.
I want some I want to I hear some advice to packaging burden in Debian. I'm working in progress and physical Debian packaging.
Okay.
So, but
you want to build Debian package with Cisco.
Right, and I'm also
I see. We actually
It's a work in progress, and
maybe
some
a bug.
I
will fix it.
gave
Hopefully,
some
but we'll
code
notice
review
this.
for
That's about
Debian packaging from the Debian maintainer, Debian developer, and Debian maintainer. So because I want to share some other architecture to utilizing seed color in Debian distribution. So this is my purpose, and there is any advice on burdening seed color because seed color GitHub page no rigid version. So right.
Don't declare versions. It's a pro for notice to just push commits.
We are a small team, and fixing the versions it's an
problematic.
overhead for us,
Notice that
because we really do not do the page delivery.
it may be overloaded and it may overload all managers connected. Just
We
because
see
on
what
spot we have
now,
lots of instances
that's
connected,
all
but
we do.
for
So
those
we
for
don't
maybe
have
20
versions.
instances,
And
like it can, the hub consumes tons of memory related freely and programs and just exchanges too many programs between managers. So say we have a global internet wide, then like all of them will be overloaded.
But if you want to make a package, we
much
can
so
probably
that maybe
think
not
about something like test suite, where all
but
the
it should be also easy to
will be
use locally.
as a
Like
first
you
step.
need to write some JSON config,
But not the
some
scholar
keys,
itself.
use keys just in case.
Yeah, when
Name and
just needed
in the manager,
you just need to run
the others.
processors,
Or
and you don't probably don't need color, but you need Symfony itself. I think it will be also tricky because we have
yeah, you can use it say
you know,
managers.
config files
One
for
is
this color.
ASAP, one is MSAP, maybe slightly different
Have quite a
versions
few
of the kernel.
directory paths in there, and I don't know how it will work if it's data package to install.
I suspect it will be just hard to support and make.
Yeah,
we do many changes. We change public things. We do not fix interfaces. So Syscaller as a package. We will break quite much. But
I
the
know.
runtime configuration.
Have you seen them?
I'll be waiting for you to come and give the details of what options are used.
Yeah, there's something broke the scheme and when I tried to run a blockchain, it didn't get so just no hit. I changed some stuff. I don't know. You know what how to do this. So it's welcome.
Yeah,
Yeah, we know
something
it's
like this container.
for just run it. But also
That might work, but then I guess what you would need is some kind of a way to self-update all the time because when you touch funds and the next version will change, something will get fixed. So maybe if there is some kind of, I don't know if Debian has a way to continuously update the packages, so every time you run it's going to self-update when you run. Maybe that type of thing could work.
So there are some integrations, but not on the package. Just some little layer. But they fetch code, or maybe they fix theoretically, like, you can test some specific versions, some commit shares, test it, and do it for some time. Next quarter, okay, next
For example, say you would
We did have some questions about people like what is
the
in the
first
stable.
time I hear
what is the stable situation? They would just once a random code inside the machine. Outside world that
A ideia que eu tinha, que a necessidade que eu vi, era pegar recursos que já estavam ali, a gente rodar internamente, a gente mesmo faz ele, a gente já tem tudo.
So for us, it was a specific number of setups. And I think calculations by all the calculations because when it's found about yes, that's machine
But like visiting the GitHub, we don't see what actual needs are used for Fiverr, but I'm sure it will help.
we don't know what the problem is.
Essa outra ideia é que ele é um pote que vai procurar, está procurando novos bugs. Ele rola no scanner, rola no scanner stable, rola no
Thank you. I work in progress. Making some other architectures, make some chance to using this color. Debian have a older architecture to test it on machine, so I'm working in progress. And now, currently I'm code reviewing from Debian maintainers and Debian developers for packaging script.
Yeah, and that's the idea of the image maybe make it more people more this way because it's just a matter of downloading the package. But you also need to provide them with random environment. You'll need to give them the these images. I don't know. We just noticed that I think maybe some more security our desktop traffic patterns.
Gente, como você falou.
It's better to know what are
Vou falar que vocês cresceram 20 pessoas. 60 no time, né? Quando eu saí já tinha 60.
Chegou a ver isso aí. Agora que all the people in Debian. Thank you. Thank you for your hard work. Eu não sei nem. Race for
vai ser gente, eu fico surpreso se alguém essa sair. O gente está falando de promoção. Aí eu converso com o Brian. Thank you. Vai muito interessante, ele vai colocar mais coisa. Aí o pessoal começou a aplicar para a sim, por causa do negócio, aí começou a apertar para agora tem que ter, sei lá, 260 lá, 80%.
Mas essa é a parte fácil, 360. O problema é que aí quando todo mundo está lá no topo, aí não, tem que colocar outro critério. Mas assim,
nem combinado, fechou entre foi aquele time. E agora está esperando o resultado de 360.
Ele está muito isolado.
Mas ele é um pouco tímido também. Então, e quem é tímido? Agora eu estou esperando 360 de novo. Se ele formar um 360 de novo.
Está precisando crescer o time e o cara prefere demitir. Mandar embora alguém que está fazendo alguma coisa que já está integrado. Começar tudo de novo. Por causa de um livro que o coleguinha de quarto dele leu. Nem ele, né? O cara lá, qual é o nome? O cara do Thiago.
Eu acho que é o John Seaver.
É o John Seaver, entendeu? O cara chamou. Quem fez tudo isso é o John Seaver.
Eu acho que
entendeu? Tem que padronizar a engenharia.
siga e o EBITDA. Sei lá como pronuncia aquele negócio lá. A regra do 20, 20, 40, 50, sei lá. Tem que crescer 20, tem que cortar 20. Para cometer outro dia. É meio bizarro o cara chegar na abertura do sprint e mostrar que nós queremos crescer assim, mas aí o nosso custo tem que crescer assim, o nosso custo é engenheiro, mas eu quero dobrar o número de engenheiros. Foi, cara, a conclusão que eu consigo tirar disso aí, você quer cortar o salário de todo mundo. Entendeu? Você quer cortar a sênior e tal.
Mas é
Aí depois eu falei, putz, o cara na verdade é inteligente, ele não é burro, ele é inteligente. Né? Ele quer que eu saia. Ele quer que eu peça para sair, porque eu estou vendo que ele está dizendo, isso aqui não é lugar para você, mas eu não vou te mandar embora.
Mas no final eu acho que é isso mesmo.
Entendeu?
Porque entrevista, o Brett fica pegando um monte de gente. O pessoal que saiu da faculdade, para entrevistar, ele falou para ele, não me manda mais ninguém que está saindo da faculdade. Tudo bem, pode ter alguns, mas vou fazer 80% do time de pessoal que não sabe o que tem que fazer. Como que faz?
Cara, olha pro muro, mas não olha, aí não olha para execução.
Então, trabalho no marketing dá trabalho demais. Segurança mesmo, a gente não conseguiu estabilizar. Conseguiu não virar um desastre.
O que o Greg fez ali.
E assim, essa discussão eu tinha zero expectativa, pra mim foi isso, né? Tipo, mandou um se vira aí, legal.
Mas, assim, é um problema em cascata, porque o problema que ele tem, que ele não sabe qual é o frete model, eu tinha situações lá que eu chegava, Steve, me ajuda aí, cara, porque você que está aqui há mais tempo, como que eu classifico? Ele também não sabia. Eu tenho um exemplo clássico que eu estou mostrando para o pessoal. Buffer overflow no NFS. Cliente. Cliente, como você usa NFS? Você sai montando NFS no João da esquina? Não sai. Entendeu? Qual é o frete model? Você confia ou não no seu NFS que você está montando? Se você não confia, melhor não montar, cara. Tá na rede. Vai que tem um bug no cliente NFS. Quer dizer que eu tenho que corrigir? Tem, eu sei, vou corrigir, está aqui a correção. Eu tenho que corrigir no 3.13. Entendeu?
Podia ter lidado de forma melhor, né? Ele podia ter vindo aqui, feito isso antes de fazer a mudança, conversar. Porque depois eu estava conversando com a pessoa aqui, explicando que ele chegou em contato com a Red Hat. Mas o resto do pessoal não sabia, o pessoal não sabia. A Red Hat paga
Deve ser meio. Mas o Google também.
Mas o pessoal daqui, pelo menos de Google Cloud, que eu tive que fazer agora eles não pagam.
Teria resolvido se eu tivesse avisado.
Mas discute, se prepara.
Discutiu, ele ia fazer igual, porque é confusão mesmo. Tipo, vira com a cara do CVS e eles estavam discutindo exatamente a pergunta que ele fez. Tipo, você não vai atribuir um CVS a essas coisas, justamente que a gente está discutindo que o frete model é diferente para cada um. Dá para colocar um score. Mas aí eu vou lá, sento do lado da galera do Google e falo, não, mas essa informação aí que você disse que é network reachable, isso é um atributo do score do CVSS. Então dá para fazer. Tem coisas que são um pouco mais subjetivas, algumas coisas são objetivas para colocar. Mas eu falei, ninguém vai ter. Eu como contribuidor, eu coloco fixes line. Eu não vou colocar um CVS, essa escola, não vou colocar nenhum atributo que você me peça, a não ser que você me exija para aceitar um patch. Eu coloco fixes, porque é exigido hoje.
Mais ou menos, né?
Entendeu?
Porque eu
não,
sentei
um monte de pé de mantenedor passa, tem conta, mas tem mantenedor que não passa, tem mantenedor que você chega lá e fala, cadê o fixes line?
Eu sentei com o James e a gente começou a tirar uns números, 40% não tem.
Que está no stable?
Que está com CVE, né?
Está como CV?
Eu ainda não sei por que ele resolveu fazer isso.
ser ignorado. Eu não entendo.
Porque dá dor de cabeça para ele. Dá dor de cabeça em várias coisas.
Quem? Alguém pergunta outra coisa a ele.
O pessoal da Linux Distros tem uma política que ele não gosta. Então, alguém vai lá, reporta uma coisa na Linux Distros, não reporta para ele. Ele achou ruim. Já começou mal aí. Alguém vai lá e manda para as duas listas concomitantemente, respeita a policy da Linux Distros e fala, vou fazer um disclosure em 7 dias. Não interessa se tem fix e não tem fix. Aí, bem, eles têm a política deles, que é quem faz o disclosure é você, não sou eu. Eu só quero fix. Mas eu não seguro fix. Entendeu? Não seguro fix. Tá bom, ok. Só que eles não seguem consistentemente. Eles ofuscam, né? É um monte de putaria que eu odeio.
Depende
de
quem tá mandando, né?
Exato. Para mim é inexcusable essa coisa de ofuscar. Não tem, assim, eu sei exatamente qual é a desculpa que ele vai dar, que é uma questão legal. Né? Questão jurídica de que você não pode... É crime, né, jogar exploit na rede, é crime você falar de um bug. Você chegar e falar, está aqui uma falha de segurança. É crime. Um problema que tem que ser resolvido, né, em termos jurídicos. Mas tudo bem, vai lá. É a única desculpa que ele tem. Mas eles fazem. Mas tirando isso, qual é o problema que ele encontra? É que para ele tem que ter um fix. Para ele você... Assim, é que infelizmente eles tinham que ser mais consistentes e dizer a bugs, a bugs, a bug. Então tá bom, então não tem security@kernel.org. Quer reportar um bug, reporta publicamente. Com fix ou sem fix.
Para mim seria muito mais consistente.
Seria mais consistente. A inconsistência é existir um canal de segurança quando eles alegam que é tudo igual. E aí não trata tudo igual. Mas...
Isso que eu falo. Assim, para mim, para ser consistente, ele teria que ignorar. Esse argumento dele faz sentido se ele estivesse ignorando, não fazendo isso. Mas vai mudar.
Mas é assim, é que aí as pessoas pedem CVE. As pessoas abrem CVE, que não é CVE. Tem aquele pessoal que fica lá querendo ganhar prêmio.
Mas
então,
isso
vai quer saber?
Porque o problema não é só essas pessoas. Eu acho que são as empresas que acho que vão pegando no pé dele.
Mas, então, aí ele tem um ponto muito importante, que é a questão de que, olha, tem um monte de vulnerabilidade aí que ninguém está nem aí, que não está dando CVE. Me incomoda muito os casos em que foi reportado para security@kernel.org, foi o fix. E aí ele sabe, ele disse que ele confessou. Eu sei, porque toda semana tem um que chega lá e vocês não estão aplicando. Né? E ele não podia dar CV para esses casos. Então agora ele pode. Entendeu? Só que ele também não pode marcar esse cara. Então o que ele faz? Como ele fez com o Dirty Pipe. Fez um backport de 1000 pets para esconder o Dirty Pipe lá. Agora ele não precisa esconder. Está aqui, ó, esse fix aqui tem esse CVE. E tem esses outros 999 CVEs juntos. Quem vai separar o joio e eu não vou dar score para poder te contar que esse daqui é o de verdade. Entendeu? Mas aí por que ele não pode fazer isso? Por causa dessas amarras legais, entendeu?
Mas de novo, a opção seria ignorar. Não mata o security.
Mas estão exigindo dele, as pessoas estão exigindo dele.
Eu acho que não são as pessoas, porque as pessoas, se fossem pessoas, ele ia falar, vai passear. Eu acho que são as empresas que estão enchendo o saco dele.
Quando eu enchi o saco, eu falei, pô, por que você soltou esse Dirty Pipe aí, colocou o fix público e não disse para ninguém que tem impacto de segurança? Né? O que você está fazendo está errado. Ah, tá bom, pode deixar que eu vou resolver. Resolveu. Agora ele está me contando que tem impacto de segurança. Entendeu? A solução é essa. Já acabou o brigo.
So it's not, there is no hypervisor. Yes. We have no more than some our to manage the whole. So it doesn't have hypervisor, but it's actually managed by someone. Something that can reboot the machine. Yes, yes.
I've heard of one of that's why I've never looked at it. Alpha has actually been working directly with the runtime utility trying to get something finalized. I think
We would hope that they
one of the things that we didn't do, and it made sense that he did that, was he tried to assume that you should not try to make any changes to the C side. And yeah, and the Rust findings were extremely complicated as a result. Right? So we spent like most of half an hour at LSU trying to understand right? And it didn't help that we didn't understand Rust. He was using like the most complicated features of like Rust typing. And you know,
I labeled it.
There you go. Joke that
See you.
it takes twice as much intelligence to debug code as it does to write it. So you write code which is as clever as possible. By definition, you are not competent to debug it. And you know, I think, you know, I think what probably needed to have happened was it should have been done offline as opposed to, you know, at frontend. And this was done because Kent thought that this would convince everyone that Rust was the one true language that was wonderful. And it did the exact opposite because no one could understand what they were doing. It's like, wait a moment, if this is what you're signing up for, check these, we're out of here, right? I mean, I think what should have happened was we could have said, all right, how can we simplify the object lifetime on the C side to make it better accommodate Rust? And even if that means we need to change, you know, all 65 odd file systems in the tree, in the long run, if it's actually more maintainable, it makes the C side simpler, it makes the Rust side simpler. What is it that you need from, you know, what does Rust need from the C code? As opposed to encoding the low-level details of how we do things, which admittedly is very complicated in Rust. But if you do that, the moment you change anything on the C side, the Rust findings are going to break, right? And so I think he had the wrong goal. You know, the goal was, yeah, let's just assume the C code never changes. And it's like, that's not true. We need to change C code from time to time. Let's change the C code to make the Rust findings simple, right? Because I think, you know, Rust is a more powerful language. It will never be like, I don't know if you're familiar with Squid. That's the generic way of taking C code and make it, it's an interface generator that will allow you to generate bindings for like Python, Perl, and like a dozen different other languages. But all it does is like C function calls. Right? You're never going to be like Squid with Rust, because the whole point is you want the memory safety problems. But like, it may very well be that Rust, unless you have to wait for that. I don't know. This is actually, I think, something I don't actually express worries about. That there are a lot of language theorists that are using Rust as a playground and are putting their favorite language features into Rust. And it hasn't stopped, right? I mean, it's fine. We're using 1.76 as our baseline. You know, Miguel was thinking maybe we'll go to 1.86 when the Rust 24 edition is. But then, what's going to happen to Rust next year and the year after that? And maybe some of the features are what we would want, and maybe some of the features are ones that we really want to use. It's sort of like C++, right? I mean, Google has internal style guidelines, what Chrome OS uses, so there's public versions. And there are things like you will never throw an exception. Right? Exceptions are verboten. That's because...
Hello. Shall we get started, folks? My other co-present is missing, but I think we can do something. I was expecting more like
it's time!
Hello. I was expecting more of a room where we would be all sitting together and talking than this one. I think essentially, as a plan for today, I think we want to kind of like summarize a bunch of like the testing discussions that happened during the past few days in this conference and before this. From the kernel side perspective, like we are pretty happy with everything that happened so far. Like we've been in a few sessions and talks and Huawei discussions and so on. We are seeing like a lot of the community talking more and more about like continuous integration on the kernel, more tests about like how we and now the problems in there, right? That the architecture that we have like is super complex, like from figuring out how you do your labs or your cloud infrastructure for the test, into which CI systems you're throwing into it, how you set up your CI systems, which different tools and things and tests and test suites, etc., that we're putting together, and how to figure out which test to test in each scenario for each platform, for each subsystem, and so on, and how to visualize that data. Like we've been looking into all that during this week, and I think it's a lot of progress. Like we were just like in a room this afternoon with like 20-30 people discussing a bunch of those topics, and yesterday as well, and there was a nice group of people in a happy hour yesterday. So I think for today, I want to see which other things we should be, like which other things that were not raised yet that people want to bring as questions to this. Maybe there is like another use case, or maybe someone else want to bring like a summary of what they saw during these past 3 days on this. Helen, maybe?
Yes. So one thing, let me see. One thing that, so a summary would be, we had lots of discussions about maintainers workflow, about different test suites, and how can we, as you mentioned, how can we define all the tests to know when to run, how we can trust the test. But one thing that I am missing, so I see several people around tests discussing, but one thing that I like to see more is maintainers to come to us and understand how we can help you as a maintainer so you can rely on the tests there, which kind of tests, which kind of data you want to see. So I was wondering if there is any maintainer here who would like to speak to, so we can understand how you do testing, how we can help you in general.
Either Ted, Kevin, who else is maintaining?
I'm already bugging you.
Yeah, you're bugging me.
Yeah.
Any?
Ted explained to us, Ted had a lot about...
The mic, yeah.
Hi, Ted. You explained to us what you like to do when we tried the test catalog effort in the maintainers file. In short, you're running XFS tests, right? In virtual machines, you have special tool for spinning up the machine and run them in Azure? Is that
no? Yeah, I mean, yeah. So I have a test framework. It's called GCE XFS tests. It's built on top of XFS tests. It uses the Google Compute Engine. I think speaking more generally, all of the file system developers are using XFS tests. We generally are running a large number of different file system configurations. So 4K block size, 1K block size, different size inodes. I have something like a dozen different configurations just for ext4. There's probably a little bit over a dozen that we run for XFS tests, for XFS. And so as a result, there are roughly speaking something like 1,100 odd tests for a particular file system configuration. And, I am currently running, using FSNext, which is a subset of Linux Next. And so I am kicking off something like about 28 different VMs running 28 different file system configs for ext4, XFS, F2FS, and Btrfs. Wall clock time, it takes about 4 hours plus or minus. And as I said, that there's like close to 30 different VMs. So it's quite a lot of compute time. Fortunately, I have access to a lot of compute time. The bigger issue is it's a very, very large number of test results. And the challenge that I think all of the file system developers have is analyzing the test results to find which of the tests are failing. Are they failing across multiple file systems, or is it just exclusive to one file system? Finding flaky tests, noting regressions. And of course, the other issue is XFS tests uses JUnit XML as opposed to the KUnit test report language, which many things like K-self-tests use and KUnits use. So there's that issue as well. I think we actually all have our own test infrastructure already, and many of us have access to the resources to run it. The big missing piece is the visualization and analysis. And that might be an interesting thing to work with kernel CI with. I think a number of us are already set up so that we have, every night, these 30 odd VMs that we're running, it's like a 600 or 700K XML file with, literally thousands of test results for one night. All right, and it's against FSNext, so FSNext is currently, is constantly changing. I would be happy to send that XML file to someone who wanted to consume it and do something interesting with it. There's certainly nothing secret in it. I think different file system developers would love if they could send their XML files as well to some central collection point that could then do something useful for the benefit of the entire community.
And so I think that's the challenge is, we've got this environment. It's a little bit different from the traditional, testing that KCI has done in the past. How can we work together? So.
Okay. I'm sorry. Yeah. So Red Hat also runs XFS tests, and I suppose others run XFS tests. And Red Hat already submits their results to KCIDB, but they are not detailed enough. So KCIDB would be happy to get your test results, because you have a lot of resources. That would be awesome. And we can work with you on trying to make sense of that data and accommodate your specific requirements in KCIDB. The only problem is that we need to manage access control, so the results needs to be submitted from an entity that we can trust and give the keys to.
Yep.
So if it's for your setup, for example, or a specific maintainer, but we cannot take it from all maintainers if they are running it separately, because we cannot manage that kind of access control.
Yeah.
So how many of those tests are performance measurement tests?
They are nearly all functional tests.
Okay, that's good. Because we do have support for performance tests, but like a story of how to process them is not developed at all yet.
We have the same problem.
Yeah.
I can run the Phoronix test suite, which is what I've been using to get performance results, but it's manual, and comparison of the results is totally manual.
Have you seen teams talk about trying to accommodate performance results in KTAP?
I've seen some of those discussions, but I haven't followed them actively.
Well, basically, he developed a tool to have reference values, have criteria, and do that in using files in your local file system. Yeah. But we will have to do something similar in KCIDB as well, and maybe you can use that. Okay.
Yeah, and I think stepping back a bit and look into there is the place where KCIDB is today and the kernel infrastructure is today, and there is what we can develop together. So having the data landing to KCIDB from you and from Red Hat and from other people who are contributing to XFS tests will allow us to have the proper feedback into how put together the dashboard. And KCIDB, which is the second part into the diagram there, is developing more and more strategies for post-processing the data. So you might have a lot of strategies yourself already, but we could bring that in and everyone can benefit from that. So that's kind of the ecosystem we are trying to put together here.
Yeah, and the general approach of KCIDB is get data first and figure out what to do with it. And repeat, basically. Yes?
Yeah, so if you want to start submitting your data to KCIDB, we have people that can help you. So let us know. Yeah, I think Nikolai can provide provide access, and we have Jenny on our side that already do this bridge in Maestro that can help you. Yeah. And once data is there, I can help you with the visualization. We can build specific boards, dashboards, so to help analyze this data as well. And we can also add some post-processing code there to figure out the issues, so you can have extract what the data, which kind of data you need to really care about and go fix.
Yeah. I think you and I discussed before that the file system community was developed a JUnity standard for the test results on the XFS tests. Because that would be easy to just we can translate that format into the KCIDB format, which is a DB schema, and everyone could just use that.
Yeah, so we've just simply been using the JUnit, that's industry standard test results, because that's what XFS tests had introduced many years ago.
Okay.
So we've been just using that because that's what XFS test does. We have extended it, but we're using the XML style of extension in terms of we actually tag the results with exactly what version of FIO, of XFS tests, of the kernel. So we have a lot of test metadata about the test environment that we have put into the XML file, but we're using XML attributes So we didn't really extend the test format as much as took advantage of the facilities that the JUnit XML standard has. I think that's actually one of those interesting limitations. I've been talking to some of the folks about, how KTAP might be extended, because it would be really, really useful if there was a way that we could do lossless interchange between the KTAP format and the JUnit format, because right now, KTAP was designed to be simple, and so what you can put in KTAP is a subset of what you can put in the JUnit XML. But that could be changed, and I know the KTAP people have been looking at enhancing that metadata, because you want that, I suspect, for the KCIDB.
Well, we have a KTAP specialist over there. I hope I can throw this well enough.
In steps, yeah.
Okay. Yeah, I gave a talk on this earlier on wanting to create a common KTAP library, and part of that is I want to create a converter from KTAP to JUnit XML, because I know XFS tests really inspired that actually. And if we're doing a converter one way, I don't see why we couldn't do it the other way as well, from JUnit XML to KTAP. So if that helps expedite your process to uploading these results to KCIDB or something, or using other KTAP tooling, definitely open to that. The only issue is the metadata. I do have the KTAP metadata proposal up for KTAP version 2, which is pretty exhaustive and is somewhat based off of the XFS tests attributes, actually. So there should be a decent amount of overlap. But I'm definitely happy to keep working with you on it to make it even closer. Yeah. Okay.
Sounds good. Should we move on? Maybe you want to give a summary of the test catalog discussion so far? Yeah, you were quite involved in it, yeah. You can take this stage.
Oh.
You are co-presenter, remember?
Yeah, right. I forgot. So we just had this discussion, right? And some of you were there. So there is idea to have the test catalog for upstream. Basically, what maintainers would like to see tested before they would accept contributions, simply speaking, right? So the idea is that the maintainers control which tests go there, and CI systems figure out what data they need about the tests so they can execute them automatically. It's a way to standardize, like for contributors to figure out what to execute, and for CI systems also to know what maintainers care about, so they can actually execute it. There was a lot of interest and a lot of discussion, a lot of suggestions. We're going to start simple. We take some simple tests that we know we can execute, not like some really wild tests that need multi-host setup, very specific. And we start from that. We start a discussion on the mail lists, about the format, and we take it from there. Basically, it's going to be, the file will be somewhere on kernelci.org for the start, while we figure out the basics. At some point, we will try to contribute it to the kernel. When we have more or less functionality, we will try to develop the tool that lets you actually run those tests from that catalog as soon as possible, because I think it's important for the feedback loop. Yeah, we'll take it from there and try to, talk to maintainers, try to put those tools in there, ramp up the functionality of CI systems in that tool for execution, like whatever is needed. Any questions? Wonderful. Okay. No questions. Great.
I guess we could go like sooner. There's a good time discussion. The K-Unit wants to say something about like summarizing what happened for you in the conference.
Happy to. Yeah, so on a K-Unit and KTAP front, we've spent some time this morning discussing whether we want K-Unit tests to be able to run entirely as user space tests or have a user space version of K-Unit. I think everyone thought it was a good idea, and that we should do the simplest possible thing, which, you know, has already been experimented with by various people of, let's have a header that implements, you know, the basic KUnit macros, assertions, etc., so that if you have something that's sufficiently self-contained, you can not only build it as an in-kernel test, but you can also build it as a standalone binary and then be able to, you know, send that to the compiler vendor as a repro test case, or not have to build the entire kernel to test your change while you're developing it. There are some interesting comments around particularly tests involving lots of threads. KUnit's not great at those in the kernel. There are ways around that in user space for people who want to do user space only tests. This might also be useful for tools in the testing, in the kernel tree, like perf, potentially some of the build tools. We'll see. Seems like a great idea. Everyone likes it, so we'll see where that goes. Yeah.
To be honest, I was thinking, I thought that KUnit already does that.
It sort of does through user mode Linux, but user mode Linux, for all of the problems it solves, it introduces a corresponding one. So it's great to have multiple ways of attacking this problem with different sets of trade-offs.
Cool. Thank you.
I kind of, since someone brought up UML, I want to just quickly say something about, like, I kind of wish one of the things we could do is build the various subsystems, components, file systems, whatever we want to call this, that are in the Linux kernel as user space modules that we can just control the inputs and outputs and actually test individually, because building the whole kernel thingy and then having to do all the stuff is quite a bit harder than if we could just isolate a component and do that. Like, you know, I'm somewhat involved in Btrfs and to a lesser extent Bcachefs, and like this is sort of a thing that has been kind of a point of discussion, is that, well, it would be super nice if, you know, one of the things that we started taking away from this was, instead of thinking of having to always do integration style unit testing, which is what we basically do right now, is start looking at whether we can start isolating these pieces and being able to build them in alone to be able to test them in isolation, because that makes it much easier to determine where the boundary of faults are when trying to fix bugs or deal with regressions and things of that nature, because you can figure out where the boundary is for what causes a regression or what's created a problem, or what the interface impedance mismatch has created an issue from. Like a few years ago, I had seen something called LKL, or the Linux Kernel Library Project. That was something that I was kind of interested in seeing whether anyone had any experience with looking at from the perspective of being able to kind of bring that into mainline and use that for enhancing the quality of testing.
So I was going to mention LKL. It's something certainly that we've looked at. It is, at the moment, basically just UML, so you know, you don't actually split the subsystems off totally, but you do get sort of in user space. It's not totally different from what KUnit's doing in some respects. Has some advantages. Actually refactoring the entire kernel to split things up would be amazing, but I'm not going to guarantee I'll do the work.
Yeah, I'm not saying it. I'm not saying that you would or anyone else would, but like I feel like one of the things that kind of inhibits that natural progression for doing it, either from contributors or maintainers or whatever, is the fact that we just don't have an apparatus in the first place that kind of encourages people to do that. It's just not really a thing, and it's really easy to just do quite the opposite in the Linux code base.
Yeah, well, hopefully this is a path we can start to go down more. There are now a few smaller parts of the kernel that are buildable independently, but it's, a few bits of data structure manipulation here, a header there, rather than any, really substantial subsystems.
It's a start.
Yeah, perhaps this could be the way, like convert and make pieces of the kernel built outside, not in context of the kernel as needed.
Hello. I just want to share that for the Rust block layer bindings, we have also built a CI, yet another one. We had the requirement that we wanted to. So this is not as much a unit testing CI as it is a performance testing CI to test performance regressions. And we wanted these tests to run on bare metal in a little cluster we have somewhere. And for that, we have built a thing. It uses NICs to, if you have a number of hardware nodes that you want to bring up into a certain state without having them stateful, so like without having a distro or like something on them, we have some tools that can, via iPXE, bring the nodes up, run your tests, deliver the test output back to some place it can be collected, and we have a little like a resource queue manager to do that. It's all like very bespoke and built for us, but if anyone is interested in that or have a similar use case, we can come talk to me, and then we can share it and make it open source. And
yeah, the part about NICs is interesting.
The cool thing is it allows you to have your workers completely stateless. The only state on them is the iPXE bootloader, which you can provide via USB stick or put it like on the ROM of your network card or something. And then what you do is you write a NICs expression, and the system will bring that node up into the configuration described by that expression, which is really cool. Yeah, I'm here, so if you want any details, you can just.
Yes, thank you. Helen, you had something?
Yeah, so I just wanted to summarize a bit some of the discussions that I've had. So regarding KCIDB, we discussed about like post-processing data and how we can extract useful information from that. So we discussed one approach with AI that looks very promising. Let's see how it goes. Also regarding other CI systems, so I had discussions about media CI and DRM CI. Everyone is doing their own CI, but we are trying to converge and reuse things. The free desktop maintainers came and showed their concerns about overloading their infrastructure. So that was an interesting discussion as well. What else that I can say? We also had interesting discussions regarding how we can manage access, at which point. So everyone should be able to run their CI, like pre-merge in any patch, or would these overload the system and also cause a security issue because we would allow anyone to execute anything? So this is one model. Another model is like post-merge tests, or another model is something in between, like post-review tests. So there are different kind of models, and we need to figure out how to manage. And another interesting discussion was, so someone raised that it would be interesting, the possibility to have direct access to a remote board to debug that you don't own this board, but this is also complicated. So maybe this could be some arrangement between like the maintainer and the lab. So yeah, just wanted to share a few discussions that I had that were interesting.
Yes, thank you. Yes, those were interesting. And another part was that the job of kernel CI could be arbitrating those contacts between the maintainers of the labs and the maintainers of the kernel, and act as like as a communication hub for them to figure out what they need, what they want. And the point was also that both sides should have control over what is running where. So the lab owners should have control which tests they want to run, which architectures, whatever, what they would prefer on their lab, and the maintainers should have control where the tests that they care about should run. So like if they don't care about particular board, they should be able to exclude it from the pool that they receive results from, because they don't want to care about it, they have no capacity. So it's a sort of like a market of hardware being kernel CI. And the point of the access control and the abuse of CI resources is an eternal one. Everybody is struggling with it, yes, and there was the discussion with the typical arguments that what if somebody mines bitcoins, which happens? What if somebody just accidentally breaks something or whatever? So yes, there are multiple ways to deal with that, and I think that ultimately each team will have to figure it out according to the way they like to work. Some people might want to never run CI before the review. Some people might allow some minimal tests in a secure environment to run like for everybody, so they get immediate value, immediate feedback faster. So yeah, but it's an eternal problem.
Yeah, another perspective into this is that kernel CI, beyond being like a project, open source project, like with infrastructure and so on, it's also a legal entity under the Linux Foundation. So we can take responsibility for the resources that people want to share with kernel developers. We can mediate a bunch of that. So maintainers can benefit from that service on kernel CI as well. Like, oh, I need access to certain amount of like cloud resources or certain boards and so on. We can figure out ways to make that happen. Not all the times will succeed, but the entity is there to also work on those like more boring stuff.
Yeah, and sometimes be flexible and figure out what we can do. And I think that's gonna, we might not think about something supporting some use case, but we are there to make it happen somehow for you.
Nearly. All right. So about that part about kernel CI being the arbitrator for that whole exchange, would kernel CI then also be responsible for making sure that the things scaled properly?
To the amount of our financing. Join the foundation.
I think I already am, as I am at Collabora, but yeah. So, but I think that's just an interesting problem. Like when the usage on a CI system like rises, like how do you handle that? Because, like, I mean, in some cases it's even impossible. If you have a device which is basically out of the market, you can't just get more of that. And so then you have to basically make sure that you share the device properly.
Yeah, you can probably try eBay.
Yeah, if it's still available. But I think you get the point. Like, I feel like scaling these like labs properly and making sure that you share them in the right amount is pretty hard. And I just wanted to know whether kernel CI like wants to take care of that or not.
That's our function. Yes, we have some resources. We should be responsible and, make sure that people who need support, who need that, that we share them fairly, and arbitrate all the discussions like why I'm not getting those resources and that guy gets those resources. So
yeah, and there's a way that we can kind of filter how much workload we sent to the labs, moving things even further left, like having contributors running the CI basically on their machines. I was talking to Guillaume earlier, and like he has an idea of using hooks, which might be a way to, like, when you're pushing your things, you can run a basic CI on your machine using virtualization maybe, because there's a lot of the kernel that you can probably test just using virtualized stuff, which clearly doesn't require labs. And then we can be sure that we only send to labs things that are almost pristine, and well, that might be a way to save resources.
A way to further improve the situation will be if vendors will just make open simulators for things. That will solve the entire problem. And in that sense, when I worked on hardware, which was very lightweight, let's say, I started from the spec and the simulator and then went to develop the other things. So I don't understand why they don't make that first and make it available before the hardware.
Well, there's probably a lot of, secret knowledge about those emulators and secret technology that you can just, have a license to run this emulator anywhere you want. But what kind of performance were you getting out of those simulators?
In my case, it didn't matter much because it was about compliance. But basically, everything was designed so that the hardware will perform about the same as the software implementation in the ways I care about. Of course, it will be a little bit faster, but it didn't matter much to me.
Well, this could be something to explore and ask some vendors, like whether they provide something like that or encourage them to do that.
But like, just for me to understand, does that really solve the problem? Because like the problem I see, for example, now is you have a specific load of tests that you want to run on a specific hardware. If you want to do that now on like open simulators, doesn't it make the problem harder? Because like an open simulator is probably a lot more expensive than having like a specific board. And so don't you need then for like testing more loads, more open simulators, or do I get the problem incorrectly?
Define expensive. It's if I get only 1 or 2 prototypes made by the company, I guess the software approach is better regardless of the performance. I can just make thousands of them with common hardware. And it may run slower, but as long as the timing constraints are the same and the stuff I'm testing is within that. And the real problem is, does my hardware comply with my spec, and does the software respect the spec? That's what I care about. And the rest doesn't really matter. You can just not simulate the actually functional part until you need to test them. So if you are testing only if the hardware initializes correctly, and that's all that matters for that test, you don't run the rest.
So I think one of the issues is proving that the simulator is actually modeled exactly the way your platforms are, and it has been a complicated issue, right? How much you can rely on your test result, let's say it's passing or failing, how much you can claim that in real life it's actually passing and claiming or failing, right? And so in our experience, that was one issue to look at, right? How do you qualify the simulator enough to be able to say, well, now people take it and run it, and you can rely it just like you were running on a real hardware?
In my case, the simulator was the reference, so it didn't matter. But if you had the opposite approach, you can just add the bugs to, if they are hardware bugs, you add the bugs to the simulator one by one. That's the only way forward.
Sure. Yeah.
Yeah. So this, just a moment. So Yeah, the simulators are simulators for a reason, right? They don't match the hardware necessarily exactly, or they cost a lot or whatever. But for certain loads and certain tests, they could be useful. So this might be something to look at to expand the lab, provided like we have sponsorship from Azure or something to run these loads, perhaps.
Yeah, I have big +1 for this idea of providing simulators. They may be slower, but common x86 ARM64 virtual machines are relatively cheap, and it's easy to scale. And more importantly, then those tests can be run locally by anyone, which is super useful. This will also allow to, say, run fuzzing on that hardware effectively. And the issue of bugs, it shouldn't be a big issue, because if you have, say, falsely failing test, then it either means bug in your driver or in the simulator. So either way, it's something to fix. You just, say, file a bug on the driver or on the simulator. And the situation that the tests pass falsely is very unlikely unless you specifically try to kind of fake things, because the simulator needs to reply in very specific ways. So it's quite unlikely that the test will pass on the simulator only.
There's the hand to respond to you.
Okay.
Thank you. Yeah, I mean, the problem is that the person who is running the simulation to qualify their software, if the problem is inside of the simulator, first of all, they have no idea, right? So how do they know if it's their problem or the software problem? And so without getting to the actual hardware running and confirming it, they wouldn't know. But again, I agree with Nikolai. I mean, there will be probably some cases, some verifications that you could run the simulator and get some value out of it.
And as I said, it's up to maintainer to select the hardware.
Yeah.
So it's up to them to decide.
I think that's a better problem to have. The second thing is, if you have a spec, either the simulator is not compliant with the spec, which is something we could statically analyze, and the other problem, which actually not a problem, it's a feature actually, is you discover hardware bugs, which are impossible to discover otherwise. You may be doing something actually wrong in software because of a hardware bug, and you only realize that when you get another hardware implementation of the same thing, and this prevents that.
Right. Yeah, all I'm saying is, the company who provides the hardware will have to provide the simulator that matches to their hardware 100%, and it's a very difficult task. That's all I'm saying.
Yeah, that usually doesn't happen.
And you have to keep updating it. Yeah. Generally speaking, once we get hardware, we don't care about the simulator anymore, because we have hardware.
So there are some people from vendors here. So how nervous would they be about sharing those simulators? Because I think that details of their hardware are encoded in those simulators. No way? Yeah.
Can we share the microphone first?
Yeah.
I mean, we do certainly have simulators for the hardware we build. I mean, that's like, especially if you want to build firmware before the hardware is really ready, you need that. So we always have that, but this is my personal opinion, but I don't see the company sharing those simulators ever with anybody else. This is just the IP, this is just an IP question. So that's a very difficult discussion, I think.
Yeah.
From my point of view.
What about if they got integrated and ran the tests themselves on the simulator, right? Like, I'm just as an idea, right? I don't know if it's really practical.
They keep the simulator instances on their premises.
Right.
The question is, can you escape the simulator? Probably not.
I mean, I'm not really qualified to answer those questions. If the company would be good with that, I'm like, maybe I don't know. But it's also I mean, simulation is also very slow to some degree. Like we're talking magnitudes, like in some cases, slower than emulation. Like it's really slow in some cases. So I'm not sure if they're willing to share the limited, like we only have a limited amount of time on those simulators for our own stuff. So it's going to be a hard discussion sharing that time with somebody else running on our simulators.
So there's different kinds of simulators. Some of them can run on regular desktop machines, but they are very slow. And that goes up like closer to the hardware, up to FPGA, which are fast, but very limited in availability. And then regarding the security, Red Hat gets vendor hardware, which they don't want us to talk about that it even exists. So like how the vendors would be comfortable with sharing it with the entire world that it's running, it's available in the kernel CI, even before they have that hardware. So
that's even like yeah. I mean, like at all, it would only be possible after the hardware is available, and like the other way around.
And it's been properly through the PR machine and everything.
I mean, like but like that's what that's a no-go anyway. But I mean,
Well, it's an interesting idea. Maybe somebody will be brave enough, or some open source hardware maintainers or developers.
It would be cool, definitely. I mean,
maybe for open source hardware that could happen.
I think for these sorts of things, it's always important to think about what is the goal that's being achieved with using these simulators, right? Yeah, there are multiple different kinds of simulators. You've got the cycle-accurate simulators that are ghastly slow. You've got something that's closer to QEMU. And I'll note that in the early days, in general, the hardware vendor is interested in just simply getting the box running. Right? And so presumably the people who will have access are people who are writing the BIOS, people who are writing the device drivers to enable that hardware. They're probably under NDA and may very well be getting paid, through some sort of contract with Red Hat or Collabora to do that early Linux bring up. And those people will have access, and they will probably be really focused on just, can I get the thing to boot? Which I suspect is a little bit too early for KCI in any case, right? And I would expect that by the time you get hardware, we can talk about whether it's DVT hardware or EVT hardware or PVT hardware, which will get progressively more available. At some point, when the hardware vendor is even willing to disclose that this sort of stuff is available, then the open source people will have access to that, right? I mean, I worked with folks at IBM who were working on the Power 7 architecture before it was released. They were in the Linux Technology Center. They had early access. And they actually were able to do something really cool, which was on the day that the chips were announced, like the Linux kernel drivers were ready because they had early access. But, I suspect that's a little bit out of scope for what we're probably going to be primarily trying to achieve with KCI. And, I suspect the hardware vendors who want that, who want early Linux bring up, will be able to reach out to the companies who are doing that work. So.
Okay, guys, we ran out of time. We can continue in the corridor. There's already people queuing up for the next thing. So let's get moving.
Thank you. Thanks so much.
Thank you.
Oh, no, it's all right. Yeah, it's okay. I almost missed it myself. So, yeah, doing all right. Good to see you too. I don't know if I wasn't asking, I'm sorry. I did a quick change on you. No worries. Yeah.
Oh, that's right, yeah, you're up to the next.
All right, everybody. Thanks for making it to the last session of the conference. Everybody survived. Yeah, so we at one point had been thinking about trying to schedule talks during this session, but also felt that it might be good just to have some open space for folks to discuss topics that they thought were relevant from the earlier microconference or was not able to come up during that time. So we kind of have it as unscheduled or unfocused, I guess. So it's kind of whatever folks are feeling like bringing up and discussing. So if we don't have anything, we'll just point to somebody and make them give a talk. So, anything anybody feels like was worth continuing discussion from the microconference? There's not a lot of us, so I can easily single you out. So. John, you've been quiet. I haven't heard much from you during this one.
I've been mostly doing stuff in the hallway, right?
Here, let's give you a mic.
Yeah, I've mostly been doing stuff in the hallway, right? So after the graphics session we had on Wednesday, I've been working with, say, the Qualcomm guys to refine the DMA buff heap stuff. So they presented that as part of the Android track today. So that was revised, and we've continued designing. So we kind of plotted a plan about like adding metadata potentially to the DMA buff, so you can tag it as it's protected. So like whenever anyone imports a DMA buff, they would know it's protected. My proposal is actually that you have this FD2 DMA buff as a new alternative to support metadata. So if you give a tagged DMA buff to someone who doesn't know this because they haven't updated their driver, it would actually fail importing the DMA buff, because it doesn't know how to actually handle the metadata that it's present. Because then you would get away from the problem that was mentioned in both sessions, I think, about like user space able to crash the system.
Yeah, that's a concern. So,
yeah.
So one of the things for user space being able to crash the system, the idea is that if we were, user space obviously can't map a restricted buffer. If the buffer is mapped to the hardware, or is requested to be mapped to the hardware, at that point, doesn't seem like the hardware would be able to check the buffer without having to go through.
Yeah, so if you say,
if it was just straight on.
Yeah, so the metadata is controlled by the kernel, right? So yeah, the heap that allocated and did the magic would set the flag, right?
Okay.
So if you import it into anything, it should actually check the flag and configure whatever they need to do that with their hardware to actually access the buffer in protected mode. Yeah. So that should avoid. So if you say incorrectly give some, let's call it normal buffer, it would basically do the normal as it would reject trying to write to that memory while in protected mode.
Okay. Sounds all right, but Submitter TJ. Yeah, so there's a question. So I want to finish this one little top that they had. So I definitely would pull in TJ and Submit and other folks on that as well. So. Yeah. Yeah, I know they did. That sounds great, so thanks. So Neil, are you still online and wanting to bring up a question?
Yeah, I'm here.
Okay, sorry.
I just wanted, yeah, hold on. How do I, okay, there we go, buttons. Hi, Neil Gompa. I do stuff on the internet in open source things, whatever. From the Android perspective, I don't think y'all know me all that well, but I was very interested in some of the stuff that you guys talked about in the Android MC earlier today and a bit yesterday, particularly around building an AOSP community as well as the generic bootloader stuff, centering around using UEFI and stuff like that. From the perspective of someone who has previously done work in community AOSP derivatives, as well as now operating in Linux distributions and doing things like having Android overlays and building things like that, I think it would be really exciting and interesting if Android actually does move in those directions of like, from the device perspective, I own a bunch of devices. I used to do a lot of stuff with it and put, custom ROMs or whatever. Encouraging that there is a path for people to use the devices that they have for running, community builds or aftermarket builds or being able to do development on AOSP itself. I know that some of the device makers are actually quite good about doing this. Obviously Pixel, and I think a good chunk of the Samsung devices as well, but like making this a general point of engagement with the larger Android hardware community to do stuff like that, and making that available even if it, like, for example, cripples protected content support or whatever makes them feel comfortable with enabling that capability. I think that is a really great thing to do, and I'm also very excited about the generic boot stuff, because one of the larger challenges for getting people to be able to do stuff successfully in AOSP is actually just doing the hardware bring up stuff and being able to test and multi-boot and all this other stuff. And in a world where it's possible to say, okay, I can have 2 builds of Android running on my device, and I can switch back and forth, and I can see what changes or differences or whatever, that is empowering to a very high degree, in the same way that when I'm working with when I'm working in Fedora or OpenSUSE on my machines, or working on Fedora Sahi Remix for Apple Silicon Macs, that I can do this kind of thing. So if this is something that you guys, as the Android community and the Android developers upstream at Google do and push for, I think that there's a really strong opportunity to bring together all these factions and fractions of Android folks back into a larger, stronger, true community engaged project. I hope that that's a goal that y'all want to have, and I just wanted to say my piece about, like, because I wasn't awake when it happened, because I'm over here stateside, and that was like 3 o'clock in the morning. It's like, no way I'm going to be awake for that. But I just wanted to reiterate that I feel that it is extremely valuable and important, and I'm really happy to see that that people are starting to care about this within the echelons of the Android developer teams. So yeah, sorry, this is a little bit babbly and unstructured, but I just wanted to be heard on that, even though, whatever.
Chris, did you want to respond?
Yeah. So 100% that's part of the concept that I have. Concept sounds a little bit, it's not a concept, it's a vague idea. But it all comes down to the fact that at the moment, we don't talk to each other. It's got to be better. The more people talk to each other, the more focus there is, the better. So that includes the developer communities, or the people working on, I don't know, Lineage OS, or the stuff that Vero does with maintaining old hardware. All that stuff is fantastically good. We should encourage that, because that's where people get their skill set. But also, I would also look at the kind of professional community. So, for the last 10 or so years, I've been addressing the professional community and talking to people working in AOSP and building it into products of all kinds. In particular, over the last 5 or 6 years, into automotive, into vehicles. So again, these are isolated communities, and if there was some kind of focus, I kind of feel that they would latch onto it, and that
I 100% agree. One of the things that I struggled with when I was involved in this like 10 or so years ago was that I didn't really have a good place to talk to people. I didn't have a good place to get feedback, and I found the process of working with the Android code extremely difficult, to the point that I just kind of didn't bother because it was just too hard. And to be fair, the documentation around that stuff has improved over the years, I suspect because more and more OEMs and more developers who have no idea what the heck they're doing need help, and so that has necessarily improved a fair bit. But it's still really difficult, and the requirements are kind of high, and it's just something that I think is going to be one of those long-term, large-scale endeavors to incrementally improve. But like maybe things like having a Gen Pop mailing list or a matrix room and some centralized effort, GitHub, GitLab, or something where people can actually directly engage with each other and collaborate. Because it feels like all the, it feels like all the current avenues are either partially closed or ignored, or you're like the community hobbyists, as well as the external professionals that are not part of the core OHA, they tend to be ignored, which I feel is a detriment to the larger Android, the success of the Android community in evolving the technology.
Exactly. We will not be ignored.
Yes, right. I mean, like doing Waydroid stuff in Fedora has made it really clear to me that this is still a problem. That this is a problem that needs to be improved.
It is.
That needs to be dealt with in some way.
I don't want to go on too much length of this, but it comes down really to, I mean, the pieces are all there. It's really, at least at the first iteration, it's just a question of joining the pieces together. So this is stuff that I do. There's the stuff that the Android developer, AOSP developer community does. There's stuff that Lenaro do. If that were somehow integrated into a single entity, that would be a great thing. And if we could do more meetups like this at other conferences, so I'm thinking maybe FOSDEM in Brussels would be a good place to do this. Maybe somewhere in the USA.
And Scale in the North America. Scale maybe would be a good place to.
Yeah. Are you volunteering?
I don't know. Maybe. I don't know if I would consider myself plugged in enough to the Android world to be able to be successful in this, but like
it could be done.
I go to Scale on a regular basis, so I would definitely swing by at least.
It would be a great forum to do that kind of thing. Yeah, for sure. So yeah, this kind of thing. That's the extent of my vision, to be honest.
And to your point about the bootloaders, that's another area where I'm personally excited, just from past history working on some of the dev boards and that aspect of kind of keeping things continually updated.
Just
when you
getting the damn thing to boot is
well, even
a huge problem.
Yeah, I mean, when you get a board that is usually a SoC generation behind or something like that, the bootloader's a little older, and keeping that up to date with AOSP was always a big challenge. And so, it's an area that I'm really excited to have moving forward. Anybody else have?
Honestly, I think that piece will just make the community feel way more heard than anything else. Like fixing the boot up sequence stuff and having the generic bootloader is going to make people, lots and lots of people, very happy.
That's exciting. All right, so we're about 15 minutes in. Is there any other topics that folks want to bring up and discuss? Beryl, you want to come up or grab the mic?
I'm sorry, there you go. So one thing I think we can do on the technical side to help make it a bit easier for people to get into it is make things a little bit more modular. For example, I've been trying to build a non-Android Linux system on top of Bionic for some experimentation. And it turns out that in order to even build Bionic, you have to pull in about 2 gigabytes worth of source code, because even something as basic as a libc has dependencies on the archive manager and stuff, because it needs to look into files and stuff. So
one thing I know Roman Starenko at Glowdroid has a project that he's used for some of the CI that's done for the DRM hardware composer on the free desktop GitLab, where basically in that kind of very limited free desktop, GitLab CI, they don't have a lot of CPU time. So doing things like just build validation as part of the CI would be really difficult to do with all of AOSP. And so he has a project that kind of pulls enough headers and stubs from AOSP to kind of allow you to build that one project separate. And so you might want to take a look at that. I mean, it's one of those things where, it's only used in, I think it's used in Glowdroid more. I don't know a lot of the details there, but the DRM hardware composer uses it for its, upstream CI, basically. So
that is certainly a good start, and we should try getting at least some support for this upstream.
Yeah, I think finding a way to do it kind of in the community might also be a helpful route. So. Anything else? Amit. Ooh.
So I have discussed this one in the hallway with some of you already, and this is not Linaro specific. So my interest is in doing ARM64 native builds of AOSP. So if someone is interested in collaborating on that, so this is not Linaro thing at all. I mean, so it will be my little pet project in the background, maybe.
Weren't there some outstanding patches that you all had submitted?
I have not even started yet, sorry.
Okay.
So, but I want to look into it at some point.
Okay. I thought somebody, Lennar, had submitted some patches that were needed for some portions of that. Oh, okay, just CTS and BTS, all right.
Yeah. And the other one is AOSP on desktops. So last week I read the multi-window support, and then I realized that can I use it? Can I run AOSP on my laptop? I know Android x86 existed long time ago. I have run that, I have tried that. It worked fine at that time, but now I want to start again. And again, this is from X-Elite point of view, the new Snapdragon chipset point of view. So it could be x86 as well, it could be RISC-V as well, but again, something which, if anyone is interested in, again, non-Linaro stuff, because we are busy with other things, but if someone wants to collaborate on that. Again, something which I have not started yet.
So AOSP on desktop, meaning you want to bring up AOSP on desktop?
On laptops, yes.
I see.
I think bring up is fairly doable. Actually using it. Actually using it as a laptop or desktop OS.
You need a lot of laptop drivers then. Then you need to support all the drivers for laptops and.
So I will start with the generic Linux distro and start adding the pieces. So we have experience of running mainline Linux without Android patch set, AOSP on mainline Linux. So we know that we can run AOSP with just plain vanilla Linux kernel if you have the. No, I mean, so the features which I'm interested in, the desktop thing, right? Wi-Fi, Bluetooth.
Still need AshMem.
MemFD, I'm okay with MemFD.
Oh, okay, yeah, I guess you could do the global switch on that.
Yeah, I can do MemFD and yeah. So can I
It's
ask
what we
you a
did
question?
for Waydroid on Fedora. Like, we don't have AshMem. We just have BinderFS, and we have the Lineage OS build set up so that it uses the MemFD thing instead. Seems to be fine so far.
Can I ask a question on AshMem, since AshMem...
Oh, go ahead.
Yeah. So I'm okay with AshMem and the AshMem as a base and MemFD as the optional feature which you can enable. Can we enable it in a I won't say production devices, but as a secure SE Linux enforcing mode?
So,
should we start looking into that?
It's something I would be excited to see progress on. It's one of those things that's been on my to-do list for a long time. There's, as far as there's been, the last kind of blocker for it is the compatibility on MemFD for AshMem ioctls, because tasks that currently can't access dev AshMem directly, like that's already been locked down, but they may receive an FD that they assume is an AshMem FD. And so it's actually a MemFD, and so they then call ioctl with AshMem ioctls on it, and they'll get errors. And so we need this little bit of compatibility on MemFD, I think, before we can make that switch. So that's been kind of outstanding for a while. I had a really test patch. Some folks have been looking at it, but
Yeah, sorry, that was on us.
No.
We were supposed to test that. Yeah.
But yeah, so I think the deprecation is still something we'd like to see for AshMem, but it's.
But I've seen the patches rewriting the AshMem driver in Rust now.
So yeah, I mean, this is kind of, I feel it's my own responsibility. So I've not managed to deprecate AshMem yet, and so it's still there. And meanwhile, we still need to carry it in the Android tree for support, across the board. And so the rewriting it in Rust allows us to have kind of a safer driver in that interim time period. So it is one of those things where I still want to see that deprecated. Alice has been doing some really cool work getting a lot of Rust stuff going. So yeah,
I'm going to ask a dumb question here. Why aren't you deprecating it without removing it? Like, deprecation doesn't mean removal. Why don't you just go ahead and say it's deprecated and tell everyone to buzz off on using it?
Well, we still need the support for this ioctl. So basically, the
supporting it is one thing, and keeping it around is one thing. But telling people to stop adding more use to it is important before you even get to the point of getting rid of it. So, why not declare it deprecated now and just call it a day?
Well, so we have already.
Deprecated is not removal.
I guess so. We've already removed it from being accessible, so it is already in a way deprecated. But these compatibility, especially for existing binaries, has to be preserved, and so we have to maintain it at the moment.
Yeah. So why don't you just go ahead and formally actually say it is deprecated, and start telling people that. Start looking at fixing your stuff to not use it, because otherwise this problem just keeps dragging on and on. I remember the first time that I heard you guys talking about getting rid of this in, 2018? We're now into 2024. So
it was probably earlier, but
hey, I'm being generous here.
Yeah. But yeah, no, it's a long-running issue. I know Joel, who isn't in the room, but at the conference here, did a lot of work to get that MEMFD infrastructure in place, and getting that last couple steps to switch over to it, I think, is something we want to see done. So, but can't say any particular timeline.
I have an observation. So I did attend a couple of talks related to boot time optimizations, and so it looks like some of the experiments which we do in Android ecosystem using Perfetto tracing, right? So using Perfetto configs and Perfetto tracing, it looks like most people are not familiar with it outside of the Android. Like for instance, they brought up some of the known things which we do day in and day out. So it'll be good to see, I think I did discuss this with you offline a few months back. It'll be good to see how we can have this learning from Android Perfetto to the holistic ecosystem.
Yeah, no, I've been definitely hyping up Perfetto and bothering various scheduler maintainers and things like that to try it out. So yeah, it's one of those things where definitely inside of the Android ecosystem, it's just such a useful tool, and it's able to communicate, problems in just very simple visual ways.
Because even if when I showed some of the traces, they don't really correlate to understand. It takes time to actually understand, right?
Yeah. I mean, there's so much you can do with Perfetto.
Exactly.
Like I only know a little teeny bit.
Even
so I have a lot to learn,
me too. But even for me to make them understand what exactly it is, it's tough to correlate until the other folks also have worked on it.
Yeah.
So I think it'll be good as we in Android to have more learning or some kind of a developer blog, or use some of these micro conferences to show some of the use cases. That will be helpful.
So I know I've got a gist on GitHub that kind of walks somebody through how to use Perfetto on a bog standard upstream kernel, and just on a normal Linux distro, or Linux, classical Linux distro. And then I've been trying to share that a little bit. I know Sarvana, I guess, linked to it in his presentation at the Power microconference. I'm continuing to try to hype it as much as I can. I can put it in the notes. I can do it. Like, just let me know. I'm definitely eager to get more people to use it because it is such a really cool, powerful tool. I have a demo if people want to see later. I can walk you through a cool little step.
Yeah, I think we should. In retrospect, I think we should have had some kind of a tech talk from Android side on the tracing track. That would have been good.
I had invited some people to do so, and they just had too much going on at the time.
Yeah, I mean, I thought I could have done my talk on one of those tracks after visiting there. Yeah. But yeah, that's one of the observations I had.
Yeah, no, I definitely, want to spread the religion of Perfetto. So it's go ahead.
Cool. Yeah, great idea, Perfetto. So, yeah, show me the code. Make a package.
The nice part about it is, so there's already packages that are on GitHub that you can download. You don't have to build it yourself.
Okay.
And then the rest of it is all at perfetto.dev. I can't remember. I think it's perfetto.dev. Yeah. So.
And is there a Yocto package for it?
So there's x86 and ARM binaries.
I want to build it from source.
Maybe not Yocto. So I mean, it is open source, but there's pre-built binaries. I don't know about if it's being pulled into Yocto. I don't know what you need to do to integrate something into Yocto, but it's a public project.
What I'm saying is, if you want people to use it, make it easy for people to use. Engage with the community. Talk to the Yocto people. Talk to whoever, and say, hey, Liam, have you thought of using this thing? I'm saying this is on you.
No, it's
all of us can do that.
Yeah. Well, the other part is
well, it's on all of us. Yeah.
I can see the point, and
pushing for Perfetto earlier this weekend.
I think Annalena Marks did a really good talk on that.
Yeah, really? Yeah, that's what I'm referring to. Yeah, there was a push to use Perfetto.
Yeah. So
within the Yocto community.
Okay.
Yeah, I know.
Yeah. So I'm not very familiar with Yocto, so that's a gap on my side. I've been mostly focused on trying to get it on spots where kernel maintainers are focused, so because I feel like it's a really good tool for the scheduler stuff initially. I think it's a good gap to fill. So.
Perfetto is also in the process of being packaged in Fedora, and so it should be available in Fedora and EPEL fairly soon as the package review gets completed and things like that.
Yeah, that would be great.
If you're using CentOS, RHEL, or Fedora, then you should be able to get it fairly easily soon.
Have you had much experience using it in those environments, out of curiosity?
I've only started kind of using it. I've done it the bad ways before Perfetto, so like I'm just, it is definitely an improvement on how to do this without, rather than doing it by hand. We'll see how it goes. Like I would like to see, like in Fedora, there's been a general trend towards trying to enable real-time tracing, profiling, performance improvements, and stack analysis, all these other things. So we're starting to pull in all these tools to make it easier for people to do this development, the kernel level, at the desktop level, at the server architectures, all this stuff that has typically only existed on other operating platforms or in specialized cases like in Kubernetes with the Jaeger and Open Tracing with the Go stuff. We're trying to make this more broadly available across the board, and so we want to make Fedora a good development environment for those sorts of things and for people to be interested in that kind of that part of the application development cycle, right? Like performance is important.
Yeah, that's great. I know the Perfetto team is super responsive to a lot of issues around trying to kind of broaden it out. So it's one of those things we're definitely, as you work with things and integrate, if you need contacts, please reach out. Happy to try to introduce.
Oh, for sure. I will definitely reach out as needed. Thanks.
Anything else that folks want to bring up? Actually, we're getting close to time. We've got 10 minutes now, so how will we squeeze it all in? Go ahead.
Okay, I'll take one.
Or no, go ahead and
Okay, so the favorite topic for these kind of things is, what about RISC-V? It was in the CI chain for a while, and then it got removed. I know nothing about this apart from that. Anybody have any comments, any thoughts? Is RISC-V even worth doing? What's the feeling of the room?
Feeling of the room, I guess. We take the temperature on that one, or is that...
Well, RISC-V is still a mess, so there's always that.
Yeah, which is really the reason. So there's a lot of interest. There's a lot of things happening. We do have RISC-V works with AOSP, and there's projects with very distant release dates. And so we're just not close enough, and it's not mature enough with our partner community yet to have it kind of be real in there. But support for it's there. The kernel work that you observed, there was some kernel stuff that came in and then went out. And really what was happening is we didn't have anybody really maintaining it. It was sort of like flung in with thinking that it wasn't just a fly-by-night submittal, but it was. And so, but kernel work is still being done. It's being done by Sci5 and Revos and stuff. So it's not dead. It's just that first set of submittals was premature. But there are folks using AOSP with RISC-V. It's alive, and there's going to be products. Just don't know when.
A lot of stuff around, agreeing on the right extensions and things like that has taken time. Then finding hardware that has the extensions that people agree on is another, it gets to be slow. Amit, you had something?
So this one is on the dev boards for Android project, which we discussed in last LPC as well. So we were having discussion in the hallway and over the emails regarding the hosting of this project. So since there are no topics left, I thought that we can
Do you want to come up here and do it?
No, I can.
No?
I mean, I'm fine. So I proposed hosting it on GitHub in my ELC talk. Kevin, I think, was okay with that. Chris has a few more suggestions we can discuss if there is interest in that topic.
Go for it. I'm interested. Yeah, go for it.
So for us, so right now it is hosted. So this project is a community of dev boards and AOSP system developers outside of AOSP. So the people who maintain or run AOSP on their respective dev boards, or it could be devices, it could be the Cyanogen mod style phones, it could be anything. So right now, so we started this project last year. Right now it is hosted on dev boards for android.linaro.org. But the concern on the hosting is that Linaro is usually associated with ARM architecture. So which is, I mean, we are okay with that. So, but to maintain the vendor neutrality, should it be moved to a more neutral place? And if it is, then where?
Okay, so yeah, it should be vendor neutral. The whole idea of this should be vendor neutral. So not linaro.org, not baylibra.com or whatever. So my suggestion is, why not use AOSP developers community dot whatever it might be. Since it's a domain that's out there, people know of it, and it is, as I understand it, it's basically a document which has pointers to other things. It doesn't actually have to host the code itself. It just has to be a central point where people can go to. When you say, hey, go to this point, go to the devices pages, da-da-da. There you'll find support for Qualcomm, for TI chips, for MediaTek chips, whatever else is out there.
So I think if I understood the purpose of the dev boards for ASP project was that it is a little more opinionated and kind of organized than the loose collection of pointers to HALs and things.
Well, no, I agree. So it's not just a question of, oh, here's a repo which we tested once and it worked. So it has to be legit. There has to be some support behind this. There should ideally be some CI chain here. There should be some test results and whatever. It should be legit. It should be as upstreamable as, well, it should be in a state where it could be upstream to AOSP if that was, I'm not expressing this particularly well. It should be of the same quality as the stuff we have in AOSP, is what I'm trying to say, but not in the devices directory from AOSP, because I'm getting the feeling that the devices directory in AOSP is basically frozen except for the Pixel devices. And I'm fine with that. I don't have an issue with that. I think in many ways that's the wrong place to put stuff.
So I wouldn't say frozen. I think it's mostly the things that we want to be concerned about is making sure that the boards that we do have in there are well supported.
Yeah.
And are kind of keeping currency.
But frozen in terms of putting new boards in there. There's no, as I understand it, no appetite for putting new boards in there. And if you did, where would you stop? You could even ask the question, why is it those particular bunch of boards? Because it's a fairly random bunch of boards, to be honest.
In those cases, I mean, I think it's because we've had commitments from folks who are working on those boards and keeping them current. And so that's, you know, I wouldn't say that we're closed to new boards in that space. But I think it's also very difficult to get the level of commitment to support them.
It kind of would.
That level of commitment is not documented anymore. Like, what does that mean? What are
I'm
also,
not,
like, you know, also, why isn't this stuff like going towards the upstream generic enablement in mainline Linux and things like that? Like, most of the enablement for these boards are not actually specific to AOSP in themselves. It's drivers and device trees and weird little bibbly bots to make stuff like come up.
At least for a number of the boards that are in there, they are pretty upstream aligned.
Yeah, I think there's two categories of things here. The boards that are not mainline or the kernel support for boards that are not mainline is yet a different level. But for boards that actually have mainline support, like what the criteria is that they would be then accepted into the upstream AOSP sources is not defined anywhere, right?
Yeah, I mean,
and
I think they require some discussions and negotiations, I think, to feel out the specifics. But
and on a related topic, in speaking of testing, I was wondering if there's in terms of like kernel CI running Android common kernel type stuff, is there one thing we're not doing is running CTS VTS on these types of upstream, and we probably shouldn't because that's not a final product, but is there some subset of CTS VTS that might be defined as we could break out as a smaller test suite that we could run on Android common kernel in kernel CI on some of these boards that actually have AOSP support? Like, is there some sort of thing there we could do in terms of testing that might help establish that another set, like you were saying, what's the acceptable level of criteria that we could have? Yeah.
So maybe can I have you send me an email on that? Because we, you know, go ahead.
We've been talking, so AOSP kernels are all in kernel CI right now with minimal actual testing. So right now the way we use kernel CI is really a kernel hygiene check to make sure we haven't broken all the other kinds of builds, and that people who are downstream of us using it for non-Android things, we're not breaking them. That's how we've been using it now. But we've been talking a lot with Gustavo and the others on the kernel CI team in the last few months, and then here this week, about doing some of the kinds of things you're talking about. But right now, while they're in the middle of going to their new architecture and bringing up a lot of stuff, getting Android support and stuff to run Android workloads and boot Android things they really want to do it, but it's kind of off the plate for probably this year, maybe the next year. And so the conversations have been more around what kind of testing can we do with these kernels that would be meaningful testing. So if you talk about a subset of VTS, there's the LTP suite and the K-self-test suite. Certainly we could be running those. And there's probably a bunch of others who've talked to them about, maybe running some performance workloads, looking for regressions, that sort of thing.
And so, yeah, there's some work internally that runs tests. So trying to align up which ones are expected versus not expected to pass on the, pre-LTS kernels would be something to sync on. But I'm happy to try to make that connection. So. Anything else on the dev boards? So as far as was your questions, I guess, answered?
So if I understood the discussion correctly, then GitHub it is, or?
Is that sufficient for the actual code hosting that you want to do?
So the code hosting, everyone is, so all the board support vendors are doing it separately. Bailey is doing it separately.
Okay.
Linaro is doing separately.
Okay.
If there are common hells, which we are working together, then we can host it on the same GitHub project. I would assume.
Yeah, I'd had some sense that the project was using Garrett and was trying to kind of be a full stack, and so I just didn't know exactly how distributed that was.
So yeah, when we started talking about dev boards for Android, there were two reasons. One was the trustability and testability of devices that support ASP and how can it be shown and proven. That was one. The other was to encourage newer developers that work with ASP to sort of be get familiarized with how ASP functions in terms of how you push patches, etc. And that's why we went with a Gerrit instance of our own. .linaro.org was just, I've explained to a few. It was incidental because we had to work with our IT help folks. And we are not very big, so. But yeah, for now, what we will do is we will use the GitHub community page for consolidating everything. And we will let everyone use whatever storage and hosting they want to use. And for us, we will do dev boards for Android because it makes sense. We have the setup already. Yeah, cool. And anyone who wants to probably experience how to submit patches, or we can help with, Gerrit submissions and +2s and all of that workflow.
Oh yeah. Okay, we're at time. We're past time. Thanks so much, everybody.
Thank you.
Appreciate it, and hopefully see everybody next year.
Absolutely. Let's do it again.
Bye.
All right. Not very loud, at least.
I'm surprised you're talking.
Trying to find the name of the guy at Google that I've already been having this conversation with. Yeah. He's put on another job or something. Okay. I don't know.
Okay. We're done. Cool. Yeah. No, I hadn't appreciated until we just So that's where we realized that most of the developers we actually interact with, the first thing is we are hesitant to push patches to ASP. And that is because there is a sense of git push or git Gerrit has a different workflow. Sometimes
all of traffic. Yeah, it's a whole new
But again, it is relevant if the intent of the developer is to push to USB. The intent is to develop outside and
Yeah, and so that was the conversation then. So then clean up do that in order to get stuff back in, we're going to establish this set of criteria. Hardware support, who's going to commit the software support, blah, blah, blah.
These are not toy projects, these are real projects that are used
It's still probably it's one of those things where,
but we're still people doing that.
I know there's been projects that have come up that just like make
But I would, you wouldn't want to say, oh, all of that has to go through your GitHub, your garage. Absolutely. Each one of those, whatever.
Mostly like if the setups do we set up for this, like that's like we're going to make them this long.
because even for us, even we started as a community thing, so we are incurring a cost on running it on and the more data that comes in, we can do some part as community for us. But if it goes beyond, we are not for profit. The part there is some work we can do for community, absolutely.
I think, yeah, okay. I think in my line, maybe I'm getting this right. There are two different cases here. There is the community-based stuff, which there might be 3 out of 5 stuff. This is a good example. And also the people. So let's keep that stuff. So there's that stuff which is relatively small and relatively contained. And then there's all the question stuff. That's the simple thing.
So even, I mean, and I think we should have this as a requirement even for adding more generator scheme information on your page itself, where things that we add, they shouldn't be dropped. So we don't want stuff that someone has done Android 10 sometime and then just stays there and does nothing. We probably need to have active maintenance for devices that get added and accountability. Yes, absolutely. There were some requirements. So for developers for Android, put together a few. I think one of them was that you should be able to do a CI and show that it is building and testable at least once a month. And there should be some contributions at least, once in 3 months. If nothing happens and no activity for 6 months, we will mark it obsolete or something. Yeah, I think those are things that sort of help people stay engaged with stuff that they do and not just, hey, we added this support and now you maintain that. We are not there to maintain stuff. We're there to help as a community, we're there to help from each other and solve common problems, but not, we've had that, we've burned ourselves with that a couple of times earlier, so this is very clear in my mind. We're not going to do this kind of maintenance.
Absolutely.
Hi, cool. I will see you evening session.
Walk back to my hotel and then we're on to do that at home and probably collapse. Oh, maybe see you later.
Probably. Yeah. Unless it's so full that we don't run into each other.
Yep, this one's still here. New meeting. Forget.
Oh, just join again.
No, it's gone. It's gone.
Oh, wait, I can get in. Well, I could log in on my...
No, but the room is gone, no?
No, the room's not gone. Oh, this one doesn't have my thing. Oh, it does.
Oh, it does. Yeah.
And then go to the server room. And what room are we in? 185?
The shared note.
Shared notes.
Yes. Oh, there indeed something.
Okay.
Okay.
Oh,
That's
there's not much there.
Okay.
Okay, but oops, what did I do?
Just create a file somewhere, maybe on the desktop.
Yeah. It's right here.
Oh.
Oh, okay. I just put it in the download file, but let's label it or something. So.
Yeah. Which is the rooms? 180.
Rename. 1.85 Friday afternoon.
Gentlemen, if you need it.
Oh, thank you. Yeah, we do.
This
Is it
one
locked?
It's Steve's, I think.
Yes,
the room is locked.
Let me see which number.
Yes, this is
yeah,
Steve.
this is Steve.
Okay.
Okay, so I think I'll head out to put this in the hotel.
Okay. Well, that's on there. There's a way to get to it. What I've been doing is I've been copying the shared notes files into the Google Drive
The shared note
of
files
the.
are saved on the servers. It's Soundwave.
Oh, okay.
So
But
not
it's really hard to find the right one.
Right.
Okay.
Okay, so now
So
we can.
I'll check the next room.
Oh, okay.
I think it's maybe the last one.
Leave meeting. Okay.